Good morning, everyone. Welcome back to the dive stream. This is dive 745 for ROV Sebastian, and we are currently on research vessel Falcor 2, somewhere in the southeast Pacific, offshore Chile. We are just beginning this dive. We're headed down to 2,757 meters. Yeah, we already saw one pretty cool ctenophore on the way down. And the location for this dive is called Mocha Island Seeps. There are some methane seeps down here. There are several, actually, sites around Mocha Island that have methane seeps. We're going to the deeper ones. Like I said, 2,757 meters. We're gonna, once we hit the bottom, we're gonna start mapping with our M3 multi-beam on board the ROV, and we're gonna do that for probably 2-3 hours. And after that, we're gonna start some biological and geological sampling on the bottom around some seep sites. We've seen a number of seep sites on this expedition. Very cool. Recommend you to stick around for that. And with me at Mission Control, our ROV pilots are stars of the show, Tyler and Mike. We have a member of the science party, Montserrat Gonzalez, our star of the show on the Chilean TV. And my name is Tomer. Some of you maybe have heard my voice before. I've been here for a while. And thank you for joining us. I hope you're enjoying a wonderful morning or afternoon or day or night or evening, wherever you are.
All right, good morning, everyone. Welcome aboard the Falcor 2, and welcome to the seafloor at 2,700 meters deep off of Mocha Island, Chile. This morning we are diving on a site that we imaged 2 days ago with our shipboard multi-beam sonar. We are going to conduct a M3 sonar survey from the ROV this morning to get our nice detailed map of the site before our colleagues descend to the seafloor and check out everything there. We selected this site because we observed a large bubble plume emanating from the seafloor in this location. We are hoping to reacquire that with the M3 sonar this morning and visit it later today. We used this strategy yesterday at a slightly shallower seep site at a depth of 2,200 meters and were successful in finding methane at the seafloor and seeping bubbles, methane hydrate, and a host of seep ecosystem organisms there. We are just getting the ROV Sebastian set up online here to do our mapping survey.
Level plumes.
Whoa.
That's awesome.
Oh, you got it on the big screen?
I got it on the big
Oh, nice.
screen. So we're down a normal person today.
Yeah.
The morning show is not the same without Sage.
Sage Scott sleeping in this morning.
Sage
Getting
taking
some
a
well-deserved rest. Oh, look at that. So we're getting set up to do mapping this morning. Once we're done and we descend to the seafloor, we are hoping to find a methane seep ecosystem. This is an ecosystem where the basis of the food chain is defined by organisms that consume methane and hydrogen sulfide. And we find unique, what we call chemosynthetic organisms at these locations that survive in complete darkness. We saw a great example, we've seen great examples of that throughout our expedition. A really nice example yesterday, it was similar depth, and that is what we're hoping to find here today. As Jeff mentioned, Sage is not with us today. It's because we are a little bit deeper than we have been for the beginning of this expedition. And with all instruments and vehicles that we're putting in the ocean, of course, what we have to be very aware of is their ability to resist the pressure of the deep sea. And so with Sage, we're taking it off today because we're a little bit deeper and we want to avoid exposing it to the pressures of this depth. So we can make sure we have it for the remainder of leg 2, which will take place as we move farther south in Chile. Start of line.
Start a line.
Start a line.
All right.
We're gonna be
What's that?
starting our mapping, and we're gonna do this line at 1.6.
Is that a seep already?
Is that-
Point 6, right?
Maybe?
Maybe? That's some sort of interference?
We were just on the bottom though.
I don't. That was weird. I
Um,
don't think we need to mark this site so we know exactly where it is.
Huh.
That was real strange.
that was really weird. Oh, yeah, maybe. It could have been the sediment in the water that we brought up. But it wouldn't have such a strong return.
Yeah, if sediment was falling off the bottom of the vehicle, it could have been that.
But then why don't we see that more?
I don't know.
Hmm.
We'll have to wait until the end of the survey
You'll
To
never
recross
know.
when we
this
come
line
back over
in
the
3 hours.
in 3 hours.
That was mysterious. We saw a little return there at the center of our M3 fan view that looked somewhat like a seep, but a little bit different as well. So we're puzzling through what that might be, and we'll be crossing over the site in a little bit. So hopefully we get a chance to see if there is indeed a real feature there when we resurvey it here later this morning.
I am,
Well.
whoa, I was just about to
Look who
say,
it is.
I am already missing
Oh
Sage.
my goodness.
Because
We already
We-
counted Sage out this morning.
Should still be
Sage
counted
is out, but that doesn't
But-
stop.
That doesn't
That's
stop
Scott.
Sage Scott.
Sage Scott is not counted out.
We just saw something on the screen, which would have been really nice if we had had Sage.
Yep.
That's, put that down in the log.
Don't miss it till it's gone.
Yeah. Can we sea log a sage problem? The problem is it is not there.
Yeah, that's right. Sage problem. No
I'll do
Sage.
that.
No sage.
Well, was the put in spot the
The put-in
The seep?
spot was not the seep. Seep should
Okay.
be in the middle of this line that we're on
Alright.
right now.
Okay.
If
keeping an eye out?
we dialed it in. No promises.
Oh.
So how do you want us to deal with altitude? What range you have a range, or just want to see if we can leave it?
Let's, for the cross line, let's just see leaving it. Let's see how the depth changes. This maybe is a little flatter than yesterday, but pretty unknown. The data looked good yesterday, though, for the most part. Like it was, even those little heading changes with fixing the depth, mostly just processed out.
Yes. There's a question in the chat about what does seep mean?
Oh, that is a great question. So we throw this word seep around a lot. And we kind of applies to a few different things. In its most basic sense, what we mean is a location where natural gas is seeping out of the seafloor. So we have gas coming out of the seafloor. Seeps can then have associated with them what we call seep communities. These are those unique chemosynthetic communities that where the food chain is based on consumption of that seeping gas. But not every seep has a seep community to it. So in its most basic sense, seep just means a location where we've got our gas coming up out of the seafloor. And our sonar systems are particularly good at picking up these gas bubbles coming out of the seafloor. So that's what we're using to identify these locations. And that's what we're hoping to see on the M3 survey this morning.
Yeah, the seep implies that there's some movement, like you're seeping methane.
Mm-hmm.
So you're transferring methane from somewhere in the sediment or to the surface and then into the water,
Mm-hmm.
which is kind of neat because we've been seeing seeps where there are no bubbles coming into the water, but there's clearly seeps with things living there and there's enriched methane. But yeah, the word seep is a pretty broad term.
It is, and there are seeps that are not just gas moving from the seafloor or moving from the subsurface into the ocean, but there are other fluids that can seep from the seafloor. Things like petroleum can naturally seep from the seafloor. We see that in places like the Gulf of Mexico.
There's
Warm water.
Water seeps, water fluids.
Mhm.
So then you start getting into another realm of hydrothermal vents, which are also seeping, but are temperature controlled and not always gas concentration controlled. And then they can mix. And
Yeah,
be at the
sometimes you can have both.
have them both at the same time.
Porque no los dos,
Yes.
as John would say.
What can you do?
It was only 2 hours. It was
Good.
only 2 hours.
ROV pilot musical chairs in here.
That's so funny. Who else? Sunny has way more piloting time than you.
You just staying on schedule, Scott? Or you
Yeah.
as your eyes just immediately opened,
Oh,
ready
no.
for your shift?
Yeah, I'm ready for my shift. I'm like, let's go. I just stayed on schedule. I woke up, like, may as well go down.
I figured out why I was having trouble waking up from my alarms.
Yeah.
Set to silent alarms.
Yeah. Those
Those are-
Why is that a seven?
work.
Seems
Well, I
counter.
had my watch is supposed to like shake my arm, which is I think in a delirious state. It's like, oh, I won't wake up my cabin mate by doing that, and then now that's not working apparently. So my alarm is not making any noise and not vibrating the phone or my watch. So It's doing nothing.
The struggle is real out here.
I mean, it begs the question, is it an alarm if it doesn't do anything? But hopefully that's sorted now. Oh, seeps. Seeps.
Seeps, two seeps.
Double seep.
Double seep.
There was like 2 there.
There was 2.
Yeah.
Yeah,
Still
let's
there.
put.
Big
Wait.
seep.
Wow.
I know what you
Wow.
mean.
That's
That's
strong.
definitely to the north.
I think it
It's
might be
north.
that mound. Still going.
But yeah, you're right. Oh my gosh. That's been opposite what I was thinking the
Yeah,
whole
let's
time.
put a waypoint down for that.
North.
North.
Yeah.
Okay.
Whoa.
Yeah.
No.
Oh my gosh.
Another
Look at the bubbles
one.
on the
Oh my
screen.
God, bubbles!
Bubbles in the screen was crazy.
Another waypoint at Nader.
Put all the waypoints.
Oh my gosh.
That
look
is
at the,
powerful. Wow.
Holy!
Oh.
Can we just go down and look at it?
That's cool.
That is so
That is an
I
I
think.
think
Look at the reverse camera.
My goodness.
that is a intense bubble stream. Oh
Wow. That's.
Wow.
That's.
man. That was a good one.
Wow, that was a bubble curtain.
Sage.
Is that a bubble curtain?
If only
It might be a
Sage.
bubble curtain.
Sage when we need you.
I know. Sage would be off the charts. He'd be going to the
Uh-huh.
moon right now.
Sage.
Well, jeez.
Well, sage might still be below when we poke the hydrates. There is that.
That's true.
Yesterday it made it up to, I believe, almost 6,000
Oh.
microatmospheres.
Wow.
That's a lot of poke derived
No,
methane.
exclamation point, dive here. Now.
Yeah, that's the place to go.
Yeah.
I would
Yeah.
say we picked the middle of the crossing
Wow.
line.
Yeah. Yeah.
It's almost as if Adam knows what he's doing.
Almost.
Almost.
I
but
don't
no.
want to say 100%,
No,
but that was
no.
pretty dang good.
That's always a team effort.
Watch it. That's going to be the only thing is that little mound. The entire survey is just around that mound with a giant bubble hose.
It is possible.
I'm so excited.
Oh, I thought you meant that was going to be the only thing that would go down. Huge
No, it
bubble
very
plume
well
and
could
like,
be just-
and like absolutely no biology. Nothing.
There might be
just,
no animals,
yeah.
no community, just a fire hose of bubbles.
Well, we know it's not the only thing because there's one to the
So there,
south.
That's
The double up job before the fire hose.
oh yeah, there is a little one.
Any other dive, we wouldn't call that a little one.
That's right, the little one. We've now reset seep size.
Yeah.
Hmm.
That was red hawk.
Tomer.
Living.
It was.
Did you put it?
I mean, we got.
Was there?
We
Did
got
anyone have time to
strongest
put its
return.
M3 observation, which is like
Giant seed.
giant seep?
I highlighted it. It was at.
You know, that's one of those surveys where we wouldn't have even needed M3 with how many bubbles were in the
Yeah.
camera.
Camera. Yeah.
I've never seen M3 glow like that either. It was
Aw.
like-
Yeah.
I haven't seen it glow like that.
Like a
either.
Roman candle.
It's grown up.
Yeah. I'm so proud.
It's come into its own.
I'm so proud.
This is really neat because we're only a couple kilometers away from yesterday's site.
Mm-hmm.
So we get a really close comparison and water depth change of what, 400 meters water depth difference, 22 to 27.
22 to 27.
Yeah.
Yeah. 27. 2,700 meters deep.
Yep. Huh. been on these plenty of these biology, not big component biology dives. Do you want to talk, Adam, about how new species are determined? I have an understanding myself, but I'm
Yeah.
not completely sure. You never really know because it takes a lot, right, to have a quote-unquote new species, right?
Yeah, we can try about this and maybe make it.
We're not the
effort.
not the biologist in
Yeah,
here.
I was gonna say the
You-
disclaimer is you're
Wrong
talking to
time.
geologists, but yeah, that's a really good question because obviously when you watch these live streams, you see all the amazing animals and organisms that are imaged with the ROV Sebastian, and it's of course we're seeing some really remarkable things, and sometimes even things we look at and go, "What is that?" We're not quite sure what it is, and so naturally you might think, well, maybe there's a chance that we're finding new species that aren't previously known to science, and that is a possibility. But the flip side is that it is actually quite difficult to define a new species. We were talking to our colleague on the vessel here, a biologist, Greg, and he mentioned it takes something on average like 13 years from when an organism is first identified to when it is formally sort of published and recognized as a new species to science. So it is a long and usually complex process. And one of the first steps to it, I think, is that these days, being able to define whether something new is new or not is often done at the genetic level. So that means sampling that organism, taking a DNA sample and seeing if, in fact, that organism's DNA indicates it is something new to science that hasn't previously been sequenced before, or if it is a variety of organism that is already known. And so that takes some time, obviously, sampling the organisms as we do here with the ROV Sebastian, and then taking those tissue samples back to a lab to process the DNA and define its sequence its DNA to find out if it is in fact a new species. And that's
That's
my
my
perspective
understanding.
as a geologist on that process, which I have never been
Yeah.
actually involved in myself.
I was surprised to surprised that it is the average to take that long, but then thinking about it, you know, there's a lot of scrutiny that has to be done and a lot of confirmation
That's right.
if you want to call something a new species.
Right. You got to
Yeah.
replicate your results and really put in a lot of effort on that. And it's the genetics really help. Before the advent of genetics, it was based on what they called morphology, which is largely what the organism looks like. What's the shape of its body, the shape of its structures? Are they similar to other organisms or dissimilar? And with the advent of genetics, we have a much clearer picture through DNA sequencing of the tree of life and how all organisms are related to each other, and in some cases can add new organisms to that tree based on genetics. And it's a much more, I guess, straightforward way of doing things than basing it on morphology. It can give you more of assurance that you, for instance, have a new species versus just a slightly different looking version of a known species.
Yeah, all right, because I think what we've been seeing, one of the things we've been looking at on this expedition is the tube worms, like a tube worm that has the little hook or the spike. You have tube worms, which have been observed in many, many places, and then there's all the little subspecies of tube worms. And is it a new species, or is it just kind of a slightly different looking version of the same species? So it gets into the weeds, but I think that's where genetics comes in and can, like, this is a different genetic makeup. Like, this is a different branch.
Mm-hmm. Yeah, that's right. Oh, we're getting pulled. Yeah, that's right. And one of the things that leads to the development of new species
Oh,
can
I can't. What's that?
We have an issue with cost.
Stop logging.
stop logging. Stand by.
Stop looking.
Roger.
Oh, that's me.
So did we lose
I can
that?
get a mouse over
No.
here if we want to.
So,
It's not me.
and then all just came back.
I just pressed the.
Okay. So we just lost all of our navigation.
What do you mean?
It's, the navigation dropped out, like it would if we had
Did you
lost.
get an alarm?
No, but it dropped out like we would if we had lost. I'm not saying we did lose NS, but that's how it behaved.
Yeah, that's subsea. That's interesting. I didn't get any alarms from the service. If you have it, I would say we keep an eye on it and continue.
Yeah.
All right, could you back
No,
back up a little bit, and then we can just start logging again? Maybe, 30, 40 meters or something.
Somebody's good. Oh, 'cause the boat. No, we just.
Ship's too
yeah.
close.
We almost need to keep going.
We can turn the boat around. Do we have to turn this
Oh, I don't
off?
have to turn.
We should probably keep going.
Yeah.
If you don't mind.
No,
Yeah.
I don't think we lost or anything.
No.
We can keep going. We can
Okay.
go stop and continue on the line and start logging again.
Logging. Because it would just take longer for the ship to stop and then to back up.
I get it,
For us
yeah.
to back up when it's just.
We're in the
across
cone
line.
of no-no. The cone of get away.
We're in the danger circle.
Is it on Jason? It's the donut.
Oh, there's something else. Oh, wait,
That's the gunk.
that must be the gunk. Oh.
Yeah, that must be sediment falling off of the vehicle.
Good to know.
We can make our own little
Yeah, it's really
curtains.
sparkly. It's pretty.
So we're shut off on that, I understand, right?
Yeah.
Can you go back and try on that home, see
Yeah.
not if there's alarm, if there's anything?
Yep. Absolutely. This is when the DVL was just coming in,
Yeah, that's a while.
and then this is when it's got it, and then we're starting tying things.
Say yesterday. Is Sage gonna be okay at the triple junction?
It'll be on. Yeah.
The triple junction is deeper than this.
Yeah, no, I know. So the reason why it's not on here, it would like 99% likely be okay at 2700. In Samoa, it went down 2700 or lower 4 times. It was fine. But then 99% is not 100%.
What?
And Jeff really wants it for the triple junction. So I conveyed that to him, and he made the call to pull it just to ensure that it's okay for triple junction.
Yeah.
And the deepest it went in Samoa was 3,200,
Which is close to the triple junction.
and it was fine. So
Okay.
What's the rated depth?
6,000. It's
Humidity? Is that the problem?
it's not quite humidity. There's a weird. This has been a really good cruise for figuring out how humidity actually kind of functions. But the longer it stays at higher pressure, the more likely just a little bit of water gets pushed through the membrane. Not in any way that it's like a pressure, like a failure-related thing, but you get just a little bit of water behind the membrane, and that can get into the fiber and kill it. So.
Ugh.
Out of a abundance of caution
Exactly.
and a
Mhm.
great desire to have Sage available in about a week and a half,
Yep.
2 weeks from now. No Sage, which is so sad from what we just saw.
It is.
That would have been the biggest spike ever.
Maybe.
That could have been a record.
25.
Was the hydrate poking yesterday? The the record for this crew,
Yeah.
this leg?
Yeah.
You poke the hydrate.
So we had a question in the chat about whether these seeps are volcanic in nature, and the answer is no. There is, as far as we know, no volcanic activity related to these seeps in this location. They the
End of line?
End of line.
end of
End of
line.
line.
End of line.
Now, the hydrothermal vents at the Chile Triple Junction, which will be visited on leg 2, do have a volcanic origin. There is magma underneath the seafloor that is melted rock, which is heating seawater under the seafloor. And that is being discharged at a vent, hydrothermal vent, and that is volcanic in nature. But seeps are different. They are not driven by volcanic activity.
Our nav dropped out on us. We're gonna start doing the north-south lines, try those at point 8.
North-south, 0.85.
Jules, could you zoom in on the waterfall display a little bit? Are we going up and down?
A little bit.
Are we being pulled, tugged?
Might be.
Yeah,
Yeah, that's because we were towing the boat behind us.
towing the boat.
Yeah.
It's amazing that like there's a couple real sweet spots, and then everything else he just introduces little bits. It's still fine. That's way under what we would see in the process data.
I think it's real.
It's real.
Yeah, it's real.
Those are sand
That's what
waves.
the seafloor looks like.
Those are little tiny sand waves.
This seep is actually just a mud volcano.
It could be.
Blasting
Oh,
methane.
don't say that.
Don't say that.
I mean,
I can hope it.
yeah, don't jinx it. I would love that to be the case.
I mean, that's
just
that's the last
I
set
gotta
I
chart.
dove on. We found new mud volcanoes every day up in Norway.
So you'll have to define what you see.
Dark
Oh,
line.
are these seeps volcanic? And then you're like, well,
Mud volcano.
mud volcano?
No, but yes.
No, but yes.
Not the way you mean, but we want to say the word volcano.
So yeah, you want
That's
to talk
a-
a little bit about mud volcanoes, Jeff?
Well, we can. It's which is a possible. You know, we could. That would be really neat if we saw a mud volcano. But mud volcanoes typically has seeps associated with the mud volcano. But a mud volcano is a constructional feature that is, instead of magma being erupted to the seafloor, you've got a mixture of mud and fluid coming out of the seafloor, which in an overpressurized environment. So I think it's like there's the weight of the earth, weight of the sediment is pushing down on a layer that then mobilizes and squirts out at the seafloor, erupts, and it starts having these flows and builds up and turns into these like these circular mounds that have flows of mud mixtures around them. And typically that mud, it's coming from a warm area and it's bringing up gas and other fluids. So you get seeps at mud volcanoes, but the mud volcano itself is this constructional feature that has a pretty unique morphology.
Yeah, I think they're called, mud volcanoes because they look like a volcano.
Little bit,
but
yeah.
the process is not volcanic in nature. There's no magma or lava. The appearance, it can look a bit like a volcano.
And the process is there is eruptions at a mud volcano.
Yes.
Or there's movement of material to the surface and then out away, moves away from some central spot. But definitely not magma. But those are really cool, and they are associated with seeps oftentimes because they're moving gas-rich sediments to the seafloor.
Yes. And we might expect to find them in this type of location because this is an active margin where we have two tectonic plates pushing against each other, really one pushing and sliding underneath the other, the Nazca plate sliding underneath the South American plate. And that pushing together those plates creates a lot of pressure that can squeeze fluids in the seafloor, create pressure that can push out at the seafloor as features like mud volcanoes and seeps.
Yeah, there's mud volcanoes too. That if they bring warm or hot material up to the surface, you get the situation where you can have hydrate that's in the shallow sediments being dissociated because you've warmed it up, which also creates more seeps.
That's a good point.
Because if anyone was watching the live stream yesterday, the ROV came across a bubble plume, of bubbles coming out of the seafloor, and then right next to the bubble at a carbonate overhang was a wall of hydrate. And maybe Adam, what is hydrate?
Hydrate is a ice-like substance. It is frozen water, but it's not exactly like ice that we're used to. It has a little bit different crystal structure, and what that crystal structure does is it forms a little cage that traps methane gas molecules inside the ice. And so it's called methane hydrate, and it is a mixture of water and methane frozen into ice. It exists at a certain set of pressures and temperatures. That's why we find it in the deep sea. It has to have relatively high pressures compared to the Earth's surface and relatively cool temperatures. And so at the bottom of the ocean, we're at 1 or 2 degrees C. That's what we were at yesterday on our dive. And we also have quite high pressure. And so that hydrate was stable there at the seafloor, and we could see it. And hydrate is a feature that exists most often underneath the seafloor in the open space between sediment grains in the seafloor. You can have large deposits of it in the subsurface that can store a lot of methane and therefore a lot of carbon underneath the seafloor. And one of the unique things we were talking about yesterday in regards to methane hydrate is methane hydrate was first discovered in a laboratory. It wasn't discovered in a natural setting. It was first synthesized in a lab in the 1800s. And it was not discovered on Earth in a natural setting until 1964. And so it's one of those unique things where we find it on the seafloor, but it's that occurrence, the realization that's occurring naturally in nature has been a relatively recent discovery.
Yeah,
I didn't know any of that.
Theoretically, it's one of those where you can know from the physics and the chemistry that if you have methane and the right pressure temperature conditions, it will form hydrate. So it was one of those theorized, like, oh, this could be something that we could find at some point if the conditions were right on the seafloor. And then as we got the technology
To get there, yeah.
to get to the seafloor, and when deep sea drilling was starting to happen,
That's really what it
that's
was.
what it
Yeah,
was.
drilling. Yeah.
That like, oh, okay, there it is. But you can think of, if you're having trouble picturing, thinking about methane hydrate, it's somewhat analogous to dry ice.
Mm-hmm.
But dry ice that you get at the store, you know, to make your fog machines, maybe you had one of these going for Halloween yesterday,
Oh yeah.
is that's CO2, right?
Mm-hmm.
So
And
it's
the line.
very, very cold
And the
CO2 that turns to ice, dry ice. And in that case, there's no water in that, right? Because it doesn't,
Turn in.
doesn't
Yeah,
some other,
that's just-
there's a little bit of water in the,
It's pretty much just frozen CO2.
yeah. Whereas methane hydrate has, what's, I always forget, what's the,
Cross line.
It's 12 molecules of water to 1.
12 to 1?
I think so.
Yeah, so for every one particle or one methane, you get 12 water. So it's actually pretty good at grabbing water too.
Yes.
And one of the limiting factors you can get in methane hydrate formation in the sediments is your availability of water.
That's right. Yep. You have to have sufficient amounts of water for the hydrate to form. Another thing to note is when you form methane hydrate out of seawater, as it freezes out, it will not, the seawater will extrude the salt within it outwards. You can get elevated levels of salinity as hydrate forms because it excludes the salt as the hydrate forms up.
So you can get very salty
Mhm.
areas.
You can get like little brines flowing out of those areas.
Or on the flip side of that is if you're looking at the pore fluids in the sediments, if you're having hydrate dissociation, your pore fluids, or your fluids that are inside the sediment, between the sediment grains, can be
And
fresh
what?
water
And
or
what?
fresher.
That's right.
So it's an indicator that you've got hydrate dissociation. Is that, oh, well, seawater has one concentration of salt, but if you're seeing the
Training.
very fresh water in the sediments, either you have migrated fluid that's
Top of
fresh
line.
from below, or you're having hydrate
Sure.
dissociate and essentially putting fresh water into the system.
That's absolutely right. And as someone noted in our chat, one of the most common things you
Oh, it's one of the worms.
you see.
It's a floater. No.
Oh, we got a worm. Uh-oh.
We got a map. We got a map. Right? That was on, yeah. That was on Greg's to-do list.
I was gonna ask if there's I slowed it down, so he's going faster than us right now. I guess so it's.
Yes, as noted in the chat, if you recover methane hydrate, it is possible to light it on fire because it contains methane that's being released, and that methane will burn. That is, you'll see pictures of it. If you were to look for it online, you'll often see methane shown as what appears to be an icy substance that is on fire.
But it's not the ice that's on fire.
It is not. It is the methane gas that's being released from the melting hydrate.
Yeah, it's the
Yeah.
you don't light if you're. I've held methane hydrate in my hands and not lit it on fire, but you can pour warm water, on the hydrate, and it just fizzes. It just releases the methane as it dissociates in your hand. But that dissociating hydrate is releasing a bunch of methane as gas, and the gas is what it combusts.
Yep.
So it's pretty cool. It's the safer version of dealing with hydrate instead of lighting it on fire.
Yes.
Which is a no-no.
That is
in the
not
safety
something we
realm.
would do on a vessel.
But pouring warm water and holding onto it is pretty neat because it just starts going, which you can think of, oh, this might be making some bubbles if it was underwater.
Mhm. And there are organisms that live on hydrate. There's the hydrate worms that have been imaged before, living right on the surface of the hydrate. So it's very unique organisms adapted to live with this in contact with that hydrate material.
I should get the numbers off the top of my, should have them more readily available, but the storage of fossil fuel or natural gas in hydrate is one of the largest reservoirs. Right?
Yeah.
It's,
Really?
It is one of the largest reservoirs of carbon on Earth.
yeah. Because the amount of, it's very good at trapping
Yep.
methane,
Yeah.
mostly.
Not only does it trap it, but it's compressed under
And
pressure.
compressed under pressure, it
Yeah.
holds a lot, and the conditions at the water depths that methane hydrate we see are generally very stable. So it has had a long time to accumulate and not be released. We see releases of methane in our seeps, and we know it happens, but for the most part in the deep sea where methane hydrate has been observed or forms, it stays locked up in the methane hydrate.
Yes, that's right. And when we see seeps forming, that often causes us to ask, what is changing the temperature in this location? Or perhaps the pressure in this location that's allowing that hydrate to become unstable?
Yeah.
And that's a question that scientists are asking to understand why we find seeps where we do, why they're in some locations and not others. If in fact that seep is being driven by gas released from hydrate, which not all seeps are. Some are. Certainly the one we saw yesterday likely was, but not all seeps are the result of disassociation or melting of methane hydrate.
Yeah, there's a indicator that there is a state change.
Mm-hmm.
I like on like a longer time scale, if you have uplifted section, because you're, let's say, in a convergent margin, like where we are now, that over the geologic time you have sections of the seafloor being elevated through compression, and you could move an area of seafloor that was below the hydrate stability zone up to shallower than the hydrate stability, and then you can get a lot of gas release.
Mm-hmm.
So that's a long time scale. We're not seeing, we don't see that on observational time scales that we have, but you can speculate that you could move a large volume of methane hydrate into a shallower environment and release that methane.
That's right.
And so methane hydrate is also, maybe you could talk, Adam, if you got it in your mind well, for the connection to permafrost. Because permafrost and methane hydrate, we're kind of talking in the same terms. In the north, the high latitudes, as the climates are, as the climate is warming, and specifically warming a lot in the high latitudes, that is changing the state and having methane release in large quantities, like off of Alaska and the Bering Sea.
That's right. The permafrost, the areas where the ground is permanently frozen there, that permafrost can contain methane locked in the permafrost as well. And so As Jeff said, with warming conditions, you can see the release of that methane, and that can have consequences. We see things like more rapid coastal erosion where that permafrost is melting. We can see things like sinkholes, and we know that that is a place where a lot of carbon trapped in that, the carbon that's part of the methane, CH4, that carbon is being released out of that permafrost up into the atmosphere. The Arctic regions are currently the most rapidly warming regions on Earth, and so that's rapidly changing these zones where things like methane hydrate are stable, and that is resulting in the movement of a lot of methane from a stable place where it's locked up, what we might call sequestered, into being free gas in the ocean or the atmosphere.
Some just changing the carbon cycle conditions. If you've got your locked-in buckets, like in reservoirs, in hydrate, and then you have your free, like your gas phase, which is in the atmosphere.
Yeah. Yeah, I think not that long ago there was sort of a conception among scientists that once carbon made it to the seafloor, it would get buried under sediment piling up and essentially be locked away for millions of years until maybe those rocks were uplifted through tectonic processes. And what we're recognizing is that more and more there's these locations like Seeps where there's sort of this pathway for that carbon to come back out of the seafloor. And back into the ocean. So that adds some complexity to the global carbon cycle and some additional pathways we have to take into account when we model how that carbon moves through the global system and that carbon cycling.
Mm-hmm.
What else do you guys think will be released when the permafrost thaws?
Well, it's already thawing, so
Yeah.
just continued more of what is occurring now. But one of the kind of unknowns is with connecting permafrost state conditions that we know are warming high latitudes, low latitude, is that the permafrost is putting a lot of methane into the atmosphere. That's because the surface conditions are quite subject to change with surface temperatures. With methane hydrate, it is this largest, or one of the large reservoirs of hydrocarbons because it's such a stable environment. The deep sea is cold and the pressure is high, and those don't change on short time scales. But what would happen if the bottom waters warmed rapidly and had a measurable effect on the hydrate stability? A large release of methane into the oceans has a lot of chemistry effects. The ocean chemistry could change. We don't have a lot of clear geologic evidence that happens periodically or that's imminent, but it's kind of the amount of hydrocarbons locked in the hydrate is a bit of you want to know how that thing works, because if something was to destabilize in that system, it could have a very large impact on the ocean conditions.
Mm-hmm.
are there many organisms within the water column that process this?
Yeah.
Use it as fuel?
Mm-hmm.
There are, in fact, one of the questions that had come up around what Jeff mentioned was, well, what if we warm the bottom waters, we release all this methane, is it going to make it up to the ocean surface and come out into the atmosphere, and could that lead to more warming and more release of methane? And I think what a lot of scientists have found through a lot of hard work over the maybe past decade or so is that there are actually untold countless numbers of microorganisms in the ocean that are consuming this methane. And because of that, even when large amounts of methane are released, they don't appear to reach the ocean surface and make it to the atmosphere unless they're coming from very, very shallow depths. One of the ways they studied this was during the large Deepwater Horizon oil spill event in the Gulf of Mexico. They tried to track the methane coming out of that well and found that it was not making it to the ocean surface because organisms were consuming it. And so that's probably good news. But then the question becomes, what happens when those organisms consume that methane in the seawater? And as Jeff said, there's a lot of chemistry related to that.
Yeah.
So there can be some of those chemical reactions can do things like consuming oxygen and producing carbon dioxide, which can alter the amount of dissolved oxygen in the water and also alter the acidity of the water through the production of CO2. So that can alter the pH of ocean water, which of course could have implications for a lot of organisms that live in the ocean.
Cool.
Okay, I'll be back.
She's very cool.
We have a question in our chat about how long our expeditions are. The length of time the expedition occurs will vary. The leg we're currently on is about 1 month long. We'll be coming to port next week, so pretty soon here, for the port call between the first and second leg, and then the second leg will depart, and I think that leg will be about a month long as well. The length of the expeditions is defined by the endurance of the vessel, and these days the endurance of the vessel really comes down to how much fuel it can carry and how much food it can carry for everyone on board. These days we have the ability to make fresh water from seawater, so that's not as much a limiting factor as in the past, but certainly the availability of food for everyone on board is probably the number one limiting factor. And so after about a month, it's about time to get back to shore and resupply those stocks of food. But I will say the food is quite good. Even 3.5 weeks out now, we're still having fresh vegetables, nice crunchy lettuce. So we're doing quite well out here, but that tends to be the factor that determines how long an expedition will be.
Fresh lettuce is a science in and of itself.
I understand that it is. There's whole processes to how you store it and keep it.
Argon and the ethylene filters and everything.
Yeah.
But we are nearing the sauerkraut times.
Yeah.
Fine by me. I love sauerkraut.
Getting into the cabbage time.
Yeah, the cabbage is starting to be stewed. So crunchy.
And the line.
End of line.
End of line. line, stop recording.
Turning. Start of cross line.
Starting cross line.
Start a line.
John was also waking up I heard. Like heavy in front of the vehicle. Almost like Adam knows what he's doing. Almost.
Not, it's a team effort.
Yeah, but you're the one
We're-
in the room.
we're- I'll take that credit then.
If they want to leave you high and dry, well, that's right. Breakfast.
That's true, then I'll take it. Yeah, we're getting pretty good at using the ship sonar to dial in the seep locations.
There's a little something down there. You got the side lobe man.
Yeah, it's pretty persistent.
It's a
Be a fish.
big old fish, yeah.
Yeah, squid. It's actually fisheries vessels will use similar multi-beam sonar systems because oftentimes fish will have swim bladders within them, which they use to regulate their buoyancy. And those are organs filled with gas, so functionally they're like bubbles, so they show up on the sonar just like the gas bubbles that we're looking for show up on the sonar. And the fisheries vessels can use that to identify schools of fish and do things like count fish populations, fish stocks, using the same sonar technology.
There's a recent paper of one of the largest in Norway.
End of cross line.
End of
cross
line.
line.
Turning.
Catlin populations.
Range
being able
ROV,
to
got an updated waypoint.
discern the sizes of the swim bladders of the predator and prey over the
Start of line.
massive scale.
That's incredible. I remember reading something about trying to, get at, not species, but like at least different types of fish based on sonar returns alone, which is pretty cool.
We've got a forward-facing sonar for collision avoidance, but it's also a fisheries sonar. We've
Yep.
got the EK80 with all the wideband transceivers, which
Are calibrated.
It needs to be.
Can be calibrated
Yeah,
to,
yeah.
so you know.
Takes a lot of calibration. Little tungsten balls, copper balls. No reflectivity. The top floor here. It's pretty promising, the cross line right at your.
Yeah.
700 or so.
Do, 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 do. Yeah, those were very, very strongest returns I've seen on the M3.
Yeah, yeah. The weather's meant to be picking up right now,
Yeah.
so I think we
Oh, yeah.
got in
Let's
at
look
the
at
right
the-
point. Yeah.
That's right. That's a good deal. Nice that we can kind of hang out underwater while the weather comes
Yeah.
up and wait for it to subside.
Good timing. Put up on the. Let's see one.
What's that?
Trying to,
So while we're out here, we're quite attuned to the weather conditions, obviously, as you would be on a vessel, but particularly because our ability to do a lot of the scientific work and exploration that occurs in the Falkor 2 is determined by weather conditions. And so if the winds and waves get too high, that can sometimes curtail our activities. And so we're constantly thinking about the weather out here, and folks are doing a great job of figuring out how we can maximize the data we can collect around weather conditions without hopefully getting shut out for too long.
Seawater temperature there. South Colorado weather, 38. So Sonny and Doug, how do you guys enjoy doing the M3 mapping?
Best part of the day.
I like finding things you can't see.
Yeah, exactly.
There should be a backspread photo you can't see on the best times.
It hones your skills when you don't have a visual of something and you have to use your instruments, because sometimes you have to, that's all you can rely on is your instruments.
Should have my mic up for that. Yeah, let's look.
Tying it with the umbilical.
Yeah.
When he gets to there, there should be the next block over him. Then 5 meters on my corner spread when you actually make it to that point. It's like perfect. If you see, now let me ask you another question. You said that screen went gray.
No, not the whole screen,
No,
just all the
light.
highlighted stuff.
Yeah. But did it go gray up here?
Didn't look up here, see if it went green, but we actually lost all those things too, so we started.
You did know.
We had it,
So
Yeah, we started
when you
close.
see that, that's the control. You see the control under S5K?
Yes.
That should have alarmed.
Okay.
The control.
Right, right.
So you know when you bring telemetry up, you normally see that flash up and it's active
Yeah.
before you actually have telemetry. Yeah, that's your control.
Okay.
That's when you usually get control first and then the vehicle comes on.
Right, right.
So it may have had an interruption on the Ethernet traffic to the control.
But
You should have had a pilot alarm.
Got it.
So if you see it again, just see that.
I saw you
I tried to
control
look,
it. Is there
I didn't
anything?
see-
Yeah.
I didn't see it.
Okay, that's
But
good.
that's why I just
So
wanted
we'll
to
keep an eye
tell
on
you.
that to see if that drops
Yeah,
out.
if you see it go red,
Yeah.
that should be on the side of that.
Okay.
All right.
Sweet, thanks.
I'll be back after the meeting, I've already eaten, and I'll just review the state.
Having fun. Are you still manually doing the depth?
Yeah.
Working out great.
A question in the chat about what is shown in the display in the left-hand corner. The bottom left-hand corner, that purple area, is showing the path of the ROV. That's a map showing the path of the ROV over the seafloor. So you can see the ROV is completing a bit of a grid pattern, and that is how we collect the M3 sonar, multi-beam sonar data. For lack of a better term, we can call it mowing the lawn. You just go back and forth along parallel lines with your overlapping swaths of the seafloor. The swath is what you see in the upper right-hand corner. And so that is a map showing the progress of the ROV. You'll notice the lines sort of jump around a little bit. That's because we're using what's known as ultra-short baseline positioning to record the position of the ROV, and so its navigation solution can jump around a little bit, but I assure you the ROV is actually going in a very much straight lines between those grid points.
I'm gonna have to just slower than that to make concessions. Or it'll start. help of the Sprint INS, we are making a much straighter line, like you said, Adam.
Right. Those are just periodic nav grabs from the USBL, but yes, we're making straight lines. But that's nice. We have the three-dimensional view there. You can see that the ROV sits about 25 meters off the seafloor. We have made one long crossing line, and now we're making north-south passes in parallel lines across our site that we identified as a potential methane seep site and overnight mapping.
Nice and sound there.
I know, right? Rude.
That's smart. I just put it down here.
Yeah. I'm taking your time. You just cup it so people think you're trying.
I had like a minute, 15 seconds, just bliss. And then I started choking on that.
You guys seen any bubbles?
Yes.
Oh my goodness, did we see bubbles? It was like all across the,
Really?
yes,
Yes.
the camera.
Incredibly strong returns. Yeah, the strongest we've seen on the M3 in this trip, and a whole series of plumes along the crossing line. So we definitely have a place for you to start.
But, so is it that big X?
No.
Where is this right?
That green dot.
Not green, oh,
Right
make it a
there.
big dot.
We can't. We can't control the size. Actually, you probably can, but just probably not. Yeah.
I don't know.
Make it a purple dot, I don't know.
I mean, does it matter?
Yeah, I'm just kidding. It's fine.
I don't think we have control over the
That's great.
marker stuff. You
So
can
it's
create-
already a success.
Well, you can enable this.
See what we get at the seafloor, but looks like we have abundant gas
No, it's just,
seepage. Doesn't always correlate to communities, but it's a good sign.
Yep. Where are we? No, I guess that's the start of the line, so this is, no wait, where have you been? You started going horizontally across?
We started on that crossing line, east-west crossing line, all the way on the western
Very
end,
good.
and we've come across the east, up, and
Yeah.
down. Yeah. We're making our way back.
welcome back
Hello.
to Divestream.
Go get some food.
I'm gonna get some breakfast. Breakfast good?
It's pretty good.
It's always good, right?
Pretty good Danish.
One.
Hold on.
Sorry,
Well,
that's why I grabbed the first one.
I only love chocolate.
Good morning, Jen.
Good morning, Lisa. How are you doing?
I'm tired.
Yeah, I hear you.
Don't do that well. Sleep,
Yeah.
with little sleep.
So do you think the nap
Did
was
Adam and Jules tell you what we saw? It was
Bubbles.
very,
I saw
yeah, it
lots
didn't
and
even need the
lots of
M3.
That's
It was
amazing.
just like, the whole middle part of the screen was just thousands of bubbles.
I could probably, there's probably an A snap of bubbles, let me check.
What do you call a bunch of bubbles?
No.
An ace. Ace snap.
Should we just call it a group of bubbles, an
Yeah.
A snap of bubbles?
An A snap.
Yeah. It's
Sorry, I'm not awake yet.
a congregation of bubbles.
A-snap is the automatic 10-second photos taken by Sea-Log. So we must have had them.
Yep, I do know what it is, so
Oh,
I
okay.
just not awake yet.
No worries.
The A snap.
9:30.
We had a long conversation in the control room about what you call groups of different things.
Oh.
And that's where that came from.
A group of bubbles. A gag? No, it's not a gaggle of
Like
bubbles.
we were looking for groups of sea cucumbers, and it turns out there is a name for them. It's a pickle.
Makes
Oh
sense.
wait, that's cute.
Okay.
Morning. Morning. I'm back. You're back.
So what, do you know what time that, all those bubbles were? I can go. look.
9:30.
For
I'm
the exact-
pulling it up now. 9:30. I did log in. Nothing professional.
Some smoothies on it.
Go get it.
If you wanna hang out here.
Have you eaten already?
What if I said no?
Yes. No, he's even a witness to it. Those horrible
Arc pilots.
cheated on the mustache fun thing already. I just started.
Someone who's not participating, you show consistent.
You have no way of knowing if I'm participating. No way of knowing because I'm following the rules. I started pinching.
Yeah.
That,
Yeah.
amazing. Can we
Although,
put that
I
picture
really
out on
appreciate
the,
So you have to have some.
Yeah,
kind
hi.
of too.
let's
This-
see.
there's
How do I do
this-
Can I'll just take a picture of that.
Yeah.
Can I do that?
So we can't have the motion.
Yes, the easiest.
That doesn't work. Oh, so I slowed us way down. I mean, it's not been okay, still. Get a bunch of this.
This was 25 meters up, right?
Mhm.
Yeah.
It's not really acceptable. It's just have much free.
Alright.
And that's what's.
Oh, yeah, finish
something.
something.
That's probably.
Like 60, so.
Is that in one?
Yesterday. I'm sorry, this is,
I don't know.
So 9:30 there is what time here?
Middle
Uh,
line.
6:30? Is that right?
Is that?
Is 9:30 UTC?
It was
6:30?
Exactly 9:29 and 37 seconds.
UTC. Well, what is that time?
UTC,
What is
sorry.
that time here?
Make him a turn.
6:30.
6:30 a.m.
Yeah.
Yeah.
What they said.
Start at cross line.
Start across line.
Start across line.
Yes. It was changed up our way through, it is changed.
This one's my favorite of it just like hitting the push cores and kind of going all over the porch. Amazing. Who would have, what?
What?
So we're set at 25 at the start of the line, and then
Try not to, just, let's see
don't
what,
touch anything.
yeah.
We can do
I'm
that.
glad you figured it out.
Wait, why are we touching?
Don't mess with it,
Don't touch it.
unless it gets, unless we lose the bottom.
What time did you get to down?
To
here?
seafloor,
Yeah.
it was
6?
about 6:15,
Let me
6:20.
see.
So mapping until about 9:15?
Yeah.
I'm being asked here.
Oh, okay.
On bottom was at
6:10.
6:08.
Yeah. And then we started the survey.
You haven't been
Six-
down to the actual bottom? though.
We, just on the seafloor at waypoint 1, they saw the bottom and then came back up. But it was pretty innocuous looking from that
Muddy?
just little, yeah, muddy. Or sedimented, didn't see what kind of.
Okay. Well, I'll leave you to it.
long is each line?
We're not doing
20 minutes?
Yeah, they're,
This way.
well,
Yeah.
maybe a little,
Yeah, that way you see
man,
it,
these
so it opens.
Macs are very sensitive.
Yeah.
The
Yeah.
touchscreen.
Just under 100 meters, which you should be able to stretch.
Touchscreen.
This is Adam's, and he's got C-Log, so I'm doing the start of line in and line.
Fancy.
Fancy?
I didn't know Mac was
Ready to go?
Well, no, no, the touchpad is very sensitive.
What this, if it's making altitude change, just kick off the auto depth manually and kick it out of that.
And no
It's just when you
cross
kick
line?
it
And a
back
cross
in,
line.
it'll depend how, like, if you can
Question
hold it
mark?
steady, when you kick it back in, that should
Yes.
be good. But if you're trying to make it catch, like during a change, it'll just overshoot for a while.
Yeah.
But if you can get it towards your smooth depth, right before you kick it back in, it'll be smooth.
That's what I'm saying. Just
Jeff, I put in a
Turn it
mid
off.
depth
I mean,
because it was starting to pick up when dirt fell off the
use your
vehicle.
fingers.
Yeah.
Gross.
So it doesn't bounce.
Gross.
Yeah, but when you re-engage it,
Then it still bounces.
so if, no, if you have to be vertical. Like, you just start turning it.
That was what I should go.
We're far enough behind him.
Good.
All right, because he's gonna have to accelerate.
Making a turn.
Make a turn.
I think they're actually.
Making the turn.
That was good.
Without
And you
both
edited
of
all
them.
these points I'll edit it, right?
I'm just doing it one at a time. What I've been doing too is when we start to get towards the.
Start
end,
line.
it's those-
Start a line.
Start a line. There's another floater for you.
Oh, damn, when the pressure starts dropping,
Oh,
because
yeah.
we're now taking that milk loop through the water. I just turned the speed down quite a bit. Just give out delta until we.
And
reach
there's
the
another
pressure.
one. That would be the same.
Line's been working.
Oh.
Yeah, the.
Yeah, but it's just like when the boat like is slowing down and we're still going at the same speed. But it's the water, we're like basically doubling the speed in the middle of it, it's like rolling it through the water line.
Physics.
That, and so paying out helps a bunch then, because he's effectively the same way.
Yeah, physics.
Sort of. But if you start to everything, just run out of delta again, it does the same thing. So it's slowing down, so it's, that's also good. But yeah, so you're saying what depth will work, but if you have any residual sea velocity, when you tell it to stay put, the stay point.
Stay
sorry,
tight.
waypoint, not stay point, the waypoint will be here, and then you'll cross it, and now you have this error.
Yeah.
And it'll come back and try to correct it, and it'll overshoot. Whereas if you
It was
set,
really
if you're
cute.
smooth, and then you just hold the depth, and then that's like constant C
Yeah.
value, and then you auto depth, that should be smooth.
Yes.
Yeah, and I'm quite confident you can.
No, my season is
Just run it there.
I'm just trying to.
No, that makes sense.
Focus
That is
on a
actually-
re-engage depth.
Yeah. It's the bouncing that tries to sort itself, but makes everyone unhappy.
Yeah.
I'm unhappy,
Especially Jeff.
especially.
Raging.
That's right. That's Gracie. She's the Raging Cajun. She's our resident Cajun.
Yeah, she's from Louisiana.
From Lafayette.
Great town, Lafayette. We get more Emmy winners per capita than any other. No, Grammy, that's the one. Music.
Really?
I've never seen it.
Maybe one musician.
Side emissions.
Who?
Side emissions.
Oh, like, full. Yeah.
You're saying like New Orleans doesn't catch, well, you said per capita.
Yeah.
Ah.
That's what I've heard. I didn't.
Not
check it
independently
recently.
confirmed.
Good. There's gotta be like a hotline we can call.
There has to be.
Back in the day, you could call the newspaper and get some facts, right?
Because then you call 411,
It's good information.
get the info.
Where do you think that number would go on the ship if you dialed 411?
I know.
Find out, get the phone.
Who's gonna answer all their questions?
What?
Can you call 411 ship phone and see if it answers?
Think so?
Yeah, who cares? Okay. Why?
Well, we just want to get the info.
You wanna get the info? I have a question about
411?
Lafayette.
Yeah.
What's the
That's a date,
411?
that's gonna date
I think
somebody.
the
if
411
you-
is actually 1700.
Well,
No, it's.
I don't think it'll actually work.
Well,
Find out.
that we could just later.
It's not gonna work.
Upload a Another
Just like
photo?
big cross.
I know.
And there goes the hose and the bungee.
And the trim. It doesn't work.
There is no info.
There is no info.
There is no 411 on the vessel.
What's the 411? The 411 is actually the 1700.
The 17
It's the
hundo.
number to the bridge.
Yeah, yeah, they know everything.
Why did they choose that number? That's like not a good number.
What did you choose?
Oh, yeah. Well,
Maybe 1000?
0.
Maybe 1111.
Anything other than 1700.
1699.
Yeah, 1701. 17's a good number.
1701.
It's like the 19th large,
Why is the emergency number in the U.S. 911?
That's a great question. If we could get a 411 number.
We
that
could
worked,
call
ask.
411 and ask why 911.
Yeah.
Darn it.
I think it's for attempting to have fewer misdials. It's like the numbers are far away from each other.
And
Oh,
old
yeah.
rotary phones,
It
right?
was chosen in 1968 by AT&T because it's easily remembered, and at the time, no area codes or office codes used it.
Oh.
There you go.
Wow.
That's it.
So it's easy to like, why 3 numbers is easy to remember? Isn't any 3 numbers easy to remember?
But I mean, everyone knows 911.
Not before
There's
when?
another one.
Not before 1960.
There's so many things you can hoover up here. 911. So we're at 18 meters altitude, still cool with that, Jeff?
Hmm?
18 meters altitude, data still good?
Yeah.
Okay.
You've got another float in there.
All these things, we do decoupling. I thought, yeah, it was. Well, that's like in writing, it was.
I think we're coming up, you can see the mound, the bubble mound.
That's it. Ooh,
That's
big,
the
huh?
next line could be interesting. No, maybe 2 lines over. You see the green, those were the Bublés, Michael Bublés.
Bubbles.
The best part is I said Paris and looked at you and looked back at him and then continued.
I think in the UK, the emergency number is 999.
Well,
So weird, it doesn't always.
When they could have just used 911, I don't know why.
yeah,
So much PSI is there.
they had 3
But
different.
it's some, try changing on yours, see if it'll grab it. Sometimes it just doesn't want to make changes. Yeah, you're on 4.0. 4.0 would be a bit optimistic. Whatever, this gave 3 knots, now it's 4 meters per second is 8 knots. Yeah,
That's good,
so we
she's
can
giving
do
me up,
less
so
than
she's
that.
testing
There's
me.
no ROV that is 3 knots. You know, yeah, right.
It's got a cupcake she's to
No
fill.
ROV with manipulators.
Big jiggle size.
Seaboards, sorry, I should say. Yeah, it didn't do anything. It didn't. But it doesn't even drag. It's not hurt us. Literally just drag along. It's only it's playing along okay because there's not very much fall right now. So if we start rolling, we'll start seeing that. Yeah. We're at 15 roughly meters at altitude, 15.5.
All right, start slowly.
Alright, we'll do this very gradually.
Slowly.
You wanna go up to 25 or?
If you can get it back to 25, that'd be great. I want no discernible motion other than altitude.
We're gonna let our buoyancy pull us up. No, it's not gonna work.
Are either of you on leg 2?
Yeah, we both are.
Good. You are spread. Make sure they map the same way. On
We already
leg
have a
2.
plan for this. We're switching like RV supervisors, so they won't know the difference. So we're gonna, it's kinda like doing the dishes, like you don't wanna do a good job.
Right.
Do the dishes, so we're just gonna tank the first couple mapping. Next cruise.
No, no. What are you, wait, hold on.
And that's on weaponized incompetence.
Yeah, that's, oh, there's a word, there's a term for this.
Ladies and gentlemen, this is a classic example.
My old job, there was the thought of if you ever wanted to get an office job, just be bad at offshore job.
Right. Yeah. Yeah. Find a spot for you, office shit.
Yeah. You know, project managers. They don't know how to do the project, they just manage the project.
I don't think that's the case here at SOI.
No.
Well, this wasn't this was
Yeah, I know.
not SOI I'm talking about.
No, I know. Just had to get that plug in.
This tow is not great power.
This is about as slow as I can go.
That was perfect.
Smooth, baby.
Just like the one
Just
wing
like-
dove.
It's like one winged dove. The ship's slowing down a little bit too, huh?
Jeff, did you?
Yeah, the ship's slowing down.
You could try changing that. You have to go shallower. Because he's been pulling up.
You think the adaptive palate should know?
You would think. It does not.
Uh-oh, cheer down. Do you think we'll have overlap in the shower?
Yeah, I measured it. You get,
Okay.
there's still 40 is the minimum, and we got like 42 there.
Okay.
So, yeah, we're okay. That should be okay.
My favorite, I love the fact that the measuring tool, this is the only software that has a tape measure instead of a ruler.
Which is better, makes more sense.
It's way more sense. But it doesn't really look like a tape measure
What?
in the graphic.
It kind of looks like a snail.
It does.
I think it looks like a tape measure.
Okay, well, once you know what it is, it looks like a tape measure.
I think you were just so used to having a ruler.
You're right, oh my gosh.
It's-
We shouldn't condemn them for stepping outside the box.
They're trying to start a movement.
Yeah.
If it was truly just a ruler, it would be one measurement that you have to just move around.
Yeah.
You can't make it
exactly.
longer.
Maybe it's a huge ruler.
Right.
Infinite
Elastic ruler.
miles. That's true, we are kind of using it to click around like you would a tape measure as opposed to a ruler.
I know. It's more, I think of tape measures.
We should start contacting people.
We should well, what number should we use to contact them?
This one
We gotta
does.
call 411.
Yeah, it's only
Let
this
me
one.
find that number, but
In
interesting.
the multi-beam, no, it's a ruler.
Just like the one winged dove. License sure close. Monkeys have gone left.
So, do you want to swim?
What?
I keep forgetting I'm still here, guys. I brought loads of more truffles to like people to help some share stuff because I think it's more funny. Bankrupt Scott's come forward. That's why.
Like, there's a discussing how we can be in there.
Then challenge special.
What's in our shop?
Oh, somebody ordered it.
Air for Schmidt. Waffle maker. Waffle maker.
Waffle.
Yeah, waffle maker. We sort of pancake mix.
Pancake mix. You do it from scratch. We have pancake mix.
Are you just trying to turn breakfast into continental breakfast?
No, we're trying to turn midnight.
Oh,
into
midnight
midnight.
into midnight
Yeah.
breakfast.
We're trying to turn the ship into a Waffle House. Yep. We gotta get the day shift people to turn on the waffle maker for us, so that when we come, it makes the batter, and then we come on. It's ready to go.
Mm.
We could do a sourdough batter. Just.
Sourdough?
Is there enough syrup on the vessel?
Yes.
That's good.
No. Should have added bring some good Canadian.
That's interesting. It's like there's one if you read the actual like
Mm,
what's it called?
authentic maple
Most
syrup.
of those-
The commission report?
No, what he actually wrote. Pretty sure that's.
ChatGPT says
Shirts around, nice.
you're right.
I'm not saying it's like intentional.
It says ChatGPT can make mistakes.
I mean,
I don't know why we don't have AI do our rotation plan. Because you can just set parameters.
How do you think I pulled off the Mario Kart? It did make mistakes in it though. I gave it parameters, but I don't think I gave it specific.
Adaptive.
Yes, sir.
Awesome.
Oh, there's something there. What? What is that? Oh my gosh. We'll never know.
No.
We don't have the ability to go look at it.
Smash them.
Love it.
Boogers. Boogers. Or is it
Oh,
Love
no.
Tino? Is that what you think?
No,
Low
I don't
bay
think it's
Tinos?
low bay. I was like a sack. A sack.
Bolsa. Bolsa patties.
Also.
Yeah.
It's raining.
That's the type of coral actually.
It's raining outside?
Yeah.
Oh no.
Oh,
that's so cozy. What a great day to be
I hope you have soup for lunch. It's raining, Scott.
And
We're
breakfast.
gonna have to call operations.
Oh God, the RV might get wet.
Yeah. At least Sage is warm and dry.
The sage is dry.
It's
in
cold
the
in there.
robotics lab. It's not warm.
It's in the cold room.
Sage is.
Oh yeah, cause you figured you put
Cold
plenty of
box.
so you're not worried about.
Yeah.
If we don't have to heat it in there, we have to heat it on deck.
I would love to heat it on there. The bench cable currently doesn't work.
Did we break the bench cable or did you break the bench cable? Is there a fire?
I think it was from the short.
Oh, bummer, so the
Yeah.
power supply's busted.
No, I have a power
Oh.
supply. It's the bench cable.
That
That's the
bench
tension.
cable, I see. Oh.
Yeah. I need to poke it more today.
Poke and destroy. Poke and destroy.
If I was good at
Poke
poking
and
things,
destroy.
I'd catch on fire.
Is the temperature probe working?
Seriously.
Because we're gonna need it today. If I'm, if I,
82 degrees, that's
That looks accurate.
not right.
That was, wow.
Negative 82C. Jeez.
It is cold.
We're deep.
Yikes. Working good.
Oh boy.
darn.
Hey, listen, I did look at that data from when we put it in the place for the octopus brooding. And it did have like drops to minus 80, but mostly was fine. So they're like, it might be fine.
It might be fine.
Might be fine.
Might be fine.
Story of,
Might be okay.
story of my life. Might be okay.
Might be fine.
What are you supposed
Who
to
knows?
do?
But just imagine what the data will look like, Jeff, if it's reading minus 80 this whole time, and we put it in the plume, it goes up to like
degrees, that makes sense.
5. It's a huge spike.
Actually jumped
Someone's gonna
forward.
catch that.
That's
Know that
fine.
there may be a problem.
Like either way.
A temperature swing of 85 degrees C.
That's a big delta. It's a big delta, big delta.
We have out
That's probably. I suppose this has to do with when you station keep,
Oh, yeah.
move the ship, like that, that was.
My pH sensor is
Yeah,
reading
so-
7.94.
Yeah, 0.2 meters up. Move the RV, yeah.
There were so many bubbles.
There were was it reading 7.94 or the bubbles or just like now?
I can't really, it's now.
Yeah, no, it's never, I tried looking back on it in the live reading at some point.
Yeah.
I looked, oh no, I told what. Yeah, I told Adam the salinity signal.
Yeah, that's really cool.
That's
Yesterday.
really cool.
It's really neat.
Wait, what?
So I was looking at the data from yesterday, and where I had, on those southern crossing lines, I had these wide peaks that there was just like methane across the whole southern crossing line. Every single one of those peaks has a freshening in the salinity. That's like, that also decreases to the west, just like the methane concentration.
Wow.
Which is
Hydrate dissociation.
Yeah, that's how you know you're hydrates.
Wow.
End of line.
End of line.
End of line.
Put.
End of line.
Come on. Hey, that's me.
Hey, you're doing a good job over there.
Thank you.
25.
I want to see us lower that.
We're going it.
You
Next
too.
line. We might see it off the
First
side.
rain we've had on
We'll see.
Is Portland gonna be blue?
Yes.
What?
It's
gonna be what? Oh, it's supposed to be sunny.
Portamont?
Yes.
It's the rainiest part of Chile.
Lie to us, tell us it's gonna be sunny, so we have a scant few hours in the daylight like human beings.
Like when we were there last month, it's very much like
Movie.
PNW vibes.
Yeah, I'll tell you.
I'm mad about that, I guess.
It's not good.
What do you mean?
That's where I live.
He lives in the PNW.
What part?
PNW. Corvallis.
Wow.
Corvallis.
Corvallis.
I work at Oregon State University.
I didn't put the two and two together.
Okay.
Me neither. Me neither.
Making a turn.
So tomorrow in Portamont, it's cloudy, and every other day on Google Weather, it is raining.
Alright, I'm gonna wrap it up.
Yeah, so that's apparently how
What's the-
Oregon
what's
is
the
when I'm
temperature?
back at home too.
Start of
then
line.
Start
Start
line.
line. Start line. Start line. Thank you.
Highs of like 13 to 15 degrees C, and lows of 4 to 7 degrees.
Because I was gonna
I
say,
do.
when we were there
There's
last
something
month,
about
we were
having a big
still,
poker.
Like
A
it was
pointer.
like late winter, just barely coming into spring, and it would not go above 7 degrees Celsius.
Yeah.
We would just be like,
Just a nice British summer, cold and rainy.
Yeah.
The rain,
Just the way I
back
like
in
it.
Oregon, the rains have started and the time change is about to happen. So
Like
it's
it's
gonna
dark
be
at
cold and
2:40.
dark.
One click is 110.
I left and it was
That sounds
warm
so
and sunny.
cozy.
That'd be
Yeah.
convenient, so you could go play. Yeah.
This
coming
is
back-
something.
coming back to California, it's gonna
Great.
be rainy.
We came to Boston in
I'm going
September.
on.
Yeah, September. It was like
Yeah.
40 degrees.
Moving north.
Yeah.
Come with
Just
me.
over.
There you go.
Well, and then like, and that's like a heat wave in September for us.
And then I'll-
Because our normal September is like
Yes.
27. It's like,
Yeah.
no, exactly. It's like,
That's
nice.
it's mid to high 20s, sunny,
Yeah.
dry. Yeah. October's like, it's like
Um,
16 to 20. The leaves are changing, like it's just.
And you get
What is that ball? Why is it a ball?
Turtle.
Oh, it's a jelly. Oh my gosh.
On the deepest sea
What
turtle.
is in that?
turtle, a deep sea turtle. Ate a octopus.
Wait,
Whoa.
can you
Wow.
could you log that? Yeah.
Stop logging.
It looks like a really
Well,
piranha that's
we've
like-
stopped moving.
He's still
We're
moving
still
forward.
moving,
Are we?
yeah. Yeah, 10.1. Very slowly.
Why?
Yeah, I think it's just a Morelia.
Just up.
Just.
You're just a human.
That's right, right? Oh, I guess it's a cross line. Who cares? It's a cross line.
I care.
Wow.
Yeah, speed up at the end for some reason. Did it? Did. That's the end of the line.
End of
End of the line.
Like this was over.
Because it's got the little eyes on the bell.
That was good.
What?
I know what all of
It's
those
got-
words means individually.
It's got the little-
Just a big.
It's got little photosensing.
We looked at it,
cells.
so we pulled the number this morning.
Spots on each
And it
part
was-
of its like bell.
Mm.
The folds are just ran all the way down.
Oh,
I
So,
know.
doesn't look like it's right.
okay. I don't understand.
I don't know, did they show you what they're talking about?
No, he just told me, it might say something about whatever the issue was on the thing. The add adjustment, I guess. So I don't know.
I don't know, like, I don't even know, because it mentioned like the brake pan was vibrating, so I'd like to see what they were talking about.
Yeah, just
That's
so
why I
we
pulled
know.
the cover, so that way we can see.
Okay, so, thank you.
Hello. Again.
Doge
This line
house.
might be exciting, Doug.
Oh,
Good
yeah.
entrance.
Yeah.
The next line, though,
Russell's on
for
board.
sure.
Let's do it.
Also, it's gonna have
For
turned off.
sure.
Yeah.
We're turning!
Here we go.
That would be wild.
If there was no bubbles, this next three
Where did
lines.
where did the bumps go?
Well, I showed them a picture, so at least they start of line. At least they know.
Start a line.
Start lines.
In the third line,
Oh, you get,
in our new AI reality, Pixar didn't happen. Is that even real anymore?
Stop,
Okay.
stop, stop.
Stop.
No, I got it, I got it.
Stop
Okay.
of line.
No, it's all right. For some reason it clicked over here. Still on the same line.
Clicking error.
Clicking error.
I'll get through mapping.
We're okay. We're all okay.
We're
fine,
all
we're fine.
fine.
Nothing wrong.
Everything is okay.
It's all
All
fine.
good.
It's all good.
Nothing to see here.
Nothing to see here.
Move along.
You touch my elbow brain?
It's your wings.
So you pick that's a little bit.
Don't touch him like that.
If you control the speed with the right elbow rabbit,
Yeah.
you can ramp it down, it's like right
Don't
up.
wiggle
Instead
that
of
like
trying
that.
to hit the lid point.
I think it does have a
So how about the
technical.
worst
How do
name?
you know what the speed is?
Oh, no, you had the
The
right.
only
I
thing
think
back
it's
is
right.
Yeah.
up there, right?
How
It
can
goes
we,
to point
this is the
1
second time
So
this
4
morning
clicks is
that I'm
1
just
foot.
like,
If you touch the rub? Yeah. You don't have to have it selected.
how
No.
about now, Levin?
Okay.
So if that's selected, it'll be wherever you set the waypoint at.
You tell him what you did.
Good to know.
Yeah, it's good.
Thanks for that.
We're
Still trying to figure all those buttons.
I know, right? Well, there's a
Talking
manual.
about one. It was the most
Jules
little
Smith,
sibling energy.
Oh, did- oh, shit, I didn't see it.
That's not a manual, it's notes that she made.
It's
And
your
I'll
own
go.
personal manual.
Yeah.
That works.
Sometimes it's.
So we just look at so, and I'll get back to it. There we go. It's so immediately, it's so sweet.
What did you do?
Did you hear that?
I don't know what you guys were doing.
We just keep going point forward with it.
Okay, that's fine.
Don't make up some ground. That's cool, you're right, pretty much the other way.
That's what this, that's what this live stream's gonna turn into.
What? What are you talking about?
We're not supposed to talk.
Red bubble chat.
You're just gonna like type ban on Facebook.
That's okay.
That would be a problem.
Yeah, honestly, that's fine.
Schmidt just has an alt account.
The Russian body.
Not
No
for trace.
offense, no offense.
I can't.
It's my Belarus.
I really like my Falcon trees too. Falcon trees.
I think we can feel pretty confident in my determination of the offset time to bring Sage back also. Look how well it all lines up.
That's lovely. Wow.
Yeah.
So that's cool that you have a independent variable or that you can
Methane in the salinity.
Oh, cool.
Yeah.
That's really cool.
So 3 minutes is working.
What? 2.5.
2.5 minutes.
2.5. What do I have in it right now? I actually, the M3 was great for it because I calibrated it so that when, no, 3 minutes. 3 minutes. When, oh, also, we're looking at Jack's axis tick is 30 minutes. I think if I moved it 30 seconds, we wouldn't even notice.
No, you wouldn't.
Yeah, actually, none of this.
Do you have the, could you plot quickly, I don't know, grab the CTD file from RV-Dev? Is that what you're grabbing?
That's what's in there.
Could you grab the one from this dive to see through the bubble plume if it freshens?
Yeah. That means I have to remember how to do that. It's in a different spot. You know, it's in a different spot.
But where it is, it's in
It's in
vehicles,
Falcor 2.
vehicles.
No, it's in Falcor 2.
Not vehicle, yeah, right. It's in Falcor 2, raw RV-Dev.
Open RDS.
And then it's the date, the CTD's SB.
Where is the CTD? Is it SB CTD? It's not SB. What is this called?
Well, look for CTDs or SBD, as in Seabird.
It might be in CTD.
So we are continuing on our survey with the M3 sonar here.
Jules.
This is the deepest
Do we
site
have,
to date for this
does the
expedition,
CTD data
2,700 meters.
Sebastian get written
So we're
in real time to
completing our
RV-Dev?
survey. We're coming up on the location where we saw bubble plumes on our initial crossing line. So we'll be keeping a close eye on the M3 sonar display to see if we
SB.
reacquire
We're
those
gonna
bubble
check to see
plumes
if
as we
it's-
cross that
I don't.
We see a
location.
freshening when we went through the bubble plume.
Freshening.
Oh, sorry, you go to.
A freshening of the water.
No, it's in there.
No.
Right.
We have entered the freshening.
Yeah.
Is it in process?
No.
It's like a quickening.
Yes.
No, it's not.
Go slow, go slow, go slow.
And it's showing
Wait,
us-
oh my god, why do you have it like that?
I don't. I didn't do anything. It's
that
the
how
name
you-
password.
Or more.
I can't read it.
You can have you sort by name.
Man, I like the Highlander Classic.
That's
Mm,
the 911.
so it's not
No, not
SB.
11. No, it is SB.
Okay. So let's go find SB.
Trying to
There's SB.
give the lease number, right?
Yeah.
CTD. Okay.
So these are
And
just
then
depth?
for today, which is today.
Look at this one, that's just depth.
Yep.
At 30, do you
Oh,
guys
depth
wanna
correction, sorry. It didn't
keep
have
up
that.
there?
I think it's gonna get shallower here.
Bing bong.
Pretty.
And bomb.
For a second, I was like, oh my
Yeah,
god.
no, because I was looking,
The
I was
mound
like,
was around
it
here
was
where you
weird,
had to
I
get-
haven't touched anything
you had
from
to
my
go-
ordering. So I was just like, what?
We were getting shallow.
Should it be like,
before.
What'd
Yeah.
it do?
what it do?
It's fine right now.
Would it be like?
That's fine, it's just fine.
They say
This
it'd
is
be
fine.
like it is.
It's fine.
They say it'd be like it is, but
It's
it's.
fine.
What is it?
It's fine. It's fine.
Don't worry about it. There's your mouth.
Yeah.
Wait, not that one.
That little guy? Don't worry about that little guy.
Oh, is this the, let's see. You don't see anything here?
Not yet.
Oh, you're right. Let me look at it.
Last.
For this, for this, it's for that, for that, and this, and that. I mean, all of this stuff must be towards the launching point. That's toolbox, which I think is I think there's also here.
Oh yeah, congratulations by the way. I heard.
Yeah, congratulations.
Sorry, that we're headed down to the winter right now.
Yep, I figured as much.
She'll buy a house.
You'll buy a house.
Oh,
This is
yeah.
what I do.
It's got a hoose.
You in the hoose. The moose is in the hoose. It's on the loose.
The moose is loose. A boat is loose.
When did we go through the plume?
I wonder. We went through the plume around
Just let me see one thing though.
9:30.
Just
No,
put
UTC.
plume up next.
Yeah.
Next month, we let the plume.
Plow right through the plume. What was it?
Two goalposts as you go through.
So did we not see a plume?
Go.
Uh,
It's fine. Not this structure. Not gonna do it.
This is how we do
That's
it.
Jeff.
That's original. I just came up with that.
I don't, let me convert real
She
quick.
just wrote that.
I don't like how it, they did read in the timestamp with a comma again, no, it didn't think that.
Excuse me. Do
Um,
you have a problem with our data? Actually, give us feedback.
Yes.
Everyone hates how we
I
do our
have
data.
so many feelings. Let me just.
The altitude's about 32. You guys still happy with that?
Could you give me that?
Yeah, 30's good.
You happy with 32? Go with 33. Well, we're still seeing the bottom pretty well.
Yeah, it looks like we have a good swath width.
I'm just adjusting the height so that they can see what's going on.
I think grants will be doing just shallow water surveys.
Uh-huh.
And we have the PB, the acquisition window, be sitting there watching it. PhD advisor, I would just have this hand come click, 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 click. Should up the game more. Hand would come.
Stop logging.
Yeah.
What are you doing? Don't ask me what I'm doing, ask what their data was doing.
No, don't
What's
ask
wrong with
anything
their
about the
data?
data.
Did the ROV get turned on at a bunch of random times? This is why. This is data from
Yesterday and today.
yesterday and today.
So-
Covered so late.
If
so
you don't
this,
flip it,
Would you
this
mind
is
going at
actually
point 4
today.
and seeing what
Just
it
so
does
you
both
know.
in and out?
if
Yeah, I'm gonna
you,
go out first.
if you want, it'll
Roger.
flip it for
At the
today's
dock.
dive
Oh, yeah.
after the
No,
dive.
no, no. I know. All of my, we were just poking around to see if we had a peak.
So,
in
what
this
you're
one.
saying is a you problem instead of our data
Oh,
problem.
no.
Just needs a.
No, the clipped one keeps
35
commas.
Oh,
okay, that's good, that works.
Let's measure the
We really.
Roger.
I had to
can you
write
show
two
me?
randomized lines of code because there was
Yeah,
a
I think
comma
we're
left
okay.
in the string on
We
every
don't want it to get too much more than that,
Wait,
because we'll start to
Yeah.
lose the swath width.
we're right now,
imported as a CSV.
we're still getting 60 meter swath width.
Yeah, so
And
that's
we're at
okay.
40 meter line spacings.
That's
So
just putting in
that's,
a straight text
that's
file?
still okay.
Does that
Yeah.
mean
It's bringing
there's
this
two
to
commas?
Okay,
I don't
that's
know,
good for
and
now.
it's never, it doesn't do that with any of the other ones. This one came in and brought a comma.
Because the first one didn't have a comma. No, it didn't.
No, it does.
Which one has a comma?
Look at how the daytime from yesterday's CTD imports with a comma in the date.
Yesterday's, like, ship CTD?
Why is there the quotes? Is that how it is?
Yeah, because it's a text string.
Oh, that's what MATLAB tells you,
That's
it's
what
a text
MATLAB,
string.
yeah.
So why is there two commas?
No,
That's
I
right.
looked. There's just one in the text file, in the
That's a,
CSV.
I think that's a MATLAB
Which,
problem.
which file?
No, because it hasn't done that with any other.
But read the ASCII file,
Yeah.
is there anything?
Which file?
39.
I need information immediately.
Do it.
Do it.
See, there's only one.
Yeah, it's getting pretty deep.
But it
But it's
also
okay,
had,
we're almost done with the line.
Yeah,
issues
we're gonna
with
finish the line here.
the header.
Okay.
For whatever reason, I think my guess is it had issues with the header because of that.
And our, yeah,
But because I don't have issues with any of the
Cross street
right
going across
lat
there.
law.
That's
None
getting
of
pretty
the-
narrow.
all of that runs
Build up.
fine.
Mm.
I have issues
Can't
with
say that on the live stream.
it's still okay
They're
though.
different numbers of
40,
columns.
50 meter swath width at that, so we'll have overlap,
Yeah.
What?
but I don't like it.
And
We're
everything.
I
turning
like
here.
it.
On every time.
We're gonna do end of line.
At least when the CSVs are read into that lab.
Freestyle and
Anywhere from
stuff.
70 to 79.
At the end of the line?
Okay.
So I couldn't consistently be like, pull column 27, it had to be like, find and identify this header, and then concatenate the line.
Okay.
It was really weird. It was really weird.
What file are you pulling? Are you pulling all? Like the events with the metadata?
Yeah. Yeah, the full, not event only.
Into the line.
End of line.
In the line.
The full one.
Clicked,
Oh,
clicked.
Alright,
Okay.
we'll drop down to
And
25.
and it's not, actually, I can say event only also has different numbers of columns, because I put 4 of them, I just threw them in Excel. Jules, I just threw them in Excel as an import, and then I was like, oh, I'll just delete these 6 columns I don't need, and I was scrolling down, like, all of a sudden, depth changed by a column
What?
in between 2, because it was a different, there was like 1 offset, so, yeah.
Oh, where do I even begin with that? At the beginning.
At the beginning,
Yeah, that's so boring.
where it
Top
all
or two,
began.
Begin in the
with just a
mid-
glimmer in our eyes.
Begin with the middle. And then work middle out.
Yeah, make it postmodern.
Did you call this black cone?
In
shame.
Shania's race.
No. Maybe.
The cone. That's adorable.
Isn't it?
Black cone.
In the ASCII file,
Black
in the
belly
text file,
cone.
is there any discernible difference?
Lead belly, cone belly.
Like if you look at the
No.
spread file versus, if we're just talking on the timestamp,
I
right?
mean,
That's
black
what's
cone
being
works.
weird.
Yeah. No, there's no.
This is good footage, I wanna make you.
Alright, making our turn.
All right, turning.
Timestamp. That's the same structure between the 2.
Were you on station for a while on that one? Cause this wasn't recorded. Jeff?
Yeah, it was
Why?
going. Yeah.
Oh,
No, it was, yeah.
you're fine.
They were,
Yeah,
they were
I-
depth correcting.
Alright,
Jules is like an opportunity to sass Jeff.
Blame Jeff.
sass me. There's, the difference that I see here is there's a space after the commas on the
Start line.
CTD.
Start line.
And then in the sprint,
Hey, Doug.
there are no spaces.
Yes.
Which line? Pain out and then in again at, what for?
They're both comma separated, but the CTD is comma
Comma
separated
and
with a
space.
space or variable.
Comma space.
With the
Well,
tab?
It's either, is that a tab? And then what is it?
Is the
It's
other
like 2 tabs, then 3, 2. Why is it expanding? Is that leaving room for more decimal places?
But if it's comma delimited, why does
Ooh, did
Well-
you get weird shit? Look at that. Oh, look at that.
you just you out.
What? You could just do matrix.
That's a really impressive conductivity and salinity.
Yeah.
That happens when we hit the water generally. I have to edit that out. Why there's so many zeros, I don't know.
Our salinity was, oh, no, I actually can't count how many, what. Oh, Christ.
End of the line.
End of
Salinity
line.
was
Oh my god, I forgot my own. It's me.
4 times 10 to the
End line.
End of line.
Stop distracting me.
Bridge, are
Stop.
we down on midway point?
Go up it up.
Morning, Tony.
We need to.
Our-
Good
our-
morning.
So he give me a good morning like he's going.
All right. This is going to be the line.
Let's cheer for the burger.
I don't want you guys to leave. Thankfully Tyler isn't. Well, at least we have each other to.
Or Alex, or Sonny,
I know.
or Ben,
Or Mike.
or Mike.
It's true.
Everyone else is abandoned.
You need to
Or
read each of it,
Our
do a read
salinity
one.
was 3.99 times 10 to the 34.
That seems reasonable.
I think
Seems
that's-
very likely.
Crazy.
You need to do a read line and evaluate each line for consistency.
Making our turn.
Drop.
I
Here we
don't know. I
go.
don't think this is an issue though.
Oh my god, you
It's
saw
still
this
comma
little
It's still
area?
comma separate. Like nothing.
What's
That's
it
not
called?
an issue.
That's
Yeah.
a
Not
new
an issue.
species of squid that
Start a
I
line.
discovered. Are you serious?
Oh wow. Wait, what?
I should have known. Oh, it's not a float. Nice.
We're talking about squid species.
This
What
is the
cruise
line,
that?
this is the survey
This is
line
the
where
line.
we are
That's
going
good.
to
This is the line.
maybe,
Oh my god, I can't
I mean, we're
See,
really
it's
building
like
it
We're
up.
going through the goalposts of bubbles.
Yeah.
it's gonna be like a sauna or a hot tub that's got the bubble.
What's that? Is that a squid? That's squid. What's a squid? Oh, that's gone.
Could we, one of the screens be Grafana? Does that have Grafana with the ROV data?
Yeah, what do you
Yeah,
want?
I'm running it right now.
CTD data?
Yeah?
Because
It,
it could be that we see the
it didn't-
water get fresh.
It didn't have fresh.
Fresher.
You say that.
Yeah, I do.
Also,
Is this the start of the dive?
Yeah.
I've got the CTD data
Where's the-
overlay.
Okay.
Yeah, but a graph is helpful. A graph
Graph is
is
so
very
helpful.
No, let's just stare at the salinity and see if we can see a change.
It went down on the third decimal place.
that we can't see. I mean, yeah, the freshening in
The freshening.
is the third.
Oh, okay, so we need to be very, well, still,
It's real.
it's real.
Like, I mean,
It's
it's
real.
noise.
A little scrappy.
Yeah.
What,
The 12 fibers
you want
on new one.
saline?
Old and treacherous always beats young and fit.
Well, yeah, it'd be cool if
It's
we
some
could
things.
see a change in
got some
salinity
tricks.
if we go through the whole thing. But it might be a very, very
I'm so happy.
and your graph is.
I'll sit on you.
Quick, take the
Design
floats
to
off.
see great things out of your hedges.
Hold your horse.
There's two
I have no
fibers.
horses.
They don't close all the way.
Yeah,
Rusty coral woodcutters.
I mean, no. I say
I
you
want it
want
to be yes.
I know you want it to be yes, but that's not how science works.
It's already down to
Well, no, I
18.
want it to be
Yeah,
yes,
hurry.
and I'll go, work really hard to find out if yes is real.
What's the lowest we want to go here? Or sorry, the smallest altitude? You got
The I don't know if we really have. What do you think
That
about
one
minimum
needs to
altitude?
stay,
Altitude.
oh, I'm still gonna move it. Let's go, let's do it now.
You want to start coming up?
Yeah.
Okay.
Yeah, 35.
Floating up.
Oh my god, I'm so excited.
Keep an eye out right in front of us for the boobs,
For the what?
the boogles. Michael Bublé. Just see a picture of Michael coming through the screen.
That's how you know there's a seep.
It's just-
Yeah. Oh my god, I'm so excited.
What happened? I don't know. He said it.
No, I didn't say it. That wasn't me.
No, Jeff said
That
it.
was Jeff.
Said what?
Don't worry about it. I'm over it. Well, oh my god.
Are you videotaping the exact moment?
Yeah.
I want to put it for the because right now it's just literally a photo that Lisa took of a screen upstairs with the bubbles on it.
That was fun.
It was a great shot though.
It is.
Right here. Right
They're
here.
coming.
Oh, visuals.
The bubbles are coming. They're in front of us.
Visuals in the sonar.
Visuals.
Forward facing sonar hit.
Oh.
Yeah, oh, you're
Incoming.
right through the middle.
Oh, yes.
Score!
Yes.
Right down Broadway.
I'm so excited.
Oh, I got it.
I hope the chat says
Running
they set it up.
Sonar.
Yeah. I'm going to
The chat better be just as excited.
Are you
The suspense is
ready?
killing
Are you
me.
ready?
There.
Oh!
Yeah. They're
my
everywhere!
God.
Everywhere!
Oh, bubble stream.
Yeah.
They're on
Get up
the.
and ready to go.
Oh, there they are.
There it is!
There it is.
Look at the bubble!
Did we see a freshening?
Was there a freshening?
Yeah.
I'm
No.
pretty sure that this one over here is
Well,
freshening.
yeah.
That one's much bigger.
Yeah, it is getting lower. Yeah,
It's in the noise.
it's the noise.
Wow.
That is a strong bubble.
This is how we do it.
Don't sing.
This is how we do
Copyright.
it.
This is how.
This
we
is how
do
do it.
Yeah. Visual. Yeah, I see it now. Shouldn't be any trouble filling up the funnel on this one.
No, that would be quite fast.
If this one is dreaming bubbles and beautiful video, I don't want it.
It's like I'm
So
done with
just
it.
walks out of the room.
Look at that, a double.
A double!
Double.
Double
Double.
bubble all the way across the sky.
That's really persistent.
That was cool.
I think the seafloor is just one mound in the center of the survey with lots of just bubble coming.
Yeah.
It is.
Yeah. I hope it's
There will not be
entertaining
many
because they got a lot of
places
time
you
to
can
spend
go
at that one
search around.
spot.
The one you saw on the sonar, Doug, must have been the one that we just saw.
I think we could argue there's a
You
trend.
saw
here.
one and then one that was larger,
Yeah.
right? That must have been what we just saw.
Oh, okay.
Let's see what it does after this.
Yeah, let's see where it goes.
'Cause
Back up.
This is. You said we passed through it at 9:30.
It was around 9:30. Yeah.
Here's.
It was the
here's-
very
here's
start
the
of the
data
dive,
from
like on the survey.
Yeah.
Boop.
I think this one is gonna be a lot of bubbles coming out of the seafloor.
Yeah.
I want big bubbles.
Big bubbles.
Big bubble energy.
Big bubble energy. That should have been the hashtag for this cruise.
Honestly.
Big bubble energy.
What is the hashtag, Soph?
I think it's just Chile.
I think it's yeah. Chile margin 2024.
No, I think it's
No,
just
is it just Chile
I
margin?
think it's just Chile.
Snore.
That's
Guys-
better because it means we are
Yeah.
infinitely the margin.
Perfect.
Hey, morning. We have it.
I don't think people do.
There's gonna be huge bubble streams on the seafloor.
It's incredible.
Yeah, at 25 meters, there's just it's like a gusher of bubbles just coming straight.
Gusher.
Yeah.
Did you take a video of it?
I videoed this. I was not videoing the screen. Everyone turned around for it, and then I just took a full video of this. So we need to go there.
Oh, we know where to go.
Okay.
It's gonna be good.
We've adjusted as per the procedure, what are we missing?
Well, there's nothing like so.
Oh, okay.
Yeah, so like we were just looking at it, we checked like.
Amazing.
There's no difference between motors.
Oh, the,
gut controls are.
So I'll put that on the insert.
2,700 foot.
But if there was some
How deep?
effect
The-
at least
in-
properly.
Yeah.
The water depth
My
isn't changing
Instagram
very
is
much
just
here.
really on a
So
daily
2,700.
post, and I love it. She's my,
It looks like there's just
social
one
media manager.
large mound
Social media manager.
in the middle of our survey,
Mm-hmm.
and the seeps are just straight out of the middle of it.
Straight out of the seafloor.
Oh my god. I didn't listen to my real audio. I probably should.
I love that. I'm so happy.
Come
I
on,
got that
look at
video.
that, look at the CTD, that's a down and an up.
Yeah.
It's a down and an up.
We should see what the CTV does at the seafloor.
Yeah.
Right next to
Okay.
We know how to make
I
bubbles
turned it on.
exciting.
There you are. It's like all it says
We're
right now is other
we are
devices.
simple people.
B3, MB,
Small
P1,
bubbles
BP.
are
That's why-
exciting.
I'm like, I don't think that's Soph's phone.
Just like being a toddler again, Jeff.
I know.
Yeah.
It's just that's the
It's just
that's
endlessly
beauty of
fascinating.
exploration.
Bubble!
We should have brought those like soap bubbles
Yeah.
Yeah.
that they give.
Just put a
kids.
bubble machine in here.
The shrimp from Finding Nemo. Yeah, the one in the
Jacques?
fish tank
Yeah.
that loves bubbles.
Yeah.
Oh,
Bubble!
Did you see the albatrosses yesterday? You
Which
saw-
I saw a lot of albatrosses yesterday.
Great.
No, but did you see
The
one?
The albatross.
That one.
Albatross.
That
I don't
one,
know if I
that
saw
one
the
albatross
one.
that was
The
giving me
one.
the eye.
Wow.
I took
Looking at
some
me.
pictures of them. So that was fun for like 10 minutes.
For your yeah, for your 5 minutes of being able to watch the birds.
Yeah. It's
Yeah.
great. It is the highlight of my day.
Yeah, no, that was awesome that they were there. And there were midday, there were, I think I counted 10 royal albatrosses in that float. Yeah.
Okay, perfect.
So much excitement.
Incredible.
I think
Sorry. Oh, thank you. No one but us will be understanding why it's happening.
And it's fine. But that's the point.
so. We're working on developing an automated machine learning system to watch for bubbles in the sonar, so people don't have to. And
What we're doing.
yeah, so what we're doing, we're gonna have a machine do it for us. And we were talking about how we need to have a noise every time the machine
you go.
detects it. I think we have it right.
It's literally just rap horn on the in the app store. That's it.
That's it. Perfect.
But that app is called hand horn, isn't it?
What?
So the app's called hand horn.
Sure. No.
Yeah.
Sure. Is it?
Do we have the same one?
I think we had the same one.
Hand horn. There's a variety of app, but my phone.
Yeah, ham horn. My bad. It's cool.
I suggested it should be that noise and just a photo of John's face for the alarm.
I mean, I have a whole bunch of those like Tyler Polaroid pictures on my door. I think the one of John would be perfect for this scenario. The one of
A
him
spider.
with the wires. It's actually,
14 years from
it's
now,
like
when
opposite
everyone is
isopods.
using Adam's AI
Actually,
bubble
it's
detection
not.
system, and they have no idea who John is, or why it makes that noise. But everyone uses it, and no one has changed
It
it.
had to be there.
Yeah. It's synonymous with bubble detection.
10 people in the world who understand why that is part of the code.
Oh, what's that?
A fish.
The old raisins
fish.
had an Easter egg in them the 8101s and 71s, that
Oh. It's a rat tail.
if you pressed on the control
Floating facing
thing,
downwards.
the control panel or something, if you did the right buttons, it would bring up a Looney Tunes cartoon on the screen. No idea why I was there, but I was told it was been there a long time.
Sonny probably
I
thought
love
we were
That's
gonna-
great.
Somebody was gonna blow up.
Yeah.
And the llama.
End of line.
End of line.
Of line.
So according to our lack of knowledge on the multi-beam, we might pass over the dual one again.
Yes. So
If we have any understanding of anything anymore.
I'm not sure about that.
I'm not sure about that either.
Start a line.
Start line.
Can I circle back to the methane hydrate real quick?
Yeah. Let's talk methane
Circle
hydrate.
back.
According to like PV plus NRT, would we be able to bring a chunk of methane hydrate up to the surface? Or will it melt, or is the pressure, like, how does the melt work for that?
So that's a really good question. We would likely not be able to grab a chunk with the ROV and bring it to the surface because the amount of time it takes to come up would result in the methane hydrate fully disassociating. So like if you had it in a bio box or something, it would just completely fill with gas and then burp out. You would not want to have it in a container that was not very, very strong because it will expand about 160 times by volume as it comes up.
Whoa.
What?
Yeah, it gets huge.
160 times?
Yeah, so you know how we're using the funnel to collect it? So
Yeah.
I was on a cruise once where they had a really big funnel and they had some hydrate in there and it was just in front of the ROV as it came up and it all disassociated and it just filled up the whole thing and just bubbled out
Cool.
over the edge of it. It just, it concentrates it immensely.
Buoyancy,
How many-
subsea.
Yeah, that's right.
So you're like,
How many times would solids hydrate
Buoyancy.
expand by?
Nice.
Buoyancy.
Solid hydrate to gas would also be a factor of
That's the 160.
160.
160.
When it
and
goes
then-
from
and
volume to
and then
bring the hydrate to gas.
230 times by
End of
volume.
the line.
end of line.
Yeah.
In the line.
So 160 going from solid to gas, and then 230 going from, or 270
Oh,
going
from pressure to seep, from
by volume.
depth to up, yeah,
Yeah.
yeah.
But so to answer your question,
It's a,
5,000
yeah,
times.
it's a massive amount. That's why you can't put hydrate in like a sealed container on the surface, cause it'll explode.
Yeah.
It's happened before with sampling too. We used these tin cans.
Making our turn.
And someone got a piece of hydrate in the tin can and air tighted, closed it, sealed it, and then the can just went exploded. Yeah.
Start a line.
Start of line.
Have any people ever launched
Thanks for your
trash
support.
cans
No
with
one else
the
supported me on that.
start a line. Yeah, too bad.
Yeah, we would do that in high school. You take a water bottle and you not even fill it, put a bunch of liquid nitrogen and throw it under a 55-gallon trash can and flip it upside down.
Yeah.
Sky high launch.
But so to answer your question, the one way you can get hydrate back up is it will come up in those cores. So, we're taking gravity cores off the back of the boat. If we were to core through a layer of hydrate, that's where I've seen it come up to vessels before, is it will come up inside the cores and you will have little pieces of hydrate inside the core. And that can also really be a problem for the cores because as it's expanding inside there, it will push the sediment out and away and leave pockets of gas where you really don't want that to happen because you'd like to have a nice continuous record of the sediment. So that can be an issue, but that is where you can bring up chunks of hydrate onto vessels.
Yeah, in New Zealand I was coring and we had like 4 or 5 inch thick, just full hydrate core, like in the core.
What?
It's like we cored a hydrate exposure.
Yeah.
No sediment, just hydrate.
That's
And it
all
does
of
make it to the, like ice doesn't melt immediately in the, you take it out of the freezer and it melts immediately. No. So if you could get it to the surface quick enough, when we're recovering a core, it's recovering at like 60 meters a minute. That's why it's really quick
That's
when
why
it comes back up.
Why you get it a lot quicker than an ROV bringing it up.
Gotcha.
It could be kind of fun if there was a lot of exposed hydrate that the ROV could get a piece of. On the ascent, just looking at it, you'll see it, turn into this gas ball.
We need to do that.
Yeah.
I was gonna say, for science. Next floor?
Well, we're not
Is
getting
that
it.
how you said you were able to hold a methane hydrate?
Yeah, that's how you could hold
Okay.
it. It
I was
came up
like,
in the
okay,
core.
how did
It was in the core, and you kind of just, because we split the cores, and like, oh, okay, there's hydrate chunks
Oh,
in the
nice.
core.
Can we follow a bubble to the surface the whole way?
It's
You're
challenging
watching
with the
them.
currents, but
Be
people have
tough.
done it. Yeah.
Yeah, be tough, but you can do it.
Would the bubble like
That's all.
expand?
Bubble changes size. Sometimes they dissolve. They go away.
Mm-hmm.
Yeah, this is why
2.5 hours.
actually relatedly it's really important to avoid getting methane
Oh,
bubbles
yeah.
in sage because the amount of gas in it
Yeah.
can overpressure sage relative to atmosphere, and then we're bringing a pressure vessel up with the ROV,
That'd be good.
which there is a pressure relief valve on sage that trips about 3 meters below sea level. So we don't bring back a pressure bomb, but we bring back a flooded sage.
Yeah.
And so one of the things they think happens with bubbles down here is that as the bubbles come out of the seafloor, they think there's a very thin shell of hydrate that is around the outside of the bubble. So it's actually the ice around the bubble.
Which we've seen when they go in the funnel.
Yeah.
Those are little ice bubbles. They're ice
Yeah.
bubbles when we're using the gas tank.
Yeah.
And so that helps keep the gas in the bubble so it's not dissolving into seawater. And those will persist having that shell up through the water column for quite some distance until the water gets warm enough and low enough pressure that shell goes away. And then usually at that point, the bubble gas will dissolve into the seawater. And so we'll see on the ship sonar, these bubble plumes will come up to a certain distance, and then you'll see them kind of all at the same depth
Wow.
go away, because that's where that hydrate shell is just disassociating.
That's awesome. That's so cool.
So we've taken a few cores here with bubbles in them. What happened when they got on deck?
The cores have expanded a bunch
Yeah.
and turned to soup a little bit. We haven't
ROV
seen any.
ones?
Oh, those ones?
Yeah.
Oh, the push cores?
Yeah,
I
the
haven't
push
seen
cores.
anyone
I don't know
with
about
hydrate
that.
in them, but they
Okay.
get,
We did have a few that had bubbles in it.
yeah.
This trip,
They,
yeah.
you can see it on the, well, didn't sage. Those cores that have gas in them starts expanding and then
Yeah.
releasing,
Right.
and sage
Coming
gets
out the
these
top.
methane pits.
Oh, okay.
And we'll be like in the midwater, and I'm like, oh look, a bunch of bubbles just. Oh god
It's
damn
the-
it!
it's the
Like,
push cores.
Well,
Okay.
it will be in midwater, and it'll be like 200 ppm of methane. Oh, look at all the cores just flashing
cores are
methane
just
out of
degassing.
them.
All right.
But we did bring one core up on deck that you could hear it. When we put it on deck, you could hear the gas coming
Really?
out of it. It was
Wow.
making a cracking and popping sound as the gas was coming out. Yeah.
Wow. Next time that happens, call me. So I can put
Just-
a mic onto it.
Even
Just
if
sound
it's
the general
say
alarm.
3:30 in the morning.
Isn't
Just
it,
sound the general alarm.
isn't
and
the
then-
alarm?
Get everyone out.
Also, why you have to be careful when you remove the core cutter from a seep core, because it can shoot
Shoot
like
off.
a
wow.
launcher.
Oh my gosh.
Oh, wow.
Yeah.
So the core catcher and cutter are tight enough to where they're kind of pressurizing the core, and as you're unscrewing it, it'll be like a little cannon shoot out.
Yep.
So you don't stand in front of it.
Protocols
I've
do not
seen-
stand in front
I've
of the
seen
end
them
of the core.
shoot, 10 feet away. The
Oh,
core.
my goodness.
Yeah.
Didn't you have
That's
one
how we left off.
shoot mud out all over the side?
Oh yeah,
of
on the
ship?
side of the ship. When we were coring off of Oregon 2 years ago, a core just exploded.
Wow.
Not like it didn't destroy; it just shot out the bottom, and all over the side of the ship was just this mud that stayed on there the rest of the cruise. Yeah,
Pebble dash.
that was with Davide. We're trying to core a mud volcano thing,
Nice.
and yeah, that was a little gassy.
Oh, that's the one he told me.
Yeah.
Some samples from. Okay, yeah.
Yeah, that was.
Yeah.
And I mapped that thing with Hercules.
Mm.
So we knew exactly where to core And we took three tries to find like the Goldilocks core that wasn't gonna explode, but have stratigraphy. It was really cool.
When you're coring in these areas, then do you approach the core with great caution when you're
Mhm.
Yes.
you don't
Yes.
know whether or not it's got hydrate?
Yeah, you
do.
always, if you're coring seeps, you just assume that all of them could. You don't stand in front of it. In fact, I've seen another when we'd have a burlap sack as we were doing, and someone would be holding it because it would shoot and hit the sack.
Whose
And
job's that?
There's they're just holding it
Newest
over. It's kind of like
person.
the
Core catcher.
the core catcher.
Core catcher.
Yeah, the core catcher.
Yeah,
That Roy had a job.
yeah. That's right. That's why he gets paid the big bucks.
Yeah.
Also, why they required
This
us
M3
to
map
have
is gonna be
uh,
wild.
methane sensors in the lab we were working in, because we were pulling up cores that were degassing a lot to where it was on the edge of technically there could have been enough methane in the confined space to be harmful,
Oh my goodness.
because there's a not a safe level for it to be in the room. So you have to monitor methane, get little methane sensors in the labs.
What happens if you inhale methane?
It can be poison. It could displace oxygen, I guess, is one of the
Displace
things that
oxygen.
concern it, yeah.
Shoot yourself in a porta potty.
Yeah, on drill rigs, they have to be worried, they're worried about that, because that's a lot of gas under pressure.
Yeah.
So they're like coming from 2, 3, 4 kilometers depth, bringing gas up. Expands a lot.
You get kicks.
Yep.
Kicks.
Yeah, it kicks the drill as they expand. You get pockets down there.
You're supposed to,
It's not
that's
good.
where the seismic data is supposed to tell you not to go, but even then, you don't always get exactly right.
Nothing.
Just
No.
very isolated, very small.
I've actually been on one job I did was for Shell, and they had a pipeline that ran a certain distance, and they were worried about if the pipeline shut down, flow shut down, that the hydrates in the crude that they were trying to pump would freeze in the pipeline and
Oh,
stop
yeah.
production.
Okay.
So they contracted our company in conjunction with an ROV company to build a trencher to bury this pipeline. And so they figured it was cheaper to design and build an entire ROV to do one job than it would be for them to insulate the pipe the way that they needed to insulate it.
Wow.
So they used seabed to insulate it. We
Interesting.
buried it to about 4 feet,
Yeah.
Wow.
and it worked so good that the heat from the crude running through the pipe actually expanded the pipe up with it and pushed it out of the seabed in certain spots. So it worked way better than they thought it was going to.
Yeah.
But yeah, they were worried about shutdowns and hydrates stopping the flow of the crude.
Yeah.
Very cool.
So yeah, pretty interesting.
Yeah, it doesn't take much to put the blanket on.
Yeah.
I suppose eventually it would,
Oh, that's an
yeah.
interesting.
So it looks like you're not close to.
Are we? Yeah, how much longer, Adam?
Are you only halfway or?
No, we're more than half.
halfway.
We
There's
check
only
the
3
map.
lines left.
3 lines left.
Which direction, that one?
To the west. We're about to finish this line, and then there's 3 to the west.
Right.
And they're.
So I told people 9:15,
We
but
could-
we probably
yeah.
do just that, right?
Yeah. How long are these lines taking? Are they 20-minute lines?
Let's see. We have more or less 45 minutes left.
45 minutes.
45 minutes
Oh,
left.
yeah, so.
So
9:30.
9,
Well, that's actually a little bit conservative, sorry.
I think it's longer.
Yeah, it is.
Significantly, because last time I was here, it was. said you started mapping at 6:30? Or 6:15?
We were on bottom at 6:15.
And you've done
and
4 lines, right?
No. We've done 1, 2, 3, 4, 5,
7.
6. We're 7 lines.
Yeah, like 15 minutes, 45 minutes.
So 45 minutes from now.
About 45 minutes to end, yeah.
Roughly, yeah.
So 9:40, 9:35, 9:40 would be when we're finishing. Okay, yeah, we can put that in the.
Looks like
What did you love? Here, get the kiss guy.
34.
Mr. Stan.
34 looks okay. Yeah, I wouldn't go much. 40 which should be a ceiling. 45, but yeah, 35 looks good.
Looks like there's a lobe of a mound to the northwest here.
Maybe.
Did you see any more?
We went over the same, but it looks like this area is just a large circular mound in the middle, and these just really vigorous bubble streams are at the top of it, and concentrated in a small area.
Okay.
So it looks.
Easy to find.
Yes, yeah. These bubbles will. The gas tight will take seconds to fill.
Yeah.
Too bad you don't have more than one.
I know. Well,
We could fill it at 25 meters.
We could
Ooh.
we could have filled the bubbles at 25. That was that concentrated a stream.
Yeah.
Well, you know, actually, the one when we did fill it yesterday, it didn't take that long.
Didn't take too
It was
long?
exactly at low tide.
So it went. You did
I
it.
mean, it took a while.
It did.
but
It was, I think I
maybe
heard
20 minutes.
20
or
minutes.
half an hour, but not hours.
Good. I was worried that maybe the bubbles were bigger than I was showing on the screen.
I think they were just coming more frequently, a
Okay.
little bit more frequently.
Yeah. Because it looked like when we were sitting around poking it, it may have stopped for a few minutes.
It was also low tide, like at
Yeah.
5 or 6 this morning.
Alhamdulillah.
6 this morning,
Yeah.
when you were
Coming down.
over there.
Mhm.
Well, we went
Sounds
back.
like
We
it's
just
a
went-
gusher.
It's a
We went-
gusher,
yeah.
so we went over it this
30
here
minutes ago.
30 minutes ago. It was
Still
still looking
gushing.
pretty good.
Great. See, there's chimneys and stuff like
Yeah.
that.
Do you show Lisa your salinity plot? That was pretty cool.
No.
I mean, the deal is when
Oh,
it
wait,
comes
I'll
out
make it
really
better.
fast as a
Mhm.
gusher, then the AOM doesn't have time to do its thing.
Yeah.
And so there's not so many animals and
Right.
sulfide, and we'll just see.
See what we see.
Yeah. But it looks from the M3 data that we've been seeing on the screen, it looks like this area is way less rocky and very smooth, sedimented. So
Right, people want
there could be a much better chance for cores.
Of course,
here.
yeah.
There
we
are
were
probably
yesterday.
some spots for some
Making
very
up
nice
our-
background bush cores that I know people didn't get yesterday.
Oh, there you go.
to check and see if they even want them today, because they're.
Nope, no one's stop logging. Jules is gone, so no one's doing the clicks.
I can do the clicks.
I got it.
Jeff can click.
You sure? I
Yeah.
can also click.
No.
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 You miss Sage, Scott?
Yes.
Yeah.
I would love
We
that
all
on
do
this
on
bubble
this one.
plume. Oh, if only. But there's a really nice. Yes, I'm gonna make a. Let me get a better figure. accurate this, but on the mapping yesterday, I had those peaks along those southern crossing lines. Some coming in, they correlate perfectly with freshening from the CTD, which is a hydrate dissociation. Like look at that.
So why that's not groundwater,
It's
what?
hydrate dissociation.
Hydrate makes it
Yeah.
fresh. So
Yeah.
that's a paper right
I think so.
Exactly.
Yeah, that's exciting.
Detecting hydrate dissociation by mapping at 25 meters.
You should go back and look to see if there's any other
Yeah.
spots. I mean,
Yeah.
this was the deep sea
This was the
where
deep sea.
there was
This is-
hydrate observed too in the dive.
This is
like
why I
that's
wish,
right.
yeah, it's all
now? Well, you can
there.
make sure, I mean, you can, rather than speculating that it's
Underline.
hydrate dissociation,
Yeah,
you can see it.
I know, yeah.
You have good pictures of
In the line.
hydrate.
In a line.
End of line.
Yeah, that's a different.
But
Spot.
that was a
Right.
different dive.
No, it's the same dive, but that was not.
The sea.
That was not the hydrate that it was coming from.
Yeah, where those peaks are, it could be subsurface dissociation happening.
Yes.
Yeah, yeah. Yeah, because I didn't get a peak at 25 meters when we passed over that hydrate area. Which I
So
think is
these
credence
peaks
to the
are
ice bubble.
diffuse flow where there's no visible bubbles.
Yep.
But the CTD's detecting them. Man, we could start using the CTD, the Toyos.
We've been that's why we put it on here.
Yeah.
We've been we've not sure. Have to maybe do some processing. It's a little, the noisy, because how small of a change are you detecting?
Third decimal place.
Third decimal place changes.
In the
Salinity.
CTD, yeah.
But it does,
They can
it's
occur-
above background.
It's well
Turning.
above noise.
Amazing, but people do tow CTDs
Yeah.
across the bottom,
Yeah.
so.
Yeah.
Turning?
And start a line.
Start a line.
It's like when hydrothermal vents were discovered,
Yeah.
it was like a tiny change in the temperature.
Yeah.
Yeah.
That's all it takes.
Second decimal place or something.
Yeah, as long as it's
Do we have-
statistically above noise.
Do we have O2?
Yeah.
We should look at what O2 does. in those
There,
ones.
yeah. Yeah, I've been looking at it, I've
What do
actually
you
been.
expect it to do? Do you go down
Mhm.
from
Oxidation in the water
oxidation,
column.
not from the source water?
Adam, in a hydrate waters? Or do you mean
Well,
generally?
methane oxidation would
Little
take.
divot.
Well, I've seen, yeah,
That signals what.
that signal's clear. This, I don't know if this site's good. It's,
Well, you could check. what
Yeah.
this oxygen did, right?
yeah,
That-
and it's
sequence.
gorgeous signals, cross signals between methane and oxygen in
See what the temperature is.
Bio Canyon.
You weren't here for the clicks.
Oh my god. I had to tell so.
That's all right.
Did you do it?
We did the clicks.
Looks like we're gonna start getting shallow.
Getting shallow.
Meters.
Yeah. Okay.
I'm sorry for letting you down. I won't do it again. I'll never live this room again.
So lively. Yeah, wait, lively. Tell me.
I'll never do it again.
If you ever have an issue where you don't have altitude, that's why I always have the sonar range up to 30.
Wait, yes, lie to me, please.
So. Exponentially see if you get brighter as you get closer, but this is your 20-meter warning before you smack the bottom. I like that.
See, did we just find a seep detector device called a CTD?
Oh, did you see it?
Oh, that's interesting.
Tell us.
There's a temperature signal with that plume.
What does it mean?
It's
it warm?
spikes.
Temperature warms.
We got a warm seep.
Because we have
From
Gas?
yesterday?
That's from yesterday.
Warm
So it's
fluid
warm,
is
fresh.
dissociating hydrate, which is making temperature.
Funky fresh.
fresh.
And it is funky. Oh man, we need to take a core here.
Yeah.
Except, you know, on the wire, they can pull it out.
We can do it with the
Do
small
a little
core.
core.
Because this would be pore fluid would be
Yeah.
very interesting here.
Yeah.
Did we do any temperature probe yesterday?
No. And it's,
I
the
wanted-
temperature
I
probe right
wanted
now
to,
is
but then I
measuring
was-
minus 86.
Is it still measuring that?
Problem.
Oh, we're getting some
Did
sort
die.
of
Yep.
mound.
Yeah, we're getting some features. In the
Yeah, the
bottom.
northwestern part of this has
Some structure. some-
features.
some water.
I think it's the pale purple in the ship multi-beam map.
Pale purple or dark purple?
Pale.
See, now
Now I don't know, Jules.
I don't
Yeah,
know either.
no.
I think you're right. I think
I think that's higher.
I think we might
elevation.
need to do at least one, depending on what the push, if the sediment looks like it's favorable for coring,
Yeah.
some pore
Look at
fluid would
that.
be great here.
Okay, they should also come here.
Yeah, this is a
Can
very.
you mark? Should we
Drop a
it?
mark.
We should drop a
a
marker.
targ
Drag a turd.
Durgator.
and say, interesting seafloor.
Everywhere
know.
else, uninteresting.
I mean-
seafloor.
Well,
yeah,
to be fair,
actually,
all-
the entire eastern part.
this
of
this survey has two spots:
Yeah.
the mound in the middle with the seeps, and this thing.
2 spots is pretty good.
That's pretty
We
good.
barely made it
Pretty
to 4
good.
spots yesterday.
That's all we need. Let's keep it
2 out of 3 ain't bad.
reasonable. 2
Yeah,
spots.
2 spots.
What kind of temperature changes are there? I mean, can you remove till we get to
0.08 degrees.
where's when we're actually flying the survey? Is this descents and stuff?
Yeah, so this is. So this is
Adam, can you
descent.
explain what's going on with the waterfall?
Yeah.
What other thing should I
Oh,
put
you-
on?
I can. I mean,
Either way.
I think the third part of
Go
CTV
for it,
is
you have the
really.
mic.
Yeah, so if we're looking on the display at
On
the
what
upper
part?
right-hand corner,
Oh,
that's our waterfall
CT&D.
display.
No.
You can think of that as an overhead map of the seafloor, and the colors are indicating elevation. The red is shallower and the blue is deeper, and so that is reading in real time off of our M3 Sonar fan view, which is directly beneath it. So as that light-colored horizontal line goes up and down, it's recording a profile of the seafloor, and then that is getting plotted above in our waterfall display. So we're getting sort of a real-time image, overhead image of what the seafloor looks like, and you can see there's like a shallow sort of lobe and mounds in this area, which is always something we're sort of interested in because we know around gas seeps they can have constructional features. That is things that are built up on the seafloor, like mounds and even rocky outcrop that is made out of authigenic carbonate rock, which forms at seeps. So when we see more complex seafloor structure like this in the waterfall display, that's always a good sign of interesting place to go look.
Oh, wait, did I already last something yesterday? No, I didn't. Discovery.
The ROV does not have ORP sensor on it?
Mm.
Okay. Darn.
It's a CTD.
CTV does.
Yes, we put it on. PMLs, CTD,
Yeah.
share markers.
How many of those do you have?
Uh,
4.
mapper or CTD or the
Mapper. Sorry, how many mappers do you have?
somewhere between 2 and 4. I have a big box in the main lab for leg 2.
Okay. Do you have a pigtail for that?
For the, do you want real time coming out of the mapper?
That's
I think
supposed
we
to happen on leg
Yeah,
2.
I have the cables. Sharon gave me the cables to make that work.
Okay. Can you give them to the RV team? Because then we can start splicing that prior.
Yes.
Okay.
I should. Do you need a mapper also, or do you just need the cables?
We have the wire diagram.
Okay.
Unless we need to make a specific map for it, but I think we've hit it. Do you guys want a mapper?
Take one when we get ready to test it, yeah.
Okay.
If you have the program and everything and you know how to test it. Otherwise, we're just gonna take power.
Yeah, I can. We'll start giving you the cables. I'll get the thing out
Okay.
and take a look at what I've got. I've done mappers with the program a while ago.
Alright.
Anson is going to be doing that.
How much experience does Catherine
Some.
have? Okay.
Then he has a direct line to Sharon, who,
We love her.
yes, makes all of this possible.
Yeah.
In fact, I can give you some fleeter mouse and some stuff that Sharon mocked up for the hydrothermal vent to help hone it in even more
Like
refined.
Graphical maps.
So I think
Okay.
there's some fleeter mouse and some other stuff. I should show you what she's given me, because
Is this
you're the
one-
connection.
Is this the
Yeah.
one where we had like the graphical representations in the area of like any sort of anomalies and then we would, okay, for the Toyos?
This was, she has replotted the Toyos from the 2010 and 2012 cruise that went to the triple junction.
Nice. That's helpful.
Very helpful.
Very cool.
I guess the connecting the mapper with the pigtail will get you a real-time feed, but it won't plug, it's not gonna do power to the mapper, so
It will do
Yeah,
power.
It will, okay, so it will, you won't have to change the batteries and stuff.
Yeah.
Those
We've
things go
done
through
it-
batteries like
we've done it-
nothing.
Yeah, we've done it before.
Okay.
I think it still has to internally log, but it can give a real-time output, but I could be wrong.
This is one I was, so the CTV right now has ORP, but that's analog.
Yeah.
And that can't be used on Sebastian.
No, Sebastian has no analog to
No,
serial.
okay.
photos, yeah.
Darn.
I know. But
But the mapper can work.
the mapper.
That's oxygen.
Is that right there?
Yep.
Because they look almost like they're-
Yeah.
It's identical.
Yeah.
To, what is this?
Salinity.
Salinity and oxygen or just, and
Temperature.
everything, same.
Yep.
Cool.
Decrease in oxygen.
Get your paper written already back there.
Yeah.
Get your figure done.
Just screen grab this.
just a screenshot
So
full,
fit.
including the toolbar.
And the tool, everything.
Everything.
It's a timestamp.
Yeah, exactly. Convert my computer time to UTC real quick. Take a screenshot.
This is
We're almost done. 2 more
Float up.
lines.
Almost
Yeah,
there.
I think you should take
Greg's probably awake by
this
now,
one to heart.
looking at all the worms.
Yeah,
Not
that's a
very
good.
likely.
That's a good one.
Yeah, that's a real good one.
That's cool.
In 3 in the morning.
No sage, just in 3.
I know,
Morning.
Sage is on vacation.
Get the pointy sticks down.
This isn't pointy.
It's pointy.
It's soft.
It doesn't matter. It still comes to a point. We're done.
Is this the equivalent of pointing at someone and that's
Yeah.
rude?
Sure.
I think it's where we said point.
Let's go with that.
I think this is actually called a pointer. So yeah.
So technically, it is a pointy thing.
It is a
Even
pointy.
if it's not pointy.
really want to 3D print this for us.
RV has unlimited filament.
Just add your tools. Just throw the boxes away when you're done, don't want to see
Okay.
them.
I took that to heart. I mean, what is it?
But it was a
But it was a big one. Oh, look, my neighbor's cleaning my porch. Oh, wait, that's really cute. Yeah.
Why is your porch so dirty? People are coming over.
I have no friends.
Probably had a party out there for
Yeah.
Halloween.
Yeah.
Trick or treat with my age.
So great.
Your white balance is off.
I know. I do too. Should I do a white balance?
End of line.
End of line.
All right, 2 more lines to go before we're done with the M3 map and can proceed to the seafloor. So we've probably got about a half hour left of M3 mapping. And then we get to go see what's at the bottom of all those bubble plumes.
Started cross line.
Start line. You're gonna have to hang out until we get to the.
Yeah, well, we definitely need to go see the
Yeah.
bubble.
Yeah, I can't go to bed until I see the bubbles.
That's the mapping from yesterday.
That's not.
That's that big. That's
That
that sharp
big,
peak.
yeah.
That's
But
the
then
one that has a very different
the-
chemical signature in the water column. And then
Yeah.
that. Yeah.
But who knows how far away.
Right. And that's the one where
It
just
just
correlates
yeah.
to everything.
But the seep was like here, right? It was up.
Yeah,
here.
the
You can see where
it was there.
Yeah. No.
So, I mean, something was down.
Someone was that away.
Yeah. Yeah.
That's what's tough about these. You know, we're just going so fast.
Yeah.
One dive at each spot.
Yep. Here, Adam, here you go. Here's the yesterday map.
Yeah. Let's see.
And that's that one
Mhm.
sharp peak.
Yeah. Very cool.
Oh, I found where we backtracked.
Yeah.
And the cross line.
And a crosslock.
And across
And
line.
cross line.
Two more lines.
Right, Jarvis, you got an updated waypoint?
Go over that.
This might be the last M3 mapping of the
So.
leg.
Saying so, yeah.
Well, if we're
Are
gonna,
we doing a 100-meter dive?
I don't know.
I don't know.
That's the hope and dream.
Hope
Is there no-
and dream.
Yes.
Is there a 100-meter seep?
There was.
There is a 100-meter seep.
It's better than a 45-meter seep.
It is. Well, we didn't go to 45 meters. Who knows? Maybe there is one there.
It's like super deep
At
water.
that seep.
All depends on the weather.
Okay.
Boat can hold the station where we need it to be, then yeah. Which it sounds like the weather is getting better right around noon.
Yeah.
I guess this is just like a rainstorm or something that's going through.
Yeah.
It's so
Knocks down
cozy.
earlier.
Wish that windshield wiper worked on that camera.
Does it not?
Nope, it's not even there anymore.
Are you kidding me?
Are you kidding?
Hard to get good parts.
Are we there? What does it indicate?
What's the name serious? Gas speed.
There he goes.
I
We're
see.
Turning.
That's the clearest indicator.
Tony
Start of line.
Start a line. Start of line. That was a lot of clicking there.
Yeah.
I saw that.
I think I like created a new one during the turn. You'll figure it out.
Just fix it in post. Fix it in post.
Because I was waiting for us to end the line, and then we didn't end the line. We turned, so then I ended it, but then I should have started it, so then I started it. So I think I locked the turn, but it's in its own file.
That's what you want.
Yeah.
We haven't
That's
been
ideal.
recording the turns. I haven't been recording the turns. Not the cross lines, the actual.
Oh, yeah. Cross lines, okay. Turns, no way.
Yeah. That's our motto.
Yeah.
Get that tattooed on.
That's gonna be the new cruise t-shirt.
Did you log the turns? Question mark. No way.
No way. Although, yes, right. This
For that time.
For this time.
Except that one time.
Except that
When I
one
did
time.
log.
Yeah.
We can forgive, not forget. Forgive.
I wouldn't want you to forget.
No. Never forget.
I also don't really want you to forgive.
So the resolution, the grid size that we're able to make from the M3 mapping data is 0.5 meter by 0.5 meter. So 50 centimeter by 50 centimeter.
So what does that even mean?
That's something.
That means that if, well, in the image that we can make, a pixel of one depth will be a 50 centimeter by 50 centimeter box.
Okay.
So what is 0.5 meter in like real things?
A coffee table.
Coffee table,
Yeah.
usually it's like a coffee table is 1 meter to 0.5 meter.
A backpack.
Chair.
Chair,
Me.
you're 0.5 meter. You're letting,
I'm small.
you're a 0.5 meter person. So we
Two soaps.
can resolve
3 soaps.
things that are in the meter to close to sub-meter scale.
Yeah.
You don't necessarily say you can resolve something, because the grid is 50 centimeters by 50 centimeters doesn't mean that you can resolve things that are 50 centimeters in size.
Okay.
Because that would be 1 pixel.
Yeah.
Is-
And you have to be able to identify
Define
it.
it, right.
So Consberg says 3 or 4 pings is minimum
Yeah.
To resolve
to
something.
resolve something.
So 3 or 4 pixels in this case would be about 1.5 meters
Yeah.
to 2 meters is our resolvability.
So you could resolve Juliana.
If I'm
Yeah.
laying down, but you could.
Maybe if you were, yeah, you'd have to lay down in line
with
with
your
the,
earplugs, because as per yesterday's story.
yes, with earplugs, because you'd feel, well, not with this, because this is 500 kilohertz, and you would not feel this because it's too high frequency.
Right.
But it often gets thrown around, the word resolution and grid size,
Yeah.
and they're not synonymous. They're not exactly the same thing.
Same
But
with
your
that.
higher, your lower your grid size, the higher your resolution. So we can see things that are pretty small. we can see things that are like a coffee table,
Yeah.
Yeah.
would be a few pixels.
Whereas if we think about the ship's multi-beam sonar, which we're
Yeah.
using as the ship goes over, our resolutions are anywhere from 20 to 50 meters. And so 1 pixel might be the size of your house
Yeah.
in that situation versus a coffee table, to give you a sense of the level of detail you can get out of the M3 versus the ship-based sonar. And that also kind of gives you a sense of what you can resolve in terms of things you're really looking for. So, for instance, if you were on the hunt for, say, a shipwreck, it's possible that the ship-based sonar might not even be able to pick it up if it was not a particularly large vessel. And so that's the sort of things you have to keep in mind when you're searching for something. If you're searching for something with the ship sonar, what size is it compared to the pixel size of the sonar?
Yeah. One of the first questions you ask yourself when designing a survey is, what am I looking for? And what is the size of the thing that I am trying to resolve? And what tool can be used to achieve that? So finding coffee tables on the seafloor at 1,000 or 2,000 meters water depth, the multi-beam will not do that. The multi-beam from the ship, but a multi-beam from an ROV that can be 25 meters above the seafloor can resolve those things.
But if your goal is coverage,
Right.
you don't want to survey with the M3, you want to survey with the ship.
Right.
If you're looking for, well, then it comes down to what is considered coverage.
Yeah. We're just dive deeper and deeper.
Yeah, survey design.
That's the best worlds.
But best of both worlds would be,
Tough.
it depends
Maybe an
on
AUV, yeah.
AUV because we're not using ship resources.
The best of to have lots of coverage, but at very high resolution, you would require to have, at the current technology, a fleet of AUVs.
Fleet.
What about the
Superior?
topside ones, whatever they call them?
ASVs?
Yeah, the ASVs.
Well, the ASV still deals with the water depth.
True.
Because it's still the same distance from the ship to the seafloor. So your resolution or your grid size is still a product of the beam, the acoustic footprint. But let's say what we were getting in water depths like this at 2,500 meters, what can the 124, 7 kilometers
Yeah.
swath width?
Yeah.
Maybe more?
It's
Wow.
Mm-hmm.
So
almost
set
double, generally a little bit more than double.
two times water depth, maybe
Yeah.
2.5. So if you wanted to achieve a 6 to 7 kilometer swath width with AUVs flying at 50 meters altitude, those get somewhere between 200 to 250 meter swath width. So take 6 kilometers divided by 250 meters, and that's how many AUVs you would need to be surveying simultaneously to get the coverage.
24
Could you
AUV.
not outfit it to run just like subsurface by 100 meters to get bigger swath width for your coverage with different sonar?
No.
You
Well,
can't?
you would,
Why?
you could, but the trade-off is how big of an AUV can you get?
Okay.
Because to get a smaller beam, you need a larger array.
Gotcha.
So your array size starts becoming a factor for, once you get to 100 meters, your resolution is going down with the same system. Because your beam is the footprint's getting
Right.
wider. So you gotta be close enough to the seafloor. So if you had a really big array, like a giant AUV could, there's a phone, bingo card.
Phone drop.
Phone drop. Yeah, there's some things that people are working like synthetic aperture sonars where your array is not a physical array, it's like a one that is moving.
Oh, okay.
So there is some, theoretically, you don't necessarily need to be right at the seafloor. But that stuff is getting, it's like theoretical, but there's some proof of concept with like that stuff.
The concept of an array.
Of a synthetic sonar array.
If I were designing an AUV, I'll put a 2040
There you go.
in SAS,
Yeah,
cameras,
always.
not just like obstacle detection, but just like strobe
Photograph.
cameras.
Yeah.
Yeah.
And,
A sub-bottom profile.
of course.
Yeah.
Get edge
Got
tech.
to.
Bought a little mesh bag and put styrofoam cups in.
A
That's
what?
right, you need to have
Goes
Well,
without
This is
saying.
very fit. Sorry.
Sub-bottom profile would be nice.
That would be so cool.
That would be nice.
I could show you some AUV sub-bottom data from some Seeps in Cascadia, which are pretty cool. We tried on this cruise to get them. Adam and I had an
You
NSF
did.
proposal that had money to rent a sub-bottom profiler to mount on Sebastian.
Yeah, we had one reserved.
We had it reserved.
And what happened?
It didn't,
We didn't
the
get funded.
proposal didn't get funded.
Oh,
Boo.
Boo.
Because it's not a NSF ship? We could do
That's
it
not the only
cross-stream.
reason why. Let's take this offline. No, they're hashtag reasons, but the, we had requested support funding for an orbit to swap for the M3, and I had that on reserve too, a 6,000 meter depth rated orbit.
Wow.
And-
I wish we had that.
And the sub-bottom profiler,
Wow.
which would
How big's an orbit?
about the size of the M3. They're not very big.
Wow.
It would I
wish
would have
that was-
requested us just mounting it where the M3 is,
Yeah.
because you have all the offsets already kind
Yeah.
of figured out for that. Now I'm not sure where we were going to put the sub-bottom profiler.
No, it's not
That
that
would have
big,
required
but we would have
some talk, like where to
taken
put-
some thinking. Yeah, where to put that.
Well, on the bottom.
Well, that's
Yeah.
ideally where you put it.
Yeah, you want to put it on the bottom.
Just put it on the bottom of the skids.
Yep.
So when you sit down.
Yeah.
Well, that
Is
helps
the
the sub-bottom
sub-bottom.
profiler. You put
Yeah.
it in sub-bottom.
You literally just put it under the sediment.
And then it
start-
profiles.
Yeah. It's just doing what it's
Isn't
supposed
that
to
how
call.
that works? Why would
Just
they call it
helping
that?
a little bit.
Yeah. Taking away layers that it doesn't have to see through anymore.
Right.
To profile the sub-bottom, you must become the sub-bottom.
But I wonder if Kongsberg has done any work, or other companies, on taking the SPP-29 model and thinking about that for like an AUV for smaller, using the multi-beam array as the receiver array for the sub-bottom.
I bet.
That
Yeah.
would be
Would think.
cool. 2040.
Scale,
As
yeah,
a
use that as
receiver
the
array.
receiver array, yeah,
Swap pings, a multi-beam ping, and then a sub-bottom ping.
something like that.
Yeah. But Kongsberg announced that you don't need a standalone transmit array for the SPP-29 anymore.
You
It can just use the multi-beam.
Multi-beam transmit.
Transmit and receive.
Yeah.
304 can, with a the Mark II 304s with a firmware upgrade, can just be a sub-bottom profiler on its own.
It's like you get an extra sonar,
Wow.
which you didn't know you had.
Bonus.
It's bonus.
We have the hardware.
You do. You have the dedicated transmit array for the sub-bottom.
You think that would give you better?
I don't know. I'm not really sure what the trade-off is.
Me neither. There's no way of knowing.
Technology's not there yet.
the tagline of
That's the
there's,
whole-
there's no way of knowing.
I love how your tagline of "There's no way of knowing" is on a research and exploration vessel designed to go know stuff.
Know stuff.
Yeah.
There's no way of
The
knowing.
whole-
As she's
We're
surrounded
here to
by
explore
things
the
that let
ocean,
you
but
know
we acknowledge
things.
it's impossible to know anything.
Are we ready? Oh, didn't feel that windy outside.
I think you're like the only scientist that has utilized Grafana.
Yeah.
Really?
Oh no, I'm looking at windy.
I'm also looking at Wendy.
Yeah,
We have our
My-
own weather station, people.
my computer's in the other room charging, so I'm not using Grafana right now.
We do have power outlets
Um,
in this room.
But I probably have been the only person who's been
Yeah.
utilizing Grafana. Yeah.
Absolutely. I would appreciate it.
I don't think I've utilized ship Grafana yet. Exclusively Sebastian.
End of line.
And a line.
End of line.
End of line.
So
Making a turn.
if you
Turn.
go at half the height,
Going down to 25.
do we get double the resolution? Not inherently, yes. You don't, you
Not
can, it
inherently.
helps, not
Start of
just
line.
blanket, yes. But
Start a line.
it starts, it's a prerequisite. If you wanted to double your resolution or your grid size and increase your resolution, you would likely need to get closer. I'm answering a question on the chat,
Yeah,
which
I-
is about, so you get down to, you have uncertainties in your measurements. Like where, like for the multi-beam, the M3, every sounding has an X, a Y, and a Z. And each one of those X, Y, and Z's has an uncertainty associated with it. So you start getting to the point where your depth measurement is really precise, but you're uncertain about where that measurement is because the movement of the ROV, the uncertainty in the sound speed velocity, the position of the ROV all comes into play where at some point you can be making many, many measurements, but you don't know very precisely where they're being made at.
Yeah.
So that comes down to you become your weakest link is what sensor, what link in that chain has the biggest uncertainty, propagates through all your measurements.
Yeah.
So it's not a matter of just getting closer means you get better resolution.
End of line.
End of line.
Red RV, got an updated waypoint.
But slowing
Go over
down also increases.
You're a
in
long
way,
track.
You're a long track resolution
You're a long track
coverage.
soundings density. So yeah, a lot of times with the ship, your biggest limiting factor for your grid is the speed of the vessel.
If you were to go really slowly and just do a bunch of crossing line, like cross your own path a bunch and have a very good temporal space between those pings, could you reduce most of that uncertainty? But it's not useful because then you get, it is useful because then you get terrible coverage. But if someone wanted to do bunko nets for 6 days straight, and you had to be going a knot and a half, and you just went back and forth over the seep, even at 2,700 meters, could you get decent resolution through reducing that uncertainty?
The biggest with the ship.
With the ship.
The largest source of uncertainty in that case would be every beam's insonified area.
Okay.
You have a 1 degree beam
Yeah.
from this transducer down to the seafloor, opening at
Yep.
1 degree.
Yep.
So what is the area of that insonified? And your depth is a random point well, not random, but it could be anywhere from inside that insonified area, is the X, the Y.
Yeah.
You only know the position of the beam. And you can't, but that becomes your biggest limiting factor is your insonified area of each beam.
But I guess that's my question is if you had infinite insonified areas, right? You could figure that out theoretically. Like statistically, you could figure out to a very good degree, but you can't have infinite. So like, is there a crossover
Like
point?
if you
I don't
pass
know.
the same area,
If you have like a
100 yeah, you would. I think-
100 square meters on the seafloor that you happen to have gone over 70 times at one knot.
See, I think
You
at
actually
that
have a
point,
ton.
you are then
have a
having
lot of-
your error in
Yeah.
your navigation.
Yeah.
So your insonified area, you're
You
going over
reduce
the,
that
you're
error.
assuming the seafloor is not moving at all.
Yep.
So then you have error that propagates from your
From your ship nav.
from your ship GPS position, the attitude,
Yep.
the motion,
Yeah.
all those things.
Yep.
So I think those things technically, yeah, even if you just could keep
If
going, but I don't know
everything's perfect.
what the tail
Right.
is, or like how
Right.
long.
Right.
Because
The noise becomes almost unmanageable because there will be some noise, and then suddenly you go from having this somewhat defined to having like kind of a cluster of where the bottom is.
yeah, that's what I've noticed with mapping. It's actually doesn't make a better grid to have more coverage. Like you need one line that's really good.
Yeah.
You're fitting a surface to a point cloud.
Yeah.
And you can have more and more and more and more points, but if your certainty of where each of those points is isn't improved, you just have more of them. Fitting that surface through that point cloud doesn't get any higher resolution.
Yeah.
Right.
Well, I think it's what Jeff was saying, because you do decrease your insonified area noise if you have 60 trillion insonified areas that are overlapping. You get a much better defined point cloud. It would take complicated statistics, but if everything was known perfectly topside,
No,
you
that's-
should you. But it's
This is
but
why
it's
you
not.
can, like, this is why geodesy works.
Right.
You can remove a lot of variables
Yeah.
by just having many measurements.
By having yeah.
Yeah.
Right.
But
Because
the
like
fact
if
that
your
the-
system is stable enough, you will have white noise averaging
yeah,
for an incredibly
It's like, what is
long
a-
period of time.
like 1 over n or so.
1 over n squared.
1 over n squared. Like you will, that does apply, but I think the uncertainties in many of the motion sensors and position sensors make that need to
Overtake
be
that.
like
Yeah.
might be like thousands of years or something.
Yeah. Yeah.
Because you're at it, if you want to do like a simple mean, like if you have 5 soundings in one square, or 5 soundings in a bin,
Yeah.
there's a lot of noise in those.
Yeah. Well, this is where it becomes, right. This is where it like, if you have that precision and you're like, okay, these bins are overlapping to certain degrees.
Yeah.
That's where that comes in, but it's not. You don't have that.
Mhm.
Yeah. So Adam, with what you were just saying, right? Yesterday, when it was
We're on the phone
oh
halfway through the
we're
last
gonna
line.
do
So you have to go
we're
all
gonna
the way to the bottom.
map
Go to the bottom.
and do the bongo nets and
And
we'll
then
map over the
we're
bongo nets. Did that make it?
From the bottom,
Was that what you just said? You just
where-
had a more
where
spaced
those
point
green
cloud that you were fitting a
waypoints
surface
are
to. So like
on the middle,
so
or to
so
the right of the
going at
map
2
screen,
knots
that's the
doesn't
biggest
improve
thing.
going at 6 knots.
Which
We have those 2 data points for
go to the
Falcor
seafloor
2.
and just go to there, right?
Going slower will just
What?
decrease the space
Yep.
between points
Wheel
along.
function.
Yeah.
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 You
So,
want-
But
ten
it-
more minutes.
But if you have enough noise, what you were just saying is
Tyler,
that can just make
how
a
many more-
wider
What's the ETA to
band
finish
of
the
the
slide?
bottom. Like if you have enough noise,
exactly.
right? So if you had it perfect, going slow would be really good, but it's not, yeah.
At our current rate of speed, barring
Come on,
anything,
don't be cheeky.
it'll be done in 8.333333333 minutes.
That's being cheeky. Okay, 8.3 minutes. We'll go to the bottom.
Recurring.
8 minutes.
We're talking about precision.
Well, he wasn't very precise with his measurements,
He
so
wasn't.
maybe he should do it again.
Actually, I think we could
I'm just kidding.
say that 8.3 repeating is very, then we can be very
What
precise, it's 8
happens
minutes
if
and
we
20
speed
seconds.
up
Yeah, 20 seconds. Why?
0.1 knots?
What's that?
So
More
if we
fast?
speed up by 0.1 knots.
Please,
we
0.1.
could do it
Then
in
we pass the boat,
minutes.
and then the boat has to speed up.
Well, there might be enough legislative more cable. There's more umbilical.
Just let some cable in.
So close.
So no more big gushing.
No, I think it's very concentrated in the middle. Although there's smaller seeps around the big one. So there's
Based on
the
the ship.
M3 map.
No, we saw like 4 plumes in M3.
4 individual
So you-
streams in the M3, but there's one really big one in the middle.
And there's,
So there are more.
Yeah,
Yeah.
but they're all
But
close
they're all
together.
right
They're
there.
probably within a few meters of each other.
Okay. Oh, it should be beautiful.
Yeah,
Like,
yeah, we're gonna get
upside
some
down
cute-
waterfalls.
Yeah.
And there's one area that the seafloor didn't look like flat sediment.
yeah,
outside
it's
of-
rocky.
Yeah, it seemed like it had a
Oh,
circular, small kind of,
Yeah.
like maybe a, it
I
had
was
a
gonna
high
say, it
spot
might
and then
not
a
be
moat.
good day for rock collection.
It didn't look like, yeah, I'm not sure what it was. We had that marked as well as another waypoint, but, and it's relatively close to the big streams.
Have you seen any interesting marine life at 25 meters?
What did we,
Photos.
marine life, did we see?
we saw Florida.
We
Saw float, yeah.
Mucous membranes,
Fish.
bubbles.
One jelly.
tail. Oh yeah,
Oh,
one
one
cool
jelly.
jelly.
Boogers.
What was that? Oh no, self left. What was the name
I
of that?
can't remember the name of the jelly.
Maybe did I?
Are we on the, I saw up there, water columns most wanted with the worms.
Yeah, we saw a bunch
I
of
think
those.
that's great.
They're in this area, I think there are some.
Coralia.
Oh, the twisting worms.
Yeah.
Yeah, that's cool.
Have to finish this one. That's good. So you're gonna stay up till we get.
Oh, I wanna see the bubbles.
Yeah, we're gonna have to see the bubbles.
We started early enough too, where not super, well, I got a little sleepy last night.
I don't know. There's been multiple times when like I've just left as the dive starting, and I go to sleep, and I wake up like 6 hours later, and I'm like scrolling through my phone to see like
Just
did
checking
we
the
find
WhatsApp
anything?
message.
Check
Just
the
following
WhatsApp
the
recap.
Like, oh,
That's a good, you wake up and like, all right, what happened?
what happened while I was
Man.
asleep?
Yeah,
We're
I
not
don't-
that good about putting things on the chat though, about what's happening, do
The chat is a lot of requests.
we? Yep.
A lot of
You get an idea, you're sitting here and it's all incoming, get me this, get me that.
a lot of requests.
5
and
course.
a lot
course,
of Greg and Maritza identifying things in real time from somewhere else on the ship.
You, well, that's helpful.
It's really
It's very helpful.
I will move back, I'll go to the peanut gallery as we approach true handover.
Would you like the chair formerly known as Sage Chair?
No, no. I will sit back here.
Oh.
You have to be wise to sit in.
Yeah. Oh.
Yes, that,
Oh no, I don't think I can.
What
live
are we
up-
gonna
I don't. I
say?
can't live up to that
we
one.
missed Sage a lot today.
Yeah. Oh, I still do. It'll be on tomorrow if we do a 100-meter dive.
Yeah.
We'll see.
Can we,
There might be one
can
more.
you measure the methane in the Niskins or something to help us get a sense?
There's not really enough volume is the problem.
You have to
It's-
take a lot of the Niskin.
No, there's actually not enough, because you're degassing into the system.
Oh.
There's not enough that you can just achieve continuous flow through the system. You have to recirculate it through the bottle, and then you're just gonna see some sort of spike and then continuous decrease.
Got it.
A shrimp.
Shrimp.
Are you
Two
guys-
shrimp.
Are you guys live on
We are live.
We are live.
People, we are live.
there? Are there people watching?
Yeah.
Yeah.
There's plenty of people.
They have been enjoying our discussion on mapping and resolution
Open data.
And hydrates.
and hydrates
And bubbles.
and bubbles,
Bubbles.
bubbleology.
Period.
We're so close.
And there were some really in-depth hydrate discussions today.
Yeah.
Mapping technology discussion.
Mapping technology, survey
I wish
design.
I heard
I
that.
could, but
Recorded.
yeah, it's on the
It's all on the YouTube, yeah.
We're done.
Doug, are you just zooming out to make it look closer? Guys, we're on the vessel.
Yeah.
I like your analogy with like the time, how you could just have an infinite number of measurements. It's the equivalent of like, if the person with one watch knows what time it is, the person with two watches never
Never
knows.
quite
But the
sure.
person with an infinite number of watches
Knows exactly what
knows
time
exactly
it
what
is.
time it is.
Yep.
Right.
Because the statistical, reducing the uncertainty by having more measurements.
Yep.
But no one has an arm long enough to hold an infinite number of watches. So
Why does a watch have to be on your arm?
that's the joke. The feasibility of getting infinite number of measurements or even approaching it becomes not possible.
It is like, it's like traffic, there's almost an infinite number of cell phones recording
Yes.
their
Yeah.
speed
Yep.
for the traffic app, right?
Mm-hmm. That's how it
So
goes.
we know exactly.
Yet it's always wrong.
Yet it's always somehow wrong.
No, it's not.
No, it's
It's
pretty
usually
good.
pretty close.
Not where I live.
On the, on major roads, it's
Oh, yeah.
pretty good. Crowded
It
roads,
doesn't-
you know exactly when you're gonna slow down and when you're gonna stop.
Mhm. Now, your phone routing you around the traffic may not do very good though.
It's not
Because it
bad.
becomes an interesting problem with, if everyone is using
And
a
then
traffic
everyone-
They all
app
do
and
that.
And
now
then everyone
they'll all go
reroutes the
take the
same way.
reroute.
Yep.
Which then creates more
Sometimes the
traffic.
reroutes go by my house and it's really off the freeway if it's really bad.
The traffic app makes more traffic. In other,
Traffic app makes traffic, that's true.
it generates traffic by people using it
End
to
of
go away from
line.
End of survey.
In the survey, yay.
All right.
To the seafloor.
That is the mapping team signing off.
Down.
Time to go explore the seafloor.
Let's go see those bubbles.
To the bubbles.
That was fun.
To the
Yeah.
bubs.
Starboard.
Would have been fun over Sage.
Would have been way better, but
I agree. Don't worry.
Sage envy.
Good morning, everybody, afternoon, evening. The seafloor crew is taking over as we descend to the bottom to find out what those massive bubbles really look like when they come out of the seafloor. This is Lisa Levin from Scripps Institution of Oceanography at UC San Diego. And I will let all the new people in the room introduce themselves. Who's there? I guess Erin's not there yet.
Hi everyone, my name is Paula Santiago. I am this morning's data logger, and I am a graduate student over at the University of California, Santa Barbara.
Hello, my name is Praxedes Muñoz from Universidad Católica del Norte, Chile, in Coquimbo. Full professor, chemical oceanographer.
Let's stop and see what we see. I'm seeing xenophyophores all over the bottom. How exciting! We haven't, at least I think that's what they are. We haven't really seen a lot of these.
Yeah.
Anybody out there know what xenophyophores are? No, they are giant single-celled protozoa that agglutinate sediment particles to make really elaborate tests. Test is the word for their home. They function like little sediment traps. They're little biodiversity hotspots with lots of different animals, but I'm going to talk about them once we have them on the screen and can zoom in. They are not methane seep organisms, as far as we know, so
Yeah, no, that's fine.
well, maybe they aren't these. These look like little clusters of worm tubes. So we want to pan around and look at a few of them.
ROV bridge.
Go ahead.
It's funny, they really look a lot like xenophyophores.
They shifted a bit, so I'd like to bring the ship's head round to a more westerly direction. If that works for you guys, you could maybe just give me a waypoint south of your current location, and then I could work the heading round.
Yep,
There are
no problem for
xenos
us. We'll do that.
that have tubular structures. These look like, well, actually, could you, where's my pointer? I don't have it.
Someone's absconded with your pointer.
Jeff, you have
The lead pointer, sorry.
Thank you.
There's updated
They're
waypoint,
lost
Tony.
now.
Here,
Thank you.
You're welcome. It's not as long.
Could we zoom in
No,
on
but
to
it's
this
got
one?
the
It's got a
hand.
pointer.
She just needs.
Okay, this platy appearance really is xenophyophore-like, this part of the structure. I'm just not used to seeing the tubes, so it's possible all those tubes are worms that are living in and on them. So xenophyophores occur usually on sloped settings. It's on seamounts and on continental margins where there's a good particle flux and they trap food. They're almost like little honeycombs in some cases. So I'm thinking that's partly what these are, but there's also a lot of tube openings, and that doesn't look like a xenophyophore. So I know we want to go look at bubbles pretty quickly, but one question is whether you want to try some coring here. Is Erin here? Yeah. Kind of want her okay on background coring, because we do need 3 background push cores according to the dive plan. Could we zoom in on a couple others of these? How about this one?
Oh, you were just trying. Yeah, you turned off. Amateur hour.
Can you guys grab it, or please, Paula, can you grab a frame grab? I think these are xenophyophores, and it's just a different morphology that's more tubular. You got a picture?
Got the picture?
Yep. Question is, do we have enough push cores to take one?
Everything's on her way.
What?
Everything's on her way here.
What was that then?
They're really fragile, for one thing. Zoom over here, please. These are fecal pellets. What we're looking at, probably a sediment deposit feeder, capitellid. It's a pretty busy seafloor. Lots of life down here. You want a sediment core, Pachi?
Yes.
Background?
Yes.
Okay, let's do a test sediment core. You want it not over a xeno or over a xeno? Could we have one over?
Yeah, we could see what is in.
We just came.
Okay.
We're at the seafloor, they're gonna get some background.
So we want to core one of these structures.
Yes.
Yeah.
Do you want porch or?
Three hours all the way out.
Picking up top.
Hopefully not. I know. Yeah,
Alex,
that's the way
favorite
it
one.
is.
Lisa, we're
They
doing
need
too
background.
much of orange.
Oh, Niskin.
I mean,
Niskin. Sorry. I'm sorry. How do we forget that? Every single time. Niskin first.
Lisa, what are the orange clumpy things on the ground?
I don't know about the orange. I'll have to look.
Yeah.
Or,
All those things.
We're at 2,751
Yes.
meters with a temperature of
Maybe chemistry.
1.81.
I assume it's biology.
Okay. Only for this one.
Giant tadpole. Onto rat tail.
There it goes.
Okay.
Skin on fire.
Great. Thank you. Can we just zoom in on the orange stuff before we core?
Sure.
Looking like sponge, doesn't it? Isn't it? What do you guys think? Sponge? The orange? Yeah. It's just a guess. Could be tunicate or something else. It could be bacteria, but I sort of don't think it is.
Welcome, Adam. Welcome, Sonia.
Okay, what we wanted to do was one push core over these structures, the xenophile floors. I don't think it's bacteria. It's very, very dense, thick, globular. But
I did mine with Mary.
Okay, what do you want?
So these things.
Okay, so everything in this is he did that.
No, he's not.
I use that to make sure you're not touching.
So, so you want it there? You want to heat down there?
You can put that one over there too, I think that camera.
Can you zoom out a little
You
bit?
can get rid of that camera. Put that over there as well.
so we have a changing of the pilot watch with Sunny and Alex discussing where to put the different camera images.
They're fighting about it.
Come off a little bit.
So this will be our test core. Look at how the sediments are, but we'd like to try to get a xenobiophore at the same time. And this will go to Pachi. Yeah, so if you can just core over a nice one that looks kind of intact. Do you?
Just point where.
Is this okay, Pachi, or you want without the orange?
No, it's okay.
Here?
Hold the sponge.
Looks nice and coreable.
Yes.
All right, so good.
Erin, background course here?
I'm pretty sure, as long, those are definitely not bacteria, then yes.
Those are not bacteria.
Okay, then yeah, that'll be good.
All right.
I think this is another spot where we're gonna have to leave it out.
We don't have sage readings, but probably no methane.
No.
Jeff's on, so you can also ask him if he's okay with these background cores since he's on the chat.
Yeah, I just mixed it up.
Okay.
Yeah, this is good.
Do you care whether they're on or off xenophytophores?
I'd rather them not be, but
Okay,
if
that's
you
fine.
want to pick the xenophytophore off of one, I can, you can take one on it.
Okay, great, I'll take it.
Okay.
Okay, so we want 3 more
Okay.
cores, 1 on a xenophytophore and 2 off.
Just point to the screen.
These are the little structures, semi-spherical, half-sphere structures.
A lot more, leave it out.
No, it's good.
We've seen so few xenophytophores on this entire expedition. I was always wondering why they weren't around. They're definitely deep water organisms. So they're giant single-celled organisms. They're multinucleate, so it's cheating a little bit. They have multiple nuclei, but no cell walls. And so it's really just one cell. They're about the size of your fist, and they agglutinate sediments in these different forms. And not surprisingly, they act like little apartment houses for small animals. providing protection, refuge from predators, and also food. They trap organic matter. And so there are little hotspots of
You happy with that?
food hotspots as well.
Is that okay?
Yep. Is that okay with you, Aaron?
Yep, that works.
It's a very tubular genus. I'm not that familiar with this type, so I can't say what genus it is.
So when usually there's three after the test score. They take this one this year started.
Alright, yeah, sorry.
What? Not pinky? What do you mean?
Just
I put it both at the same time. Look, it's right there. It's right next to it.
so that's a small xeno. Probably a couple centimeters across.
What?
Yeah.
Thank you.
That was Sebastian processed from yesterday. So in the dive.
Okay, so
data.
two more, not on any of those structures, just on the plain sediment, please.
And ideally as close to the other one, number 6 as possible.
Okay.
Thank you.
I feel like we should try to collect the orange material maybe in this section. Or a quiver, but we're short on quivers, so we kind of need to keep them. Yeah.
Near it.
So near it, but not on a xeno, yeah.
Calculated.
You okay, Erin, with this spot?
Yes, that works. If you, yeah. We can avoid the fluffy stuff. I don't know what it's orange. No, the lumpy thing.
The lumpy stuff is
Just
xenos.
like that with our lasers, with the laser, those are the good spots, just make sure not to get.
Things are operating under that.
Yeah, that would work too. I mean, you gotta put you in.
That works.
Just as long as it's not like, you don't wanna get the mound where it's gonna destroy.
So I discovered xenophyophores very early in my career when I was researching seamounts, and they were all over the seamounts. I was studying animals that lived in sediments. And it turns out, if you take sediment cores on and off xenophyophores, you get really different animal densities. They tend to cluster in and under the xenophyophores. We did thorium-234 measurements on the sediments, which measure particle deposition rates, and we're able to show that there was like 3 to 4 times higher particle deposition in and under the xenophyophores than right next to them.
I need a pour shot.
Xenophyophores only live in the deep sea below about 400 meters, but they're found as deep as the Marianas Trench at 10,890 meters. So they have a huge, huge depth range with different species occurring in different places. What was that? Where did the sediment come from?
I flipped it all over the,
It's along the front of the porch.
Oh.
It's kind of pushed up.
We don't know how long xenophyophores live. Probably a long time if they're not disturbed. There have been some time-lapse photographs taken of xenophyophores in the deep North Atlantic that show they can build their tests very, very fast, however. I think when there's particles, suspended particle events, they pick up the particles and conform their tests over a matter of weeks. In other places, we've found brittle stars hanging out inside them, lots of small crustaceans, amphipods, isopods. They're used as reproduction sites by some of these small crustaceans. We've seen whole families in there. Do we know if nobody else needs background course, right? Davide probably doesn't.
It's good.
Mostly dug up, got some upside.
Excellent. 2 hours. That's nice. That was nice. You went to bed. You didn't watch it. We watched the reader show.
Gotta go straight
You
down.
went to bed, what?
Is that going to be okay, Erin?
Um,
It's a little bit tilted.
if it's possible to check it out and maybe make it like here, on the other side of where 6 was.
Yeah. Leave this in here. I shouldn't take that.
No, I got it looking for the surface next to it. I should come up with that size to the orange magic.
You guys are placing, you're carefully reset on this. So you're not gonna be building on it for a moment, right?
What does that
You
involve?
reset. Just wait. It's not affecting them at all.
No, it's, well, I'm not using it as right now.
Yeah.
Just using trims, so just turn off the,
Oh, okay.
yeah, okay, it's better now. But you, if you need to do something, we're good. Yeah, you're right.
Try to keep it as vertical as possible. I think that's what
Maybe,
I like
sorry,
about
maybe
the
just
last
back
one.
a hair, like here-ish, to avoid the substrate that is now settling.
Yep.
Perfect, thank you.
It's like we're pouring the laser.
Focus stays in the tube.
I just don't want to wait until.
Or when the sediment doesn't push down with it, and it's actually filling, you don't want those to just push over the core, or the plug in the bottom, over it, push it up a little. When you go push a little bit, it goes a little bit closer. Just keep picking.
Alex, I think the BBL's covered in mud.
Very likely.
We'll just keep an eye on that once we start going.
Is it not dropping out the way it should, like, it should, when we're on the sediment bottom?
Well, this sediment is pretty sinky.
Yeah.
And also, we had a lot of spring drops right through jumps, which we don't normally have.
Yeah, but how come it didn't just reject the TVL as a sensor though? Like, is it different when it's covered in mud versus when it's just too close?
I don't know.
Yeah.
I'm assuming because a range, if it's covered in mud, then it might be sending returns and it's expecting.
Yeah. What does it usually do? What does it usually look like when you sit on the bottom?
It's usually drops off, but sprint should not have like a 5 to 10 meter radius.
It should get, right, understood, because.
I think mostly it fell out. What do you think?
Yeah, it's gone.
So that's compromised because that quiver has,
So you can't use that for.
well, I'm gonna suggest that maybe we can take a xenophytophore and pop it in on top. Or some orange, with some orange stuff so that we just have a sample of it. Since we can't use that for any quiver for anything else. We'll just take the surface. Is that okay, Aaron, if
Yeah.
we just collect that right now,
Yeah.
since he's got that?
I think that's perfect.
Well, although he could put the, oh. So what we'd like to do is just use that core to sample the xenophytophore and some orange. Maybe you can get them both in the same core.
Okay, just scrape the,
Not to scrape, but just
Pour
core
it,
it
okay.
and then put it in the disturbed area. We'll just use the top. Let's see if we can find a place where there's some next to each other. Maybe right here. Can you reach that? Can't reach that. Can you reach that one over there?
I mean, we can reach anything we'd have to.
Okay. Well, we need another, all right, let's just take Aaron's core. And let me think about this. We have to have a free quib, another free quiver. How about right here? Can you get the orange and the xeno in together? Just to sample them. The orange blob.
Right here looks like there's a lot of gold.
What?
Right here seems to have a lot of gold.
Right here.
If that's your goal, or if you're going for the xenophore.
We're going for orange
Yeah.
and xeno. So he'd have to put it over the side right here to get both. It's mainly orange.
Yeah, switch to the left just a little sunny to get both of them. Just, you're in the right spot, just to make sure to get the spongy looking lump as well as the orange.
It's fine if it's short. I don't know if it's gonna stay in though. It's
Don't
okay,
put it over
just
the
put
red
it,
one.
it's okay, just put it in. It's not, it doesn't have to be undisturbed because it's going in
Don't
the
get it over the
disturbed
red.
spot,
I
right?
was trying to advise it not to go over your red quiver.
Yeah.
Because then it would contaminate both.
Right. We'll see if there's anything, but. Erin, do you want us to push in another core before we collect 8, or collect 8?
Maybe we just start with collecting 8 in case it also starts telling you.
Okay. No. Background for Marlo. No, not yours, and not,
Not mine.
not his seat
Okay.
course, and not Jorge's, and not David's. Yeah, but we had one fail, so we are trying to get the organisms, so. Paula, do you think you could recover one of the close-ups of the xenos of the sea log and send it to me? Or send it to a expert to get a name.
Where does it go?
From earlier in the night.
Of the xenophilus?
When it was filling the screen. Of course. That's very good, thank you. So can we, Erin, I'm gonna suggest taking a core a little bit further away, because I think what's happening is there's a lot of water exchange underground from all this coring.
Yeah, this one's good.
And that one was really good, so maybe just a little beyond it or something like that. Someplace undisturbed and not on a xenophile for one more core.
Give you more porch if you want, since we're gonna reach out further. Nope. So have you turned him about to see that now? Can DV out this one on it?
So we're taking background cores right now for the microbiologists who will be comparing this hopefully to cores from active seep sediments.
We turned it on, zero positioning, which means we tell it to run the UV on.
So yes.
Yes.
We call this habitat background, but it's only background relative to the seep. If one was looking for xenophyophore habitat, this would be it, and everything outside it would be background.
If you could, sorry, if you could go a little to the left, just to be closer to the others were taken. Like, to the left. Yeah, right there. Thank you.
So for the record, we're gonna be short one push core because of that disturbed one. I'm not sure where it's gonna come from, but. Thank you.
Anything else?
You know, I'm sort of tempted not to section. I think we got a piece of sponge in the push core, so I don't think we need to section here. But we would like to proceed to the, I guess those double bubble points. Yeah.
Did you wanna just go slow on the seabed? or-
Yeah, slow on the seabed and let's zoom in and see what these black creatures are. Probably sea cucumbers, but they could be something else.
I think we'll be going in the current, but we're gonna be dropping mud for a while, just here. Where stuff like.
Hopefully it'll flow
Yeah,
behind
it-
us.
It should, but if it's like stop quick or something, it'll stir up.
Okay.
So I'll try to just keep us in the-
We have a lot of mud on the porch right now from the core that fell out.
Well, it's from when we push the porch in and out.
Oh.
And laying on seabed like this, it just sticks. It's migrating.
Sticky mud.
Yeah.
It'd be great to zoom in and see what these dark objects are.
Yeah, I don't have to go out. Might be worth just zooming around, try to clear it off.
Just stay like kind of far away. When I zoom in.
Doesn't look like a sea cucumber. Maybe an anemone. Or a jellyfish sitting on the bottom. Is that possible?
Yeah.
A benthic jellyfish? Is that possible?
Looks like a
A Paralia. In sleep mode. Maybe they go to the bottom to sleep. Interesting. Okay, let's grab a photo once the camera settles down and document. That's good. Can we get that picture?
So just kind of.
Clearly alive and moving. Wonder if they eat xenophytophores.
Yeah. I don't know what the word is, but definitely more confident it's a sponge. This has a little hole in the middle.
Yeah,
I don't know
could
what
be
it's called.
sponge or tunicate.
Oh, tunicate's what it's Ooh.
Yeah, those are fecal pellets of usually a deposit feeder would make those underground. Lots of fecal pellets right here in front of us in this picture. The grayish.
See, that looks really cool to me. That's a thing. Terrifying thing.
Well, if this is a Paralia feeding on the bottom, it's a great example of benthopelagic coupling where the nutrients from the seafloor will be carried up and probably excreted into the water column. Okay, I think we're good. You guys got the photo. We can continue.
I'm gonna.
Looks like there's a few of these out here, but maybe there are other things.
Do you wanna take a look at these ones specifically? The group of them, or just, do you wanna get close to all of them, or just?
Of these?
Yeah.
Well, there's one moving across the seafloor. I don't know if it's the same thing. I think it's just an interesting behavioral observation. Yeah. Okay, let's keep going
Well, this one
towards,
just flew off the seabed, the one you're pointing at.
yeah.
Thank you.
But I don't want to take us off our track, so.
I do.
Yeah. There we go.
Yeah, these are some form of Borrelia or something related, which are jellyfish. We have them in California too. This is a different kind though. That's not maybe, I don't know if it's the same thing. Actually.
No? Yes. What's it looking?
Beautiful. I don't know if this, it's fine. We have to go find bubbles. Got rid of our silk.
Do we just have it?
So we're just going up to shake off. Sea shower.
It's making us heavy, so I'm gonna move our stuff off the seabed. So just
We don't have a way to shake the ROV though. Get
that'd be
it.
great.
Dogs are so good at it.
I know.
So you can see in the M3 all of the sediment that's coming off of you.
Bubble plume.
Yes.
Sediment plumes.
Yeah. We can make our own bubble plumes.
We don't need.
It's a sediment plume, not a bubble plume. We are also contributing to transfer of material from the seafloor to the water column.
Circle of life. We're still full. We'll keep
Is that what
alive.
you need to speak to now?
You're into over 45 degrees. What?
We're lighter.
Yeah, that's fine.
What's our distance from the gusher?
We are 210 meters away.
Okay, so we got a bit of a trek. It'll be interesting to see if the xenophyophores cover the entire seafloor here. There's certainly a lot of them. I would call them dominant and
45.
whatever that sponge is,
So fast
or
as what?
tunicate. There's a lot of that too.
I don't really know. I think our train is being generally 0.4, but I'm sure they've gone like 0.6. Alex, what's the fastest you've ever flown to that?
So these are sea cucumbers, different from the jelly we were seeing. It's a big, long purple one.
Yeah, a few knots.
I'm guessing Greg knows what it is.
Yeah, probably not more than 2.
Okay, we have a request for the clear one. I assume the clear sea cucumber. I'm not. Is that, did we pass the pelagic one? Is that?
Next to the purple one, there was a white thing, and I did not know what it was, but
Oh.
I think it's what.
Okay, I didn't see it. There's more jellies near the bottom.
Might be that thing over on the left.
What is that?
Can we zoom in here, please? Could we slow down and just zoom in and see if this is what he wanted or not?
I mean, the translucent white blobs don't make a biologist. They look similar. Okay.
What?
What are we looking at? I'm gonna guess it is a sea cucumber, but okay, Greg, let's see if this is what you wanted. Did this look like the other thing we went over or not?
A bit of a different shape, but same color and like translucency.
Looks like it's on a xenobiophore. You guys got a picture, right?
Yeah.
Maybe we can, I think there's two of them, unless this is one thing. How big, can we tell how big is it? Would it fit in this section?
15.
Greg thinks it's an egg case. Pretty big eggs. I was gonna say the eggs are probably 3 centimeters across in there, if those are eggs. Eulohia wants the isopod, so if that's an isopod on top, which I doubt, but how can we collect this? Do you think it'll? So are we looking down on it
Yeah.
here? And what, I can't reconcile what we're seeing in the two images. This is the side, and the structure curves around like that.
Yeah.
So how are we seeing a hole on the top?
Because what you're seeing here, it's kind of curving like this towards you, and it's going around.
Shaped like a nuclear power plant cooling tower.
Yeah.
With a hole in one
Okay.
side.
Okay.
It's not really clear enough, thank you.
I mean, that's in shape.
Do you think this is something we can suction up? No. We could put it in a bio box if you think you can pick it up. This is the isopod that Eulohia wanted, I think, creeping up right next to us. That we can suck up.
I don't know that you can reach any table. Yeah, I got to come forward.
Zoom out to your camera.
Oh, look at that, yeah. It's been a big morning for me.
I just didn't.
Okay, now I see how it looks like an egg case. It was a pretty deceptive view we had.
Always use all your cameras.
What you're referring to?
To give you different perspectives.
Oh, right. I was like, what am I about to hit?
No, it's included.
It's like, oh, no, it doesn't make sense.
Might be some clams down there. Little white shells.
Yeah, set up.
Strawberry wrap?
Yeah, Craig thinks it's an egg case. It's some kind of egg case. It's a kind of egg case. Cookie mollusk. Gigantic.
The eggs are like that.
What's the mollusk? Skate.
No, skate egg cases don't look like that. I don't think.
Can we take it in sequence?
We're gonna try to collect it with the grab and put it in a bio box. I don't know another way.
That's a swimmer.
Where? Up here?
Oh, going on. Look, we saw a lot on the way down. We'll get them tonight.
There's gonna be a lot of interesting things on the way. I wanna see the bubbles.
Ready for this air?
Oh, you're gonna section, what, okay, we were gonna try to are you
You
gonna
said
get
you
the
want
isopod?
isopod,
Yeah,
yeah.
okay, we'll get the isopod.
What jar are we
And,
doing?
3 or 4 maybe? And then we wanna pick up the egg case. The bio box.
Just zoom in on the,
So-
see the crowd. And,
You can still barely see it there.
Where is the isopod?
It's right behind
We'll take some sponge as well, once, after you get the isopod in there, it'd be good to get a piece of orange stuff.
it.
Did he go in?
See if he makes it.
Could you collect a little bit of orange material for us?
he's in the go.
I think so, yeah. That one's the soap leaves.
I think you got that. Thank you. So that's section number 3.
Did you want more of the orange? Or just the-
Maybe one more piece would be good. Thank you. So you guys got that, section 3?
Yeah, thank you.
Isopod and potential sponge. So we think our shift's gonna stay on till one.
Rolling forward. Let's roll it forward.
To one. You could
One
take
before.
the-
So,
the-
yeah, we'll just do the lunch,
Trying to get.
lunch break.
Doesn't-
You guys okay staying till one?
Shifts are shifting.
Shift until one is one.
Not in that function.
So
You want to section off?
somebody will relieve.
Next.
I provided my signature.
And I'll
for the lunch.
Yeah, I might swap that with Peter earlier because I have a lot of stuff to do.
Yeah, it is.
Is there anything that you
Yeah, you can-
if each one sends a group chat and next one sends me.
Zoom in on the call camera.
Those look like really large eggs. If it's a mollusk, it must be a big one.
Yeah. Could open 4B. Yeah, 4B.
Anything else? So we should be good. You want a picture of it before we put it in?
If it's precarious, no.
I don't think it's
I've been
very.
getting some anyways.
We-
What's that?
I've been getting photos along the way.
I think we're good. Hopefully it'll come up intact. Can get some more pictures. Definitely looks like an egg case with big, big eggs.
Yeah.
So 4B. We may also put other things in that container eventually.
Hey.
Okay, thank you.
You want to see spider?
Is there one? I think,
Right. On T4 arm right right there.
I'm gonna guess we don't
Okay.
need it. We've seen a lot of them on this trip and collected quite a few. I love these xenophyophores. Very
So we'll push
abundant.
that down.
You wanna zoom in and just see if that's another bunch of Paralia? Looks like it. Another seafloor jellyfish. Neat. Hmm. I've seen a lot of Paralia, but never seen them. And I've also seen them touch the seafloor, but I've never seen them lie down like that.
In the Caribbean, we have an anemone that's called the upside down jellyfish because it likes to have this tentacle upside down. But this one is with the tentacles
It's
down.
right side up, but on the seafloor.
That's so interesting.
On land, when cows lie down, it means it's gonna rain. What do you think it means when jellyfish lie down?
In this case, it meant it did rain this morning.
Maybe.
What? Yeah.
It would be my dream picture.
Sweet.
What's happening?
There's just a different background. And you're gonna geotag. I'm just waiting.
We're ready to go. This is one of the more dense xenophyophore patches I've seen. We find them really abundantly in calderas on seamounts and on the bases of continental rises. There's quite a lot here. They all look to be one species.
This is another one of those white.
Could be a reticulamina. I'm not sure. Oh, this might be the white
This is the thing we saw
thing that
before.
Greg wanted us to collect. So how about this one? Do you think it can be sectioned
I mean,
without clogging, or
if it's soft,
do we put it in a coral quiver?
what's
Or
it-
we could put it in the bio box with the egg case if you can pick it up, but it might be slippery.
Are they, how delicate are they?
Don't know. But it looks like not a scotoplanes, I don't think. I've seen these bright yellow. Oh, it's a sea. I guess it's a sea pig, but really big. It might be a different species than we've seen. I'm almost thinking you'll have to suction it and then drop it into the, like just pick it up gently with the end of the suction and drop it into the bio box, because
It's evasive or it's just delicate?
it's slippery and, well, try it, pick it up, see if it'll pick. Could you put the lasers on it, please? And will allow us to get a photo first. Okay. Okay, frame grab that, please. Okay. Oh, they're asking for a close-up. Maybe we can zoom in a little bit more. Definitely a sea pig of some sort. Penny agony. Oh, it is a penny agony, okay. So these can swim. So they do swim away. Okay, I think we're good. You guys got pictures, right? Gotcha. Surprise. See, he's trying to swim. Oh. Put it in the same box as the egg case, please. That would be 4B. And we'll have to make sure he doesn't swim out before we get the box closed. Just think of all the alien abduction stories this penny agony family is going to tell. It's like a big claw came and grabbed me from above. Uh-oh.
So once you let it go, carefully get out of the box.
Close it, close it, close it, close it, close it.
Okay.
It's swimming to A now.
Close it, close it.
No, I don't want to
Yeah,
cut it
but
now.
he went in A.
It's maybe
If you close it too fast, it'll just push it right out.
Yeah, yeah. Gotcha, good job.
But it is an A, not B, so.
I'm gonna consider A still available for other things, but I don't know, we can't devote an entire biobox to that petty agony. We'll see what we need.
You ready to keep going?
Yes, please. Okay, hopefully we're not gonna see too many more things we need to collect, so we can make our way to bubbles. Methane. And hopefully methane seep communities. Paula, did you send me a picture of the,
Yes.
you know, is it?
Let me know if it's a good one.
Is it on WhatsApp or?
Oh, yeah, what's up?
There we go, okay. Thank you.
Bridger, are the waypoint?
Copy that.
Touching screen, see that?
Coralia?
Is it just that server grant that it keep?
No, you're doing the
Actual
push
board.
pulls, the actual touch.
Yeah, we'll look at that, right, the starboard side.
I'm watching it on the TiVo account.
Yeah.
Just touch. You could probably find them now. I'll call it maybe.
No, it's heavy enough that I don't want it to just blow up the seabed, it's my concern. If we have to stop. Obviously, there's help from the right.
The reason those last two collections, the egg case and the Peniagony, went in the bio box is because they would have clogged our suction sampler. And we need it. And there's a nice large sea spider, Colossendes. Every so often we see the benthic Paralia. The Peniagony, when we collected it, there also can be pelagic, but that one clearly had been deposit feeding because there was a big fecal cast that came out of it. One interesting thing about xenophyophores, well, there's a couple interesting things. Greg and I found fish embryos inside, some from Costa Rica. So there were snailfish that were depositing their fertilized eggs into the base of the xenophyophore deep inside. A couple of snailfish species were doing this. So they can be fish habitat, fish nursery habitat. And in a couple of regional fisheries management organizations, this group, the xenophyophores, are designated as vulnerable marine species indicators. Okay, and speaking of indicators, we're starting to see some dead clamshells. That's a great sign that we're coming up on seepage. There's Acarax, the white shell with a dark fluted periostracum around it. That's another seep animal, although we haven't collected any here. We've seen these shells at a couple of seep sites. And these are vesicomyid clam shells, including the big species, Archivesica. Keep your eyes peeled, folks, for bubbles, carbonates, clams, tube worms. One of the seep species we haven't seen at all on this expedition are mussels. They form dense beds at some methane seeps, like in the Gulf of Mexico, but we haven't seen, and off Costa Rica, but we haven't seen any here. Oop, coral. Could we zoom in really quickly on that coral, please? An octocoral, I guess.
Is that wood? Wood?
I think it's an octocoral, but could we like
The
zoom in?
substrate.
Oh, the substrate. Is it carbonate? I don't think so. We need our coral lady, Anna, to tell us if this is something of interest.
Yeah.
Can we look also at these whites? See if they're monoplacophorans or something interesting like that. Anemones or zoanthids, I'm not sure what they are. Could we go over to the side just really fast and take a look at these guys? Monoplacophorans are little limpet-like mollusks, but they're interesting because they have paired gills, and so it makes them, well, there's some terabellid tentacles that we're looking at. Let's take a look at the down here. Yeah. Sometimes they're transparent enough to see through them. I don't know if those are hard to tell what they are. Maybe not monoplecophorans. Okay, thank you. Let's find out from Anna if there's interest in this coral.
No.
Beautiful. How many tentacles? 1, 2, 3, 4, 5, 6. I think it's an octocoral.
Yeah, it has one.
But I don't know if it's one she has.
No, here. No sample?
What?
Sample.
No sample. Okay, we don't want a sample. Just checking. Beautiful.
That looks like a background bird.
Little amphipod there. Okay, we can continue. She does not want one. So this is a promising sign. Dead clamshells mean that there has been seepage here. Normally, xenophyophores avoid the most sulfidic parts of methane seeps, as far as I can tell. I feel like you should use these clamshells for your white balance. Brighter white than anything else we see. Okay, can we zoom in here just in case there's some living clams? So we're still quite a ways from the bubble spot, I guess.
50 meters.
50 meters? These still mostly, these look pretty dead. Yep, just more abundant. There's a few in living position, like those right here. When the clams are inserted half in and half out of the sediment, they have a higher chance of being alive. These also look like they have sea anemones on top. What is that? Is that a small octopus or something? Oh, a xenoturbella? Greg? Yep, xenoturbellas. All right, I'm pretty sure he's going to want to collect these lovely creatures. There's maybe 2 of them. So the question is, can they slurp? Be slurped. What do you think? Well, size-wise, will this fit through the suction? Or let me ask him how he wants them collected.
Yeah, if they're pretty compliant, then they'll look like a sock. I assume they feel like a sock.
Yes, well, it's a dirty sock, dirty dead sock.
I accidentally dropped my crusty little sock.
Yeah, go ahead.
There are some live clams here
Pause
as
here,
well.
move for a minute, come down on stuff.
Yeah, copy that. I'll start copying that.
Thank you.
How do you want? They're big. How do you, do we need clams also? You're here, I can just ask.
Clams are
probably the same as yesterday.
Probably.
You get one or two and the xenos slurp them.
Slurp.
They slurp them.
Okay, let's
Ge-
slurp the
gentle slurp,
xenos. The xenoturbellas, not the xenos. This is a xeno day.
Yeah.
We got two kinds of xenos. Xeno means foreign in Greek, I believe.
And turbella is one. So
Turbella is
trained
worm.
worms, and they are.
And xenophyophore means bearer of foreign bodies.
Wow.
So we got lots of xenos. We'll call it the Xeno Day, November 1. I think we can use a coarse jar. So 5 through 8. Are we on 5 now? That would be fine.
Do you want us to stop and put some cool light on this?
Do you need more close-ups, Greg, of this?
Would be good.
Okay, so before we slurp, can we do some camera work with and without the laser?
You can see if they're male or female. The body shows the eggs.
I assume this is one also. Yeah, just folded.
Yeah, I don't know why they fold up like that. We used to think it was the ROV blowing around.
It's their defensive posture.
So the head is to the left.
This is the head? Okay, we're being told the head is to the left and
That's female. You can see the legs through the body.
And
The
the-
white kind of patches.
down here. Female has gonads with eggs.
associated with it.
Xenoturbella?
Don't say that.
This is a xenoturbella,
Very good.
but very big
Remember
and
that
wide.
Gulf, California?
Right.
Oh.
One of nature's weirder creatures.
Xenoturbella alert.
There's only 5 species.
In the world.
This could be the same one as Mexico, but we'll see. Okay, how about the other one? Doesn't give you a good sense of their normal posture. Probably see
That one
others
has
later.
eggs also.
Yeah, there's another one. Again, the head's there to the right, and then they have this ridge. Okay, that's great. And we think they eat plants somehow.
That's the pre-related coffee, the other one.
Yeah.
They've got
That's
plant
interesting.
DNA in them.
They do, in the
Yeah,
gut.
when we sequence them, we get plant. It's tricky to get the xeno, but they've got this little funny mouth, and I think they eat clam mucus.
Have fun with it.
So we want to sidelight it like this.
Hey, Greg, let's see. A Nemeridian?
Oh, yeah. That's cool. That could be the same.
Pretty busy sediment down there. Okay, so you can get that guy too.
Yeah.
But the Xenos turbellas are the priority. We have to hope we don't clog up the suction. Oh, it should be fine. Looks like a good size.
That's just the way it moves.
That was-
I love the sound effects.
I don't think they're
You want to get the little guy?
Are
Yeah.
they like leathery?
That's why it's the beach. That's the noise.
I remember that's the experience.
His fingers on
Wildlife
the
humor.
pulse.
There it goes.
Oh, okay. I was going to say, how do they
When we want them to get-
Zoom in, just sit down on it.
Oh, we did see one.
Oh, no, it wasn't. It was one of those big purple seeping ones.
Right.
Was that the one that sock
Something.
Have any of them come through?
Yeah.
The first one did?
I got more shots on this, but it was like very like random. You would just put and then something. We did it like.
There it is, this next one. Okay, great.
When I pointed like, it seemed like
I think we want to pick up
it's just hard to film.
one or two clams. Greg, no problem putting the
Yeah, yeah.
clams in the bio box, right, with all the other things we've been picking up. Are we,
We fitted two in a quiver, but if we want to hold it.
I want to keep quivers, and I'm just, the only problem is if the Peniagony's gonna swim,
Maybe
but
it's settled down.
but
We should try and put something in there.
we need to
And
be
if it
able to
gets-
put other stuff
if
in
it
there.
gets away, it gets away.
But Jim was like,
I'm hoping now it's just settled.
Or is it your box?
Yeah, we need the box.
I know.
Usually it helps bring it onto the.
No.
How about one clam? I honestly, I think it's the same thing. One clam is
We're
good.
talking about Sonar.
One clam that's live, like with a foot sticking out, or, yeah, a siphon sticking out, I should say. Yeah, that's a good one. Hopefully not too much without so much sediment, because you could shake off the sediment, and we're gonna put it with the APS. Possible.
But it's only the full species.
See what that clam has. Polychaete tube attached. I'm not sure which polychaete that would be. Maybe a terabellid, maybe a capitellid. We'll be fast so the Peniagony doesn't.
I'm interested, yeah. Going into four.
Yeah.
So I'm gonna look
Oh,
at
I
one.
saw the lady.
Yeah, I'll do that. Okay, opening.
So xenoturbellas are hang out around clam beds at methane seeps. Greg Rouse is the world's expert on these. As he says, there's only 5 known species in the world, and I'm going to guess he's described them all. And apparently they eat clams. We're collecting one more big vesicomyia just to see whether it's the same species that we saw yesterday at 2,200 meters. These are big clams. No, one's going to be fine. Thank you. We can continue towards bubbles. It's interesting that we have xenophyophores coexisting with living clams here. I don't see that very often.
Anything else you'd like to see?
No, I think we're fine. It's possible that these aren't xenophytophores and that there's some sort of worm that builds a tube complex above the bottom, because we definitely are seeing a lot of tubular structures there. But we've collected some, so hopefully we'll be able to figure this out. There's some black sediment patches. That's a good sign. Probably means there's sulfidic sediments down there. Something's underground. Some mound builders and burrowers have been pulling it up. There are azinid shrimp related to ghost shrimp that burrow and make little sediment volcano features on at hydrothermal vents and methane seeps. Could be what we just passed over. These clams look really healthy. Nice big patches of living clams. There's another xenoturbella. A couple more. Look at them all. That's nice. Makes me feel good that we didn't take the only ones. Definitely they're common here. How far?
I also
Getting pretty close to where the gusher should be.
Really?
I've gone up to the ship short because you've been sitting here. So you just sort of forever.
No, I'm just
It's bedtime for you. Get ready.
Okay, we've got to find bubbles.
You don't blow up this one. Oh, you're right. Never mind.
Yeah, I see it. It's gonna be that shadow.
Okay,
Pretty
we're
sure.
headed right for it, right?
The one to the right.
I see star down there.
This might
What is
you can
that
also always
fish?
pop to 5 meters.
No, Sage Scott said we have to go this direction.
Sage Scott.
Okay, straight ahead.
Sage Scott. Look at this fish.
Once a sage, always a sage.
There's really only one clam species here, the big one, and they look really happy, all sitting up. This is a very large clam bed.
Oh, that's probably that mound to the left.
Yeah, can we just scan? Oh, bacteria. Let's scan over and look at this mound. I feel like beautiful. It's an isopod.
That was for you.
What was for me? Oh, the monopsin flyby.
Looking up.
Got here, yeah.
Beautiful. Let's not, let's slow down, please. Take some photos here. Zoom in and see what all the little wormy things are on the bottom. Are they giant caprillid amphipods? You guys see the little white curly cute squiggles moving up and down? I think they're amphipods on the clams, which is really something new and different. Caprillid amphipods. Okay, can we zoom in? Let's do a little zooming around here, I guess. We'll want to check out what we have. Definitely have amphipods on the clams. We've seen them mostly on hydroids up to this point. Almost all the hydroids that live on tube worms have these coprolid amphipods, but I would say these guys are several times larger than the ones I've been seeing. There's a scale worm down there, the crevices. So what do we think the amphipods are eating? Maybe bacteria out of the water, or maybe bacteria on the clams. We'll try to get some really good close-up pictures once this clears.
John's busy.
So this looks like bacteria up in the water that we've kicked up, doesn't it? Filamentous orange bacteria. Various. Coprolid amphipods. On the, you could put that they're on the clams, right? On the large clams.
Bridge RV, you can move to the waypoint now.
Whoa, whoa, whoa. Oh, they're moving, not us, no. Right, so we'll want to try to get some close-up pictures of the clams with all their fauna. The gas hydrate's good. I think that's hydrate. It might just be bacteria on the.
The only thing I saw that looked like hydrate was lower down into the left, the more right part wasn't.
It was.
No, it was not.
It was not.
I don't.
So these could just be
That is on the right.
straight ahead right here. I'm sorry, but that looks like hydrate, doesn't it?
Yeah, that's
solid anyway, whatever it
You can
is.
see the bubbles on it.
And this. Beautiful. Guys, keep grabbing frames, please. All of these. Lovely. Looks very ethereal. An ice house made of methane.
He's so on it.
It's increased the ice, so you can't see through the silk as much, so it's
What's
like,
that?
it's just a
The,
matter.
the different lighting is really interesting because
We need
each
more
looks.
What would happen if they touched it? Would it be like ice?
It would explode.
That's not true.
That would be cool.
Okay. We're going to do a lot of photography before
I
we
wasn't
start
saying to touch it,
distributing.
I was asking
Yeah.
what would it? It would be
It's
cold.
frozen.
Lisa. Lisa,
Yes.
before catching, there's the skin also.
Why don't we do it now?
No, no. You wanna do now?
Yeah.
Yeah. Just before starting.
But I feel like anything more we're going to do is going to disturb a lot of.
Anything you wanna do?
This is going to be the least disturbed time. here.
Yeah.
So what we'd like a listening sample, please. And then we'll come back and do more photography. I still don't see the bubbles, but they must be around here somewhere. was down to
Sorry. That was me.
It would be Niska number 2. Yeah, went. Thank you. You guys got that? Good call, Anna. I think as soon as we start sampling or doing anything, we'll disturb it, so. Okay, can we zoom in on some of these dense clams just to get a really good picture of the fauna? Maybe with the crab in it. Yeah. And we'll get some. Frame grabbers, when you've got it, tell us. So we can, got it?
Yeah, you can see it on the map. To the bottom.
So that's good. They've got this for you. How, are we all the way zoomed? Can we zoom like any further? So some of the caprellids are on the mud, but most of them are on the clams.
A lot of carbonates.
Yes, lots. We'll try to suction them, I think. Everyone.
Many Chile people is watching the video.
You want to talk?
I used that out to see.
Do you want me to go to lunch? Did you have lunch?
Muy buenos días. Los saludo a Eulogio Soto, jefe científico de esta expedición, para comentar que nos encontramos estudiando una filtración de metano, un ecosistema de filtración de metano en el sector de Isla Mocha. Ha sido realmente un hallazgo muy interesante poder encontrarnos con este tipo de comunidad de organismos que se adaptan a estas condiciones extremas de presión, de temperatura, pero por sobre todo que habitan sedimentos reducidos en ocasiones con nula concentración de oxígeno y principalmente ayudados por la quimiosíntesis bacteriana que se alimenta del gas metano que encontramos en estos ambientes. Vemos también la presencia de rocas con hidratos de gas en estados que llegan al punto de congelación. Esas manchas blancas corresponden justamente a presencia de hidratos de gas y en torno a ellos esta comunidad de bivalvos, de almejas, y en torno a ellos también otros pequeños crustáceos, estos caprélidos, estos flaquitos blancos que se ven sobre ellos, también llamados comúnmente como mantis de mar, o fiuros, gusanos poliquetos. Pero también nos ha llamado mucho la atención la presencia de otros organismos como pepinos de mar y de un organismo muy extraño que es la cenoturbela, organismo que hoy en día no tiene una clasificación clara en la taxonomía del reino animal, que tiene una apariencia como si fuera un globo desinflado y que los hemos encontrado en este tipo de ecosistemas. Estamos ahora en la sala de control de la Ruby Sebastian. Estamos a 2.745 metros de profundidad y ha sido muy interesante poder ver esta comunidad de bivalvos que permite, que le da refugio, que le da hábitat y sustrato a organismos menores como estos caprélidos, crustáceos pequeños, o fiuros o estrellas frágiles, gusanos marinos y cangrejos también. Así que los dejamos para que disfruten las imágenes captadas desde el Falkor 2 buque oceanográfico del Schmidt Ocean Institute, y recordar que esta expedición, bueno, está formada por un grupo interdisciplinario de científicos tanto chilenos como extranjeros, que se ha liderado por la Universidad del Paraíso durante todo este crucero que comenzó el 11 de octubre en Valparaíso y que finaliza en unos días más en Puerto Montt. Entonces, interrumpimos para que la comunidad hispanoparlante pueda saber de qué se trata lo que estamos investigando hoy. Son ecosistemas distintos, no son los ecosistemas que generalmente la gente conoce. Hay ausencia de oxígeno y las comunidades se ayudan a través de gases como el metano. Por lo tanto, la vida que vemos acá sobre estos sedimentos es bastante interesante. Entonces dejamos a la doctora Lisa Levin, que está ahora dirigiendo las observaciones en la sala de control, para que siga con sus observaciones.
Oh, Sabella, maybe. There's one. So we're just panning around looking for the different types of faunal associations. There's definitely gammarid amphipods sitting. It's interesting. They're sitting in the bottom. I usually don't see that. And sabellid tubes. Where'd the bubble come from?
Sediment.
Did it? It might have come from,
Right this hole, maybe?
maybe where the sediment's falling down, maybe.
Hmm. There's the Acarax shell.
Oh, yes, there.
I don't think there's a living clam associated with this one, but that would be worth checking out also. The sabellid
bubbles.
tubes are interesting. Another bubble?
Yeah, but they are behind, like,
Behind it.
they are here.
Coming up
Lisa?
amongst the clams.
They're coming from that side.
The other side of the mound? Okay, well, we can take a trip around this mound and look, but I'm still fascinated by finding all the different kinds of animals that are living up here. We'll get to the bubbles. There's more sabellid tubes. I guess there's sabellids. Some buried in the mud. Look at all those caprellid amphipods. Very busy. I'm not sampling yet because we'll disturb everything and we won't see. Do you want me to start sampling now? Or? Well, we're just trying to look at this point to see what, and get pictures of everything. Can we zoom in on the scale worm, please? It's full zoom, okay. We can come back and try to get. Yes, there's another one we can just. I mean, do you, if you. I feel like we should look and then decide what to sample. Go all the way around, find the bubbles. Yeah. What's that back there? An octopus?
I don't know. Oh, a fish?
A fish, maybe.
Yeah.
Oh, is this whole thing a fish? No. What is this?
Oh, okay. Is that fish? What do you know?
Interesting.
But that one is alive.
Oh, that could be the acarax. This
Yeah.
is an acarax shell right here. I don't think acarax looks like that. Unless it's its foot. Maybe.
But looks like there is a fin. This one doesn't look a fin.
Well, I think it would become good to come back and sample. Can you show me where this view is on
You
there?
point right at it, almost right there.
It's right there.
Yes.
Okay. Acarax can get really, really large. We've seen huge ones in Costa Rica, so it could be that. Okay, that's great. I think my preference now is to just do a trip around the mound and see what's here, and we'll make a note that we might want to come back and sample that. So it looks like we have gas hydrate, lots of caprellids, definitely gammarid amphipods also sitting in the bottom. We have sabellid clusters, acarax, several. What's fascinating is how every single place we go looks different. This is different than yesterday's hydrate mound, even though some of the same clams, possibly the same clam species were there. The caprellids definitely were not. And these clams all look alive and happy for the most part. Let's zoom in and see what that is down here.
Oh, the fin.
Maybe a hagfish, something orange. There's another worm long version here on the other side.
Would you mind zooming in, Sonny?
We'll take a look at this and
On
this
the-
one.
Not on the locals, not on those, not on that. On those, the orange.
Yeah, it's no, could be a.
Ah, it's not a sea cucumber, it's a sea cucumber. It is a very new kind of sea cucumber, probably a seep one. Just a guess, since we haven't seen anything that looks like this. And there's two of them.
We making
But
those?
you guys, can you grab a frame of this, please, and write sea cucumbers? There's some sabellids, and there was one more of them up on the, just above. Actually, could we get a laser on it just really fast, so. Maybe push BBC highlights too.
Yes, please.
There's the lasers. Okay, please take one more frame grab with that, just so we have the size. That sea cucumber must be 25, 30 centimeters long, 25 maybe. Great. I think we're gonna wanna collect this also eventually, but if you could zoom up to the one above, there's another one sitting there. Oh, that's an acorn worm. That is an enterobnoost. At least I think they're still called enterobnoosts. And that's pretty cool because we generally don't see those associated with seeps either. Beautiful. Got a frame grab of that, guys. Could we just center it a little bit more so the tail is in the picture? I don't know. Wonderful. Beautiful. This seep is fascinating because it has a lot of taxa that we find out in the rest of the deep ocean, but I don't know if these are going to turn out to be seep specialists or not. Thank you. Okay, we can zoom out. Assuming you guys got good pictures of these. Let's continue. The bubbles are where? Are they near us? Right there, from under the rock, from a hole in the rock. I think before we take a gas type sample, we'll want to check around and see if there's more active bubble area, because based on the number of bubbles we saw in the water, they saw at 6:30 there should be a gusher somewhere.
Jeff
So
told me, he came in and told me that if we want to look for bubbles, he suggests coming a few meters off the seafloor and looking with the M3 and the forward-facing sonar.
okay, I would. So we can do that, but before we do that, I want to go all the way kind of around this mound.
Yeah, I'm not proposing
And,
that, I'm just saying if you're
yeah.
looking for the bubbles.
But could we mark this site, just spot as bubble? I don't know how precisely we can mark it, but we need to be able to remember to come back, how to come back to it if we.
This particular spot.
Oh, there's all the bubbles, right there.
Yeah.
We will collect,
Okay.
but not yet.
Okay.
Because otherwise we're gonna disturb everything, and we need the beautiful pictures of this site.
Because we don't have any
Acorn worms.
in any museum in Chile.
Okay, great. This might be the first one.
The first one.
There's bubbles. So just try to, we'll try to remember where everything is. That sea cucumber also, I think, is new. That
The orange one.
sea cucumber just below the acorn.
It's below, yeah. That,
Yeah,
The,
yeah.
the orange one.
Okay. Great. Yeah. And the acarax will be new.
Olutura.
Yeah, yes, yes, we'll get them and the acarax.
Yeah.
But this is gonna be important also. Get the gas sample.
Well, Caprelli, you already collected?
No, we haven't collected anything. I'm trying
After
to
that.
keep it good photography of everything.
Really nice habitat. Really nice.
Yeah, beautiful. And this is the main habitat, so we have all day to be here. And, yeah, it's the main place. That's beautiful imagery.
Sonny, you actually have control of the focus over there too.
BBC, are you here? Are they both at lunch? Or are they here?
And make comment about the bubbles.
They both here?
Yeah, here.
Yeah, yeah, go ahead.
Lo que están viendo ahora justamente son estas burbujas que salen desde el fondo marino, desde los sedimentos, que uno de los objetivos que tenemos en este crucero es poder detectar estas burbujas, emanaciones desde el fondo del mar de gas metano, y que justamente son estas burbujas las que nos permiten poder asociar muchas veces la presencia de estos ecosistemas quimiosintéticos. Para el grupo de geólogos a bordo también es muy importante poder recolectar algunas de ellas y después estudiarlas. Si se dan cuenta también, en torno a la zona donde se emiten estas burbujas, se ven sedimentos reducidos, lo que estaría indicando justamente presencia de gas metano. Claramente es muy interesante ver cómo estos pequeños crustáceos, estos flaquitos largos que son caprélidos, del grupo de los anfípodos, de los isópodos, se adaptan y toleran con facilidad o sin problemas la presencia de estas burbujas de gas metano. La misma situación ocurre con estos moluscos bivalvos que coexisten en este tipo de ambiente que para la gran mayoría de los organismos sería tóxico. También hemos observado gusanos marinos en este tipo de hábitat. Y bueno, nos ha también sorprendido la presencia de un grupo de Enteropneusta, estos torcuatórides, gusanos bellota, que son muy extraños, no existen antecedentes y a mi modo de entendimiento creo que no existe ningún ejemplar de gusano bellota de acorn worms, Balanoglossus, en los museos de Chile. Sería muy importante poder recolectarlo. El gusano que vimos hace un rato de color translúcido blanco con púrpura. Entonces, queríamos comentar esto de la presencia de estas burbujas importantes y que caracterizan este tipo de ecosistemas. Una parte importante también de la investigación es obtener muestras de estos sedimentos y estudiar la microbiología, las comunidades bacterianas que existen en este tipo de ambientes, cómo se adaptan, por ejemplo, a la presencia de estos gases. Hay un grupo de investigadores del grupo del Dr. Jeffrey Marlowe de la Universidad de Boston que justamente trabaja este tipo de sedimentos. Por su parte, el grupo de la Universidad del Paraíso también está muy interesado en recolectar la fauna. El grupo también de la doctora Alicia Levy, el doctor Greg Rose de la Universidad de California también están muy interesados en poder describir estos organismos. También hay un alto porcentaje de especies nuevas al ser organismos nunca antes estudiados y hábitats desconocidos que son explorados por primera vez. Los organismos recolectados sin duda tienen una alta probabilidad de ser especies nuevas para la ciencia. Recordar que la identificación de estos organismos, pasando por procesos moleculares y taxonomía clásica, puede demorar meses, incluso años. Por lo tanto, aquí también nos encontramos con hallazgos muy importantes para el conocimiento de la biología de estas comunidades que son por primera vez filmadas frente a Chile en nuestros fondos oceánicos. No teníamos la oportunidad de obtener estas imágenes y esta expedición a bordo de este barco norteamericano con altas capacidades tecnológicas nos ha permitido por primera vez obtener en directo y con mucha resolución y gran detalle estas imágenes que nos permiten conocer cómo es nuestro fondo marino, cómo son sus hábitats, cómo se adaptan los organismos y la diversidad, la alta diversidad que hay de formas distintas a las que comúnmente conocemos. Por ejemplo, vemos que los moluscos sacan sus sifones, seguramente están filtrando, lo que viene desde la columna de agua también deben estar filtrando metano. Muchos de estos bivalvos realizan quimiosíntesis bacteriana. Las bacterias se alimentan, obtienen la energía de este metano y justamente participan dentro del metabolismo de estas almejas. Nos llama mucho la atención la alta densidad de estos caprélidos, estas mantis religiosas blancas largas que están tal vez alimentándose o abasteciéndose de este gas para sus procesos también. Para el grupo acá de investigadores también ha sido muy asombroso poder encontrar este tipo de ecosistemas con organismos muy variados. Ha sido muy diverso y ha sido también ha generado mucha felicidad poder encontrar este ecosistema acá en la zona de Isla Mocha a 2.744 metros. Vamos a estar todo el día describiendo, observando, mapeando este sector, mostrando las diferentes características de los organismos, describiendo los metanos, los hidratos de metano, los diferentes hábitats que justamente denotan la presencia de emanaciones de este gas, forma de burbujas. El metano también se puede expresar de otras formas. Vemos que algunas rocas carbonatadas presentan estos hidratos en forma de hielo por la presión, por la baja temperatura.
No, no. You're gonna go to lunch?
Yeah.
Okay.
Buongiorno Ana. Bueno, dejo con ustedes al doctor Greg Rose de la Universidad de California, quien le corresponde su turno y estará comentando, bueno, en inglés lo que estamos observando. Yo por mi parte me voy a almorzar, pero yo tomo el turno de las 4 de la tarde y ahí también estaremos comentando en español lo que estamos observando y investigando hoy día.
All right. What's happening here?
Greg, I'm going.
You're going.
Please come back to and then stop.
And then chaos.
If you
Yeah.
want, there is a list.
Could we do a Niskin, please? Another Niskin.
Are you ready?
Yeah, thanks.
I hope you're going the wrong way. I just saw it extend. I've seen it much.
All right, hi everyone. Greg Rouse here, just taking over while people are having lunch. Lisa's on lunch. This very cool seep at 20, nearly 27, no, plus 2,700 meters, 2,744 meters. Wonderful clam field, gas bubbles, lots of weird fauna around it, microbial activity. Pretty exciting.
Can't see it going if you haven't done anything yet. You can see the rock moves really slow. That flag for number 2 has to come on.
Do you think it went up?
No, it hasn't gone.
Oh, no.
I just saw the flag.
Not even at 3 yet. Keep going. Keep going. Keep going. That's only a flag for 2. That's 3. There you
Okay.
go. Perfect.
Took its time. Well, I think the first, do we have to move if we wanted to get those bubbles?
Yes.
Okay. Could we move and, well, Huh, we'll have to sit
Right
on,
on top of these clams, but yes, we could.
would we have to sit on top of the worm then?
No, not on top of the worm, but we'll probably have to move up to where these clams are right here.
Yeah.
Straight in front of us, yeah.
Yeah.
think they'll recover.
Could we pan down? I just want to know if there's anything people wanted sampled here. Oh, there's the sea cucumber. So people want this. Okay, I think what we'll do
Ooh,
is...
that was cool.
Yeah.
Spit out. Cool.
Clearing out its valves.
Yeah. How are you gonna propose to take that suction?
Yeah, we can suction this
Wanna
creature
suction that guy first?
and this guy, if they
Okay.
could be reached. And
All right.
they could, we could put them in 5.
5?
They're all, actually this thing can be sticky. So we could put this one in 5, that'd be okay. This one we'll put in 6.
You want to put this one in 6?
Yeah, by itself. They're notoriously sticky.
I don't know if you can pick that up.
They can't, you have to put that out. You have to push the row out.
Yeah,
You
yeah.
can't just pick it up.
The worm.
You want to try push one?
Which one are we lined up with then?
6, the one in front of us.
Yeah. Could we get a nice close-up first? So this is a synaptid sea cucumber. They're often long and snaky, very soft. And they have little white spots there. Probably it's ossicles, little calcareous discs in the body wall. And its head is up and curved around to the right. You can see a tentacle or two. Okay, thanks, Doug. Maybe you could get that sea little scale worm there too. See that? That thing.
See that? The one just right underneath in between the...
It might be sticky. Let's see how it comes off. Oh, the worm should be okay. Nice.
Once it gets to the jar. I'm trying to move this clam out of the way. So the one's still with the plug.
So these synaptid sea cucumbers, they're the branch of the sea cucumber tree. That's the branch, and then there's all of the other sea cucumbers. So they're pretty interesting from an evolutionary point of view. They can reach 5 meters or longer. On coral reefs, you can see them draped along and among coral branches, looking like gigantic snakes. It's not too sticky. And nicely done. A few of the caprellids, the skeleton white shrimps, would be great here, thanks, Doug, with the same chamber.
There you go. It's in. It's in.
What are we
Nice.
looking for?
work right?
These white skeleton shrimps. Since we're here, might as well get them. These white
Indexing.
creatures are a kind of amphipod,
Same one?
which are, you might be familiar with as beach sandhoppers, or but these the body's elongated, and they have these hooked claws, legs at the front that are used to catch passing prey, so they feed on plankton. Unusual to see them hanging out on clams like this at a seep.
More?
No, that's good. Let's just look if there's anything else would be good for this chamber. Okay, let's go to, oh, there's a snail there, Doug. Sorry, that would be good. Can you reach it? Yeah.
Okay.
Nice. No, I think we can index that one. Thank you.
I haven't seen that snail going in yet. That's on 6. Is that
Yeah.
where you wanted it?
Yeah, 6 is good.
Okay.
There it goes. Okay, that's a good haul.
Alright, and then where do you want this guy?
We can go back to 5,
Okay.
and it'll be, they're super fragile.
Okay.
So the head end is to the right. If you can kind of lift that up with the nozzle, and then on gentle suction, the whole thing should come up. But there's a risk of it tearing, but
Nice and gentle.
yeah,
Nice.
nicely
Nice and
done.
easy.
Yeah, that's perfect.
Nice and easy. Just let it go nice and slow.
Roger.
It's already in the hose, so.
That's great. So the hemichordate's in number 5.
We already have something on number 5.
Correct. It's with the xenodevelopment.
Thank you.
Okay, and nothing more?
Shut it off so it doesn't smush it against the filter. A little bit more suction to get it in.
One more.
That was a torquatorid hemichordate acorn worm, and it's a deep sea group, and they can have a pretty elaborate heads. Colleagues of mine named one after Yoda from Star Wars. Its genus name is Yoda, and there's some, if you Google Yoda acorn worm, you'll see some pretty cool pictures.
Is that it? No.
That's the slime it was in. We're just looking at the chamber to see if it's come through.
I'll try for one more bar.
Alright.
Full bar slow.
There it is. Oh,
Nice one.
it's perfect.
Index.
Alright, awesome. Good job then.
complete.
4?
We could go back to 6, and there was another snail, and I think they'd like 2 of them.
Oh, you want, there's more suction in here? Okay.
We could just, one more thing for 6
Sure,
is
sure, no
the snail that's over here.
Okay. Oh, that's awesome.
That's on 6, right?
Yes, please.
Okay, suction halfway.
Nice.
Here you go, I think that's it.
Yes.
Yeah, okay. Off.
That was great. I think there are other things to suction, but we can do that after we move and get the bubbles.
Okay, where are we going next?
We were going to sample the bubbles, so yeah.
Would you like a push call actually near the bubbles? Near the bubbles?
So you probably have to hop up.
Push call near the
Just
bubbles?
put it right in the center.
As close.
Right in the center of your picture. So that we can grab the gas light.
But, again?
Why
So, yeah, see where the clams are. So you want to set like right on the edge of this clam bed here, so that all of the gray is right in front of us.
Here you go. Yep. Move it forward.
Should be good right about here, but just don't drift back when you're coming down, just try and stay ahead. Get yourself settled out there. Next thing is I'll have to know, get the gas turned down. What's that?
I'm gonna climb something down
You're
there.
all right. This is only this you can be. Okay. You can kind of hang out there, I just need to be able to see what the sit done.
Greg, are we ready to do this?
Yes, please.
Okay, what you on, Doug?
You hang tight.
You ready?
Yeah.
That's what we got.
Because we have to go to the bubbles. So it's still a film and so it's still- we can get them.
So, what's left on our list?
So it's-
Let's see, I'm gonna make a list on something. Give it to me, those right here. The rigor writing, snail or the worm. Worms, oh, there was an apparatus. These baskets look So are we doing the gas? Okay. Thank you.
Just tap it. Tap water. Get the little tug. I've seen things work like that.
Picks it up, it's gonna turn it over and it's gonna fall off. That's what you're asking. The nozzle?
No, I'm asking about the high temperature probe. But it's not working there. Minus 80. That's like a refrigerator.
I believe
Freezers. When you make this sample, just note that it's the purple tape.
It's dressed up for the
It's dressed-
seep.
That's right.
I like
It's
it.
got its black dress on, with purple
With
lining.
accents,
Yeah.
yeah, purple accents.
Luckily for the gas type program, one gas type per dive makes it very easy for samples. There's just one dive, one gas type,
Yeah.
one
Do you
location.
have to color them or no?
They are, all of the gas types we have are different color tape on to make sure we know which one's which, but
Got it.
after every dive, I just make a dive day and I put tape on it with the dive
Frozen.
number.
So tell me what you're gonna measure. Tell us what you're gonna measure on this gas
The total gas composition and isotopes,
of
methane,
carbon,
carbon isotopes.
just carbon.
Yeah, we can do helium measurements on it.
Helium
3, 4.
isotopes? Yeah.
Yeah.
So
This
the
is
carbon
to-
isotopes signature of the methane is gonna be very useful to us to
Yeah.
know what one of the N member is, N member signature for determining the food sources of all these animals. Do you expect it to be about minus 65 or 70?
I mean, I like higher.
Lower?
thermogenics
Lower?
always- Or
You mean lower? Or higher?
I want
Or you want it-
thermogenic, which would be like minus 20, right?
You want thermogenic?
I think thermogenic is always more interesting because it comes from depth for me.
Okay, so thermogenic be minus 40 or 35.
40,
Yeah.
Well, it's filling up fast.
Oh, yeah.
Easy.
This will be the
peasy.
record
That's
fill
on the mother load.
time.
Yeah, record fill.
Yeah.
Yeah.
We're
Wish they were all like this.
Tamara Bobberger from OSU and PMEL will be doing the measurements with Anson, who's coming on Lake 2. Excited about that.
Well, you'll have to share the isotope signatures with us.
That's the plan. Although we'll see when Tamara does those measurements in Zurich, she'll take those back maybe sometime next year.
Will you do C14?
Not on the gas.
Not on the gas. Maybe on the rock?
Are you
Scott do
That would be Scott.
Yeah. It would be really nice if we could get some rock here, but I haven't seen any loose ones so
Can we,
far.
let's get our, because we're almost ready. This is a good shot. Can we zoom in on the actuator when we're ready to push it to make sure we get a view of the O-ring? And once the actuator presses, you can push the button for the sample.
Say when,
I think it's ready.
Ready?
It's pretty full.
Okay.
Okay, pressing.
Let's keep it on here.
What gets pressed? I don't know how these work. Right there on the back.
That
end.
black actuator is going to push in on that metal. That's the trigger. And then
And it
that releases
closes
the
it?
valve. It's under vacuum. So then it will suck everything that's in the little tubing that goes from the funnel into the bottle, which is the long cylinder in the front.
And the,
Let's do it.
Keep going.
the material trapped in the funnel is released, right?
Keep going. It'll stop on its own. Huh?
More?
Keep going. Might need to turn it up a little bit.
It's moving slow.
Yeah.
More? Can I move anymore?
It's really slow.
Okay. If it's pushed in, if it's not moving anymore in, do you think it's done?
I think so.
So if you release or pull back on the actuator,
What number is it, Ben?
I think it's 1, 2, 5.
Which one? Quarter, starboard?
Port.
Okay. You can try retract and see if the,
yeah, and then we zoom in on where the O-ring is. We should see the O-ring back out.
Nope.
No, I don't think
Okay.
we pushed enough.
yeah, I don't think so either. Hang on, Ben. You said port 5, right?
Yep.
All right, try it now.
Cool.
Yeah, it's going now.
Did it move? Did the
Pushing. I can see it push.
Okay.
Try, no, push more.
Push more?
Yeah.
Pushing more.
Yeah. That's all you can push, man.
Yeah.
Think-
Okay. So release. Can you zoom in on where the black O-ring is? I think I see it moved. It moved
Yeah.
enough.
Okay.
Yeah.
Shh. Can you zoom in? Can you rotate this? Is this
No.
fixed? Okay. Can we take the side cam or
Okay.
just to zoom in? Let's see how much that O-ring. Yeah, that's moved.
good.
That's enough. Okay. Well, that, I mean, it's filling up so fast that I don't think we could get a great view of it. Like,
Okay.
actually suck it up.
I just wanted to make sure we gave it every
Yep.
possible opportunity.
Okay, did we get sample?
You got samples?
Okay. And flip it.
Well, don't you want a cool dramatic effect?
Yes. Cool dramatic effect.
You ready, Sophie?
I'm ready.
Now that's a bubble plume.
And ice.
That's ice.
That's an ice plume.
And ice.
That's an ice plume, yeah.
Nice, nice.
Okay, thank you.
Okay.
Before we go, can I get a zoom of clams and bubbles once you start it?
Yeah,
So
sure.
that's it
Record
for
the whole-
gas, but we will continue to record bubbles. Can you tell me something? Was each of those bubble, like the bubbles are spread out over here, are they each coming out a different hole in the rock?
I don't know. We saw on the M3 multiple streams.
Right, but in
Uh,
that one spot, it looked like there were
There could have
coming
been.
out of multiple holes.
I don't know. I didn't see. The M3 had it. It seemed as if the bubble plumes were coming from more spaced out than just right next to each other.
Okay, so you're thinking this is thermogenic methane?
Well, I don't know
You
yet.
don't know.
Maybe. Probably. It could be that the methane is biogenic, but that there's fluid dissociating the hydrate locally, which would mean it's probably biogenic methane, but thermogenic.
Should we try the
fluids.
temperature probe again? Or it's
It's
still broken?
Yeah.
Oh, that's a bummer.
But what's our?
What do you think? It's hanging now.
Do we have temperature
Happy with that?
in the CTD?
I think it's.
Where's fauna? Do we have the chart, the
Huh?
plot?
It might be.
On 20, see, yeah.
That's good.
There you go. That's okay. I appreciate you double checking. I don't want to drop it either.
If we can't have ice cream, we can have hydrate ice.
Oh, gosh. Yeah, that'd be a methane slushy.
That's good. That's what you had in the funnel.
Yeah, it was. Yeah, I just need some syrup on it now.
Yep. Shave ice, but
Yeah.
bubble ice.
Bubble ice.
Deep horizon,
Yeah.
you see those?
So don't go anywhere. We're going to want to take a look at all those tubes on the mud right below us.
That's all I can give you. That's all I can give you if you want. So. There was the 1.8 one there.
The 1.81.
Yeah.
I have
One of those columns was
Was
Don't shoulder and board and
that-
you're hitting a push core.
Yeah, there we go. Okay. I should learn how to read.
You got this far. You've done pretty well.
Clear.
Just let it go. Just keep going.
Keep going. So.
Okay, you're hitting again.
Last 5 minutes to
I do like the last half.
You're hitting push core hard. Yeah, I got it.
Plot or just numbers?
I can make a plot real quick.
No, that's okay. I'll take a look later, but it might be if they want to do. I'm guessing a CTD over the bubbles.
It's like consistently 1.8.
Well, spread. It's pretty. You know, it would be interesting if it had any little blips up here. That's the temp. Where the yellow?
The green.
Or the green?
Yeah, did I grab it? Yep.
So it's changed temperature a little bit. Yeah.
Is this the CTD?
I was gonna say, did we just find the same graph?
Yeah, it's on the
Oh,
Grafana
yeah.
on the Grafana dashboard. You can
So
just
that's
change
neat.
the window.
So how much has it gone up?
What is, well, the graph shows it's gone up
0.02.
but very, very small numbers, but it has.
We're looking now at the temperature on the ROV's CTD to see if there's any evidence of hydrothermal emission here.
That's these.
And there's a few spikes.
Very small.
Very, very tiny ones, so. Our temperature probe is non-functional, unfortunately, so otherwise we would stick it in the bubble holes and check. So Jeff, the source of hydrothermal, of warmer temperatures would just be that these fluids are so deeply
Yeah.
sourced that they're warmed by the inner part of the.
Yeah, there's geothermal gradient, you know, they're
Yeah.
warm from just being from at depth.
Yeah.
There's
We-
a lot of faults here. This is, you know, a very active margin. So it would be surprising if we could, if get indications of some
Right.
hydrothermal fluid flow.
So off Costa Rica, at a little shallower, at 1,800 meters, we have a definite hydrothermal seep where the fluids are conducted up by a subducting seamount.
Yeah.
And the Chile triple junction also has warm sediments of 12 degrees C when the ambient's about 4 or 3. So I hope they get the temperature fixed by the Chile triple junction leg.
Definitely.
Can we leave it like this or? Can we take a look at the worm tubes, please, that are in the mud right down here? We may want to sample those. They're really high densities of tubes, as you can see in the sediment on the rocks. There's a bunch there, there. These are probably amphorettids, polychaete tubes. More bubbles. Is this where we sampled? See what I mean about different holes for different bubbles?
Oh, wow, yeah.
They each come out of a different spot.
I'm,
Look at the ones that are
with this
stuck.
close, this is, from the M3, we'd see this as just one seep. 'Cause the-
Well, it is just one.
It's one bubble. in
But
each side.
it's just interesting how there must be several conduits
Yeah.
coming up. So I'm really interested in this tube bed on the left here.
Yeah.
We'll probably have
When
to
you get
section it.
If you need it, when you get it, if you want to go, if you're done exploring here, not right now, but when you do,
Mhm.
this is the next thing to look at.
That
This
mound.
is-
Do we have a waypoint
There's a
for it?
waypoint on the green sea for that one. And then when I process the M3 data, it looks like there's another mound here that we kind of half mapped. So
Okay.
this is where we are. There's this other feature that we have a waypoint at, and then to the northwest of that, there's another kind of deformed seafloor that looks like it's had something going on at it, but it
It's
didn't have any bubbles.
It's
up there.
gonna be a while because we have to core and
Yeah.
do a bunch of stuff here, so.
Only for, because I'm gonna probably go to bed in a little bit. Just
Okay.
those two are the
We'll go
most
look.
interesting things we've got outside. It didn't
Thank
seem
you.
to the southeast that there was anything
Okay.
on the seafloor.
Do we have a waypoint for that way far north one?
No, because I only saw it until when I processed the M3. I can give you one. I'll go
It might
grab
be
a
good
spot.
to
It's
get
not
one
this, is
for,
it?
No, that's the second one.
Okay.
It's up to the north. Zoom out again. To
Here.
northwest. That
Yeah.
thing. Jump a waypoint
are you,
there.
Hachi, what do you think about coring? I sort of want to suction in here, but what do you think about trying to core in here? It's
It
okay.
would be really cool to just.
Elohi will probably be happy with his cores there.
We could do that.
Um,
Oh yeah.
Did we decide what that big thing was? Do we know?
It's a congrio.
Is it? Who said that?
In there, it's just a fish.
Who said that?
Me. Truly the
It is
master of
it is a
biology.
fish, but which fish it is, I honestly don't know. It's an interesting looking one. There's an acroax shell behind it, but not alive. That looks like. But that might be what we were looking at under the acroax. Okay. Ben, using your judgment, is that field of worms tubes that this area over here, is that, oh, in this area, there are lots of them. Do these sediments look like they could be coreable to you? And
One way
Doug.
to find out. Let's stick my
Let's
core in
do
there.
a science boat,
I'm gonna have to
Poke
go
it.
first.
or a science core, whatever.
So the ones on the rail are already out. I'll use those first so we don't disturb everything in front of us.
You think you'll reach it okay?
And reach what?
Inside the bubbles?
For a core? Yeah. I can reach
But
it.
wait, oh, you don't have to.
No,
well,
I'm not going to. I'm
you're
just
gonna poke.
seeing the distance.
They're definitely
Put a
close
core
to
in
the
there, yeah.
bubbles,
I think
so.
so.
The only problem is, Pachi, are you worried about having too much meth gas in the core there? No, but even to the side, are you worried about it or no? We can try and see. We don't have any spare cores now because we lost one. Sort of.
Last one?
We didn't lose it. we have a bad core that had the stuff fall out into the quiver.
Oh.
So we'll either take these or shake them out, but. And I'm really interested in the worms. And so we'll, you know, all those tubes that are there. So if you get them, you can give us some. Or we'll also probably suction after pouring. Amphoretid beds are a characteristic seep habitat. So
Okay, where
I'm
would you like to
thinking
try
that's-
and pour this?
Anywhere in the sediment? Not on the clams, not by the not on the bubbles, and
So
not
here.
on the clams.
Right here where I got it lined up is good?
Yeah, it's good.
Here?
Yep.
Okay.
There's a nice paper by Andrew Thurber and co-authors on amphoretid beds in New Zealand that show them living off aerobic methane oxidizing bacteria. If sage were alive and reading, it would get some spikes, even more than it does already.
Okay. I don't know, is this the only one we're doing here?
We are going to do more, but I want to see if this sticks. So can you pull it up and stow it, please? Before we take more. Because Eulogio needs 5 cores. I'm just going to do his cores here.